Now, with HTML5, it's the latest standard in the HTML language, and a lot of the concepts that we're going to touch upon are going to be concepts that have followed HTML since its early beginnings and still carry forward even to this day. So HTML5 may be the latest standard, but we're not going to focus just solely on features that were added with the HTML5 specification. So you don't have to worry. You're not going to lose out on any sort of older HTML language that you're going to need to know in order to be an effective web developer. So first things first, what is HTML? HTML stands for Hypertext Markup Language. So hypertext actually stands for it signifies the HT part of the HTML, and then markup language, the ML portion. So along with CSS, which we'll touch upon in another course, CSS stands for Cascading Style Sheets, and JavaScript, which is the backbone of all web-based programming. HTML is the cornerstone technology used to create web pages. So you can think of a web page as a human body, and the human body gets its looks and feel, the color of its hair and the features of its body will come from CSS. So CSS can be thought of as almost like an artistic panel that you apply to your HTML web page. JavaScript is the functionality, the dynamic behavior of an HTML page. So when you hover over something and a pop-up box flies up, or you see squirrely animations on your HTML page when you click a button and you see something, something taking place like boxes moving around, that is all done with the JavaScript programming language. And then you have HTML. So HTML can be thought of as the actual skeleton of the web page. It is the main portion, the body. It holds everything together. So all three of the technologies are absolutely essential in order to be an effective web developer and understand how the actual World Wide Web works. What the initial features of HTML were, it was actually created by a guy named Tim Berners-Lee, who was a physicist at CERN in Switzerland, and he ended up, he was looking for a way to be able to share documents with other physicists at the CERN laboratory. So if you date all the way back to the 1980s, Tim Berners-Lee is actually the guy who is considered the father of the World Wide Web. Although what he was working on back then doesn't look anything remotely close to what we have now, he did build the cornerstone, or the beginning foundation, of what would later become the World Wide Web. So as we talked about before, HTML is considered the skeletal structure of an HTML web page, or any sort of web page for that matter. So it consists of tags. So each bone in your body that allows your body to function, to hold upright, like your ribs obviously protect the inner organs, your arms have certain bones in order to be able to flail about, and HTML can be thought of as the same thing. So if you think of it as like a bone structure, each bone is considered a tag. And everything in HTML is a tag. So there's different types of tags. In fact, we're going to see all kinds of different types of tags. And each tag does a specific thing that we'll look at later on. So everything in HTML are tags. Tags can also be known as elements. Sometimes you'll hear them referred to as DOM elements. And DOM stands for Document Object Model, which is basically just the structure of your HTML page. So they'll say when you manipulate the DOM, you've changed the structure of the HTML on your page. As we'll see in later tutorials, like in our JavaScript course, you can see that JavaScript can allow you to actually mutate and change the way the HTML is structured, which allows your page to then change in its presentation. But HTML by itself doesn't do that. You write HTML in a particular page using a code editor or something like that, and then the browser just renders the HTML based on the way it's structured. So browsers expect tags to be in a certain order and follow a hierarchy. So as we're going to look at the different types of elements in HTML, but you're going to see that there are certain rules that have to be applied. So HTML is very forgiving. You can write very sloppy HTML, but there are certain procedures that should be followed. So what are these procedures and who sets them? Well, HTML standards are set by the community. for the most part. Now, when HTML was first becoming popular, web browsers like Netscape and Internet Explorer, which was owned by Microsoft, and different companies owned different browsers, but the standards were kind of rogue. It was the Wild West of the web, where nobody was really following any certain criteria, and the companies that created the browsers essentially made the rules. And then you had certain developers that worked for different companies that would end up enforcing their own way of doing things, and ultimately you had a lot of confusion and just dysfunction within the community. So the companies, like I said, which own the browsers, they don't always follow the same rules, and in many cases the browser companies just set what the rules end up becoming. So it's really just a trial and error that gets us to where we are. But all that said, we now have an organization called the W3C, which oversees the HTML standard, and not just HTML5, but the HTML standard, overall. So the reason why is, like we talked about before, all the different companies were going rogue and setting their own standards, and we needed just a peaceful resolution to all of this. We needed an oversight committee that would end up being able to say, okay, HTML5 is the new specification, and this is how we're going to do things, this, and this. So if you want to do this, this is the rules you should follow. And if you don't follow those rules, then your browser is considered to be non-compliant. So you don't have to follow the rules, but if you don't, then you have an entire development community that is writing code in a way that may only work on your browser, or may not work at all on your browser because you're not following the rules. So for the most part, we just have a few major browsers out there. We have Firefox, Mozilla, or Mozilla Firefox, however you want to say that. We have Google's Chrome browser, we have Internet Explorer, and then Microsoft's new browser, which they call the Edge browser. And then we also have the Apple iOS Safari web browser. Now, believe it or not, a lot of these web browsers actually share similar engines as far as how they actually work and interpret HTML. But we'll talk about that at some later time. So we're going to go ahead and summarize this first video as HTML5 is the newest specification of HTML. So HTML goes all the way back to the early 90s. HTML can be considered the skeletal structure of a web page. It's used in conjunction with JavaScript and CSS, which we'll touch upon in other courses offered by hipstercode.com. The set of rules that HTML follows is governed by an organization called the W3C. And HTML is made up of tags called elements or DOM elements. And I also forgot to mention that another term that you may hear them called as is nodes, which is somewhat of an unusual name, but they can also be called DOM nodes or HTML nodes. So here I have JS Fiddle pulled up, and here's the actual URL and the link. So if you go to this URL after everything's said and done, you should actually see code inside of here. So the way this works here is you have four panels. You have this result panel, which is actually going to demonstrate everything that is put into the editor. Then you have the actual HTML section here. You have the JavaScript section. I'm going to try to zoom in so you guys can see a little bit better. That might be zoomed in a little too much. So here is HTML, JavaScript, CSS, and then the actual output result. So this is very beneficial in that we can just quickly write code and see the output, and we don't have to install anything on our machine. All we need is the actual browser on our computer. Now, as we talked about in the last module, HTML is used in conjunction with CSS and JavaScript in order to make desirable modern web pages. In this module, we're really just going to focus on HTML and not worry about these other portions here. So for that reason, I'm going to slide JavaScript down, and we're going to slide CSS up and try to minimize that as much as possible. So in this first video, let's talk about an HTML element, which we've talked about can also be called a DOM node or a HTML node or an HTML tag. HTML tags always go into these brackets, which are greater than, or really it's less than and greater than signs, and anything in between the two is the actual tag name. So this tag is an H1. H stands for header. So in HTML, there's actually all kinds of different headers. You can have headers that are header 1 all the way to a header 6. Header 1 is the main header, like a title to your page. Every web page should only have one HTML header tag, or H1 header tag. You can have multiple H2 tags, multiple H3 tags, H4, H5, H6, but you should only have one H1. That helps search engines like Google, when they're parsing your page, it uses tags in order to determine the relevancy of what the page it is that it's looking at, because it tries to figure out what your page is about, so that way it can return good search results to users based on your page's content. So it uses these tags, which are important. So we'll say our custom header. So if you'll notice in JS Fiddle, when we put H1 here, it actually gave us a separate H1 tag, which did it automatically. So this is actually called a text editor. So it's actually it knows what we're trying to do, and it helped us out by automatically typing this. But tags in HTML always have a closing tag. So for the most part, every tag you're gonna encounter is going to have a separate tag, which is its closing tag. And the only difference between the two is this / right here. So it's the same exact tag, but just the / and it signifies the end of that tag. So that way when the browser is parsing this, it knows, okay, everything in between these two is an H1. So let's go ahead and say run. And you can see this custom header is actually very big and it's bold. Now what if we did something like this, and well, actually let's go ahead and do an H2. And we'll call this second header. And if we click run again, you can see second header is smaller. So the browser knows there is a difference between an H1 and H2 and H3. Even though they're all header tags, they have different significance. This is smaller. So as you can see, there's a particular rule set that is looked at by the browser when it's determining how to display a header tag. Alright, so for right now we're just going to focus on the different types of elements that we have within HTML. So we've looked at the header. The next one we're going to look at is an actual link. And this is going to be, actually, it's called an anchor, which is really weird, but it stands for a link. So we all know about web pages that have links. You click here and it opens up a new page. So we'll say open a new page. And if I went in here and I actually put the HTTP address to hipstercode.com, and I say target equal blank, you can see that we have the start of the anchor tag and then the end. And when we run this here, you can see that the only thing that gets displayed as a link is anything between the brackets. So if I were to click on this link, it's going to open up Hipster Code into a separate window. Now the reason why it opened up in a separate window instead of opening up in this window that we currently had open is because we use something called an attribute. HTML tags allow attributes. Attributes can be, this is an attribute and this is an attribute. And what they are, they're just little arguments that we pass in. And an argument is really just it's a key and a value. So if you can think of it as a dictionary. When you look in a dictionary and you look up smart, you're going to see a picture of yourself, right? Or it's going to be, okay, look up smart, and then you're going to have a definition of what smart is. So that was kind of a joke, but you have a dictionary and there's a lookup key, and then you have the actual value. So this can be thought of as essentially the same thing, where you have this key, this href, and then the value is the web address to this new page that you want to open when somebody clicks on this element. The href, I know that stands for, well, it seems very, very weird if you're just getting started with HTML, but you'll get used to it. It's essentially the reference of, the reference to the page that you want to request. This target equal blank is another attribute, and just having any sort of blank, or this could be any value whatsoever, it tells the browser when you click on this, open it into a new window and not into the same window that you currently have open. So that's a very important thing. We have an element and then we have attributes. So let's look at a few other common tags that we're going to see. This is a paragraph tag. You're going to see these all the time. So when we run this, you can see that it's a nice little paragraph tag. So if we add two paragraphs together, you're going to see some separation. And by running this, JS Fiddle's taking a while. Alright, sorry about that. It looks like JS Fiddle had a little bit of a hiccup there. So you can see that we have two paragraph tags and there's a nice little paragraph separation. So a paragraph tag is a very important HTML element that you're going to see a lot. Alright, let's look at another very common HTML element that you're going to see a lot. And this is called the image, which is shortened to IMG. And if we look at hipster code and we in Google, you can right click with your mouse button and say inspect, and it pulls up this little panel down here. But by me being able to do this, I can actually do a quick copy and paste by searching for this image that is in here. So here's this image. I'm going to just copy the link address. And if I said image, and I want to tell it where on the World Wide Web does this image sit, like where is it stored? And we're going to use, once again, an attribute, which is called the source, and then we just point to the web address where this image can be found. So if we click run, you can see it's very, very big. So it's actually grabbing the entire humongous image on the server and it displays it right into the browser. Now, one of the funny things about this element, and in the previous or earlier in this video, I said that all elements have basically the same element name except for the ending it uses a /. Well, some elements don't require that you actually copy the exact element into the page. You just have to do the / and then the greater than sign. So see this image here? That is a shorthand that you can do with certain tags, not all tags. But the image is one of those tags that doesn't require you to actually do / image fully spelled out. So essentially I don't have to do this. I don't have to do that. I can just simply do that. And that's fine. So you're going to see that a lot. Another thing, let's go ahead and add some attributes to our image here, which we're going to say width and then equals, and this is going to be in, remember, make sure you do double quotes, and we'll just say 100, and then we'll say height equals 100. And if I click run, you can now see that the image is disproportionately laid out here because it's a wider rather than taller image. And for something like that, you would probably want to say, 200 width by 100 height. That's still a little bit off there, but you get the point. You can just adjust these values, these attributes within your HTML, and the browser knows how to render it. Alright, so for this demonstration, we're going to go back to JS Fiddle, and I'm just going to paste all this stuff at the top. In fact, I'm going to put in here, we'll just say inside of a header. No, I'm going to put it in a p tag. And the p tag, if you remember from the previous video, is a paragraph tag. And we'll say module 2. Okay, this one's going to be module 3. All right, so as you're following along, when you view this JS Fiddle here, you'll be able to see the different modules and what we touched upon in those modules in case you need to actually look at the code itself. Alright, so we've talked about attributes in the past, and the attributes are considered this href is an attribute, the target's an attribute, width and height on the image element is an attribute. one of the most important attributes that you can have in your HTML page is the ID. And the ID, and then the second most important would be the class name. So, and when you get into more complicated development with JavaScript and CSS, the ID and the class name becomes super important because you need to be able to identify where an element tag is. If you had a bunch of H5 element tags and you needed to identify just one of those H5s, how would you find the right one? Well, in order to find the right one, you might ask yourself, well, why do I need to find the right one? Well, what if you needed to actually change the color of the fourth ID or the fourth element, or of 5 on your page? Like, how do you find the fourth or the fifth, or an individual tag element that could be in a web page with literally hundreds or thousands of other elements? Like, how do you find it? Well, it's a common task that you need to find it, and you're going to find it using either an ID or a class name. So let's, without further ado, get into an attribute ID first. So here's one. We'll just do this in a bunch of H3 tags. So we'll say ID element 1. All right, so here is 3 elements. Now, if we add the ID, we can give it any sort of name that we want that has a valid name. So it can't start with, actually, typically what you want to do when you're giving an element a name is you want it to be descriptive. So you could say something like header 1. And by the way, this is a common tactic when you're actually giving names, that you should use camel case, or depending on whatever sort of development team you're working with, or whether you're working by yourself. But typically different teams have different ways of actually spelling out the attribute names that they want to use. But this particular one is called camel casing, and what that means is that the first name is all lowercase, and then any sort of subsequent word after the first word, the first letter is capitalized, making kind of the camel hump. And it can have more than one hump if it has more than one, more than 2 words then inside the ID name. So let's go ahead and give the other tags their own IDs as well. Now, here's a problem with this particular approach. Number one, this is considered invalid HTML because a HTML web page should only ever have one unique ID. Like, there should never be 2 elements that share the same ID name. That is considered invalid HTML, and it makes things very, very confusing. So anytime you're going to have an ID, the value needs to be unique. So this would be now unique if we went like this. So that way they each have their own name and there's no sharing of names. So an ID should always have its own unique name to associate it with. So if we look at the HTML here, like if I right click using the browser, you can see that they have ID H1. Now, when you get involved in CSS, and I'll give you a quick little CSS demonstration, but when we want to apply a color to a particular element, we associate the ID using the pound sign. So we could say pound header 1. And then this is a CSS example, but what we're going to do is we're going to change the element 1 to red using CSS. And this isn't a CSS tutorial, but this is the main reason why I was trying to tell you that in order to be able to differentiate the right element out of a pack of literally hundreds or thousands of elements, you use the ID, because the ID is unique. There's only going to be one ID with that name, and that's how you're going to be able to locate the element. Now you might be thinking, okay, I don't want to apply a style to every single element. Like what if I don't need to identify a specific element, but I just need a specific group? And for that reason, you would use a class. So elements can have both IDs and classes. So let's add a class attribute to this element, which we're going to call this test class. And we're going to copy this exact same class to all three of these elements. And this is perfectly legal HTML because classes don't have to be unique. In fact, classes are made in order to be able to take a blanket and cover them over multiple elements. So say I didn't want to just change header 1. I could now reference the class name. Instead of using a pound, you use a dot and you say the class name. Using CSS, I can now change all my header 3s that have the class test class to red. And you can see they're now all red. Now, if you'll notice, let's go ahead and add an H3 right here that doesn't have the class or the ID. So it doesn't have class or ID. I keep saving it for some reason. Okay, and then we run this and you can see because this CSS only targeted this class name, only those elements with that class name got changed to red, and this other H3 did not. So that is the importance of class elements. Class elements can be applied to multiples, and they can share the same name, and actually that's their purpose. And then you have IDs, which are guaranteed to be unique, and they never share a name. So it allows you to identify a specific element inside your web page. CSS stands for Cascading Style Sheets. It's used in conjunction with HTML to apply detailed styling like colors, fonts, borders, even things like opacity, like changing the transparency where you can see through images. All of that stuff is not natively supported through just standard HTML tags. And we've seen, if you've watched the beginning HTML5 video series, also available on hipstercode.com, you've seen that HTML displays certain elements differently. Like an H1 has a larger font size than an H5 or an H6. Well, certain things can be displayed natively by the browser just based on the HTML element. But in many cases with modern web development, we want to be able to add a lot more style and individuality to our web pages. So that's where CSS comes in. The combination of HTML, CSS, and JavaScript make for the dynamic nature of the modern day web. When the web was first created, it was really just a document sharing service, and the documents were very, very basic. It was mostly just text. If you fast forward to today, we have embedded video, embedded audio, you have web applications like iTunes or YouTube, and they all become, they're very much, they're more sophisticated than they've ever been, but it's ultimately just a combination of HTML, CSS, and JavaScript, which is making this stuff happen. So CSS is a very efficient markup which the browser knows how to render. So CSS isn't just executed through a text. You have to write CSS in an HTML page, or you have to link to a CSS page in order for the browser to be able to read it. But we're going to look at how you do those simple steps and later on in this module video. So CSS is rendered using the browser. So when a browser sees CSS, it knows how to take action based on the content of your CSS. It's commonly associated once again with HTML and JavaScript. So you're going to hear a lot of, being a web developer, it's automatically assumed that you know HTML, CSS, and at least a little bit of JavaScript. So there are three main ways to use CSS. The first one is, if you've watched the beginning HTML5 video series, we saw that there is an attribute that you can add to an element like a p tag or a header tag that is a style attribute. And inside the style attribute, you can actually give CSS to that one specific element to make it maybe change its color or adjust its font size. There's also the ability to use the HTML style element that you can put anywhere inside of your web page, and then those CSS rules will be applied to all the to any sort of style that you added. It will only work for that one particular page, and that's called an internal style. If we just add the style attribute to the HTML element, then it's considered an inline style. So these naming conventions are a little bit difficult to grasp at first, but you definitely need to understand that an inline style means that a style tag was added to it, an HTML5 element. A internal style means that the style only applies to that one particular HTML page, and that in that HTML page there's going to be a style tag, both opening and closing HTML style tag as seen here. And inside of that style tag you're going to see all the different CSS. The third and final option is an external style sheet, and that is going to be the most common option that you see in the web. In most cases, we don't want to write CSS scattered all throughout our HTML files. We want it all to be self-contained into one .css file. So a .css file means that you can write CSS in just a simple notepad like what I have down here, and I can write CSS right in here as long as I save the file as a .css file. Then it's going to be considered valid CSS, and if a browser tries to read that page, it will be able to understand what it is that you wrote in there. So just like with HTML5, there are certain rules that have to be abided by when you're dealing with CSS. Every CSS rule has a selector and a declaration block, and then I gave an example here. So the P, if we remember from the HTML5 video series, that is the paragraph tag. So that paragraph tag, that P signifies the selector. It says, hey, select. In this particular case, it's going to select all P tags. And you could have 1,000,000, you could have 5, you could have 1, but it's going to select all of them. And it's going to use, inside these curly braces, this is called the declaration. The declaration consists of one or more property value pairs. So this is just like a dictionary. You can think of font size as the key when you look into a dictionary and you look up the name happy. And then you have the definition of what happy means. So this is the same thing. The first key is font size, and it says, hey, be 18 pixels. So in this particular case, this selector only applies one style, which is font size, and it applies it to all P tags. So we're going to learn more about that later on, but ultimately you need to understand that CSS always has a selector, and then it has a declaration, which actually says what the styles are that are being applied. So we'll get into that once again much more in the coming videos. So the latest standard of CSS is 3.0. It's been 3.0 for roughly the past 6 years or so. There's going to be a new specification of CSS eventually. It'll most likely be called 4.0. CSS changes every so often, just like any other programming language or programming technology, where new additions are made, adjustments are made, and then a new standard comes out. So right now we still go by CSS 3.0 as being the latest and greatest, but eventually just be on the lookout for newer versions with newer features. But ultimately we don't expect the language to change too much. So we're going to summarize this module by saying that CSS 3.0 is the newest specification of the CSS language. CSS is used to apply styles to a web page. It's used in conjunction with HTML and JavaScript. CSS uses selectors along with a declaration body containing property values in pairs to assign actual styles. And then there are three main ways of using CSS, which is inline, internal, and external. And those are three very important concepts that we'll look at. And in this module, we're going to be using the jsfiddle.net website, which allows us to write our CSS right into a browser and not have to worry about downloading or installing any sort of software, which can always get in the way of these tutorial videos. So if we can avoid doing that, that's going to be helpful. So if you want to just follow along with any sort of example like this, we can go ahead and do that. You just need to pull up a browser, go to JSFiddle, and follow right along, just so you know how JSFiddle works. On the top right here, we have our CSS. That's where we can write all our CSS, and that's using the external style method. Then you also have the HTML, so we'll actually write our HTML elements down in this box, and then down here I have JavaScript is minimized as much as possible since we're not going to be touching on JavaScript for the most part in this course. So let's go ahead and look at a few elements. For starters, let's look at the paragraph element. So this is a paragraph. And then in CSS, if we want to blanket apply a style to all paragraph tags, we just simply have to say this. So once again, this is your selector. It's selecting the p tag. And then you have the declaration body, which is going to be property value. So property will change the font size. And keep in mind that anytime you have property, there's going to be a colon and then followed by the actual value. So this can be 18 pixels. And anytime you list a value, you want to end it with a semicolon. So you're going to want to get used to that, because if there's more than one style that you're applying, they have to be separated by semicolons or they're not going to work. So let's go ahead and click run, and you can see that this paragraph has changed. Now let's change the font size so we know that it is having an effect. So now you can see that it's bigger. Now once again, if I were to not have added a semicolon and I want to change the color of the font to something like red, watch what happens. I have a semicolon past this one, which is fine, but the editor here is even warning me it's turning this red because it knows I didn't execute or end the statement properly. So you can see that no statement was applied. This thing was completely ignored because the browser tried to render this, it couldn't, and it failed. So if there was CSS after this point, that would also not be rendered. So CSS is rendered from top to bottom, left to right. And if it runs into a problem, it's going to choke up and it's going to cause massive issues. So if we add a semicolon and we end this statement properly, and we run this, actually it didn't turn it red. I thought it was actually turning it red, but it doesn't know that. That's just the way JS Fiddle works. So you can now see though that the style is not ignored and everything is happy again. So once again, with this p tag, this is actually going to apply to every single p tag on the page. Right now we only have one, but say we added 4, or we add 3 and now we have 4. You can see that it applied the style to every single one. A lot of times people don't want to do that. They only want a style to be applied to one element. So if you've watched the beginning HTML5 video series that I talked about there's 2 ways to identify elements, 2 of the most common ways anyway. Number 1, if you want to have a unique element where there's only going to be one element with an attribute, then you're going to want to use an ID. So an ID attribute should always be unique. Even if the element is different. So even if you have an anchor element and a paragraph element, they should never share the same ID. The ID should always be unique. So if I had an ID on here, I could say ID equals 1. And now what if I said, you know what, instead of P, I only want this one element to be styled red. Well, I can do that now. So this style, this selector only applies to this one element because that's all that matched. Well, then you're like, well, then I have to add a unique ID for all the different elements that I want to have different styles. Like, what if I want this guy to be red too, but not these two? Well, that's where classes come in. So keep in mind here that we referenced an ID by using the pound sign. That's something that is a little bit difficult to just conceive at first, just because it doesn't make any sense if you've never done this before, but eventually it'll just become second nature. But IDs are referenced through the pound sign. Classes will be referenced through the dot, so a period. So if we change this over to a class does not have to be unique. In fact, it's made so that it can be applied to multiple elements. Now, one thing I do want to let you know is that even though it is considered bad form, HTML will not complain if you have 2 elements with the same ID. And if I even change this to 1, you can see they both got applied. However, there are certain standards that, for instance, Google as a search engine searches millions of web pages, and it looks for web pages that are properly formed, that are very professional, and it gives them more credence, it gives them more search traffic because it is valid HTML, it's valid CSS. There are rules that are executed on your page, and if you go to like the W3C, they have testing tools where you can insert a web page and it parses the web page and it finds all the errors. So you're going to get a CSS validation error because you have two IDs where they're supposed to be unique. Where it gets into even more of a problem is when you start using JavaScript to start adding dynamic behavior where you think that you're dealing with a unique value where there's multiple values and it's being applied to either the last one or the first one or applied to both of them, and it just creates a ton of headaches. For the most part, you're not going to style a lot of stuff with an ID. You're going to see classes used most of the time, but that doesn't mean that you can't use IDs. There's always a time and place for everything. Sometimes you just want to apply that first, that one style, and an ID might seem fitting. However, so those are the differences between classes and IDs. All right, so here we are back in the JS Fiddle webpage, and you can go ahead and visit this. You'll be able to see all the different content that we've talked about in each one of these modules. And in this fourth module, we're going to be looking at styles and comments. So in the previous video, I showed you in the CSS panel, which is somewhat unrelated because we're not doing CSS, but CSS and HTML are very, very similar in that they're so tightly binded together. They're basically best friends. You absolutely have to know both of them in order to be a web developer. The way that we referenced this CSS style was it's considered an external style sheet. So JS Fiddle automatically creates a CSS file and then just points to it. But in many cases, you don't want to point to a external CSS file in order to apply style to your HTML element. And you can actually apply a CSS style to an HTML element without using a CSS page at all. And you use that using the style attribute. So let's go ahead and do a h4 tag here. And this is a custom HTML style. So what we do is we use the style attribute, and then in here in the double quotes we actually do the same thing that we did here where we listed the key value, and I can say color blue, and if I run this you can now see that we have this blue color, and we didn't need to reference a CSS or external CSS page at all. If I wanted to do multiple styles, I could do that by separating them with a semicolon. And here I can say like font size, which sets the actual height and width or the actual size of the text there. And if I do that, you can see that's now bigger. You can even make it really big. But we'll keep it at a more reasonable size here. So that is the style tag. So you're going to occasionally see styles that are directly attached to the HTML element. This is typically considered frowned upon. You want to avoid inline styles as much as possible because it becomes a maintenance nightmare. An inline, and this is what this is referred to as an inline style. This is an external style. Most of the time you want all your styles to be in an external style. That way they're all in a one identifiable location. If you have a bunch of HTML web pages and you have tags that all have their own styles, they're always going to override your external style sheet. And you then have a big maintenance nightmare, like I said, because you're going to have to go through every one of your HTML pages, and instead of just changing all your styles in one page, you have to then go through all your pages where you have all these inline styles and update them. So sometimes it's easy just to do a quick and dirty style tag, but most of the time you do want to avoid it. But if you ever see them doing that, or you see them in your HTML page, that is what they're for. The next thing we want to touch upon in this module is comments. Comments are an interesting feature in HTML5 because they allow the browser to ignore certain pieces of the HTML page and not try to render it as HTML. This is helpful because a lot of times you want to write comments to yourself or to other programmers that might see your code that explain certain sections or certain logic that you might have buried in your HTML page. But there's all kinds of different reasons why you want to use a comment. In order to use a comment in HTML, it's a less than sign followed by an exclamation, then 2 hyphens. And then you have 2 hyphens and then a greater than sign. So everything in between these 2 tags, everything between these 2 tags is ignored by the browser. So if we run this, you can see that there's been no change because it's ignored by the browser. It's not going to output as HTML, but it's actually in the HTML source code. So you can see down here, it's still there. It was just ignored by the browser. So this is a good time to talk about how HTML is executed. HTML, similar to many other programming languages, is executed sequentially. So from top to bottom, left to right. Basically, how do you read out of a book? You read out of a book, you typically start at the top of the page, and you start, starting on the left-hand side, you start reading sentences from left to right, top to bottom. And if you're not reading that way, I don't know how you're reading at all, assuming you're human. But that is how we all read, and that's how the actual HTML is executed. So this portion of the HTML is going to be executed before this portion, blah, 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 on and on down the line. So it's a very important concept because there might be times where you think the page is supposed to behave in a specific way, but it's not. And the reason why is like maybe you change the page at a top portion, but then a bottom portion of the page, the last part to be executed by the browser, overwrote the change that you made to the top part. So it's a very common thing. We've actually seen it in so many different programming languages, and it's just one of those things you have to understand. That's how the page is being parsed, and there's a method to all this madness that you're going to run into. One is the unordered list, which is signified by UL. UL consists of a bunch of LI elements, which stand for list item. So list item 1, list item 2, list item 3. And if we run this, you can see that they're displayed in bullet points, so typically the way list items are displayed. You're also going to see a OL, which stands for ordered list. And the ordered list is displayed in numerical context. So 1, 2, 3. So you'll see both of those. That's a very common element. Now another one that you're going to see a lot of is the button element. Anything inside the button is press me, I'm a button. So now we have a button. Doesn't do anything when you press it, but that's what it does. Now another element you're going to see a lot of is the input element. The input element is very important because it takes a text by default. So this is a attribute type, which we have set to text. Inputs do not need a closing like we've seen with the image tag. It does not need a closing. We could just simply have this. You can see it's a text input box. But it allows certain attributes like, let's think. So the like the placeholder. Sorry, I forgot the name of the word for that placeholder. This is temp, and you can see when we do that, it's grayed out. So when you start typing, it gets rid of that. But you can also have a max length on this. So we can say max length equals 2. And if we run this, and the reason why that didn't work is because I'm not supposed to have the underscore there. So by having the max length, it won't allow me to add more than 2 characters. So there's all kinds of different cool things with the input type, but that's ultimately every form that asks you to input some sort of element is using the input form. And this is, you didn't have to say text, by the way. The type is automatically defaults to text. So there's going to be no change here. However, What if we want to change the type to something like password? So if you've ever seen password, you know that when you type in a password, it gets starred out. That way, nobody else that might be looking over your shoulder can see what it is that you're typing. There's other different types that we're going to look at as far as the attributes, but that's really all we need to know for right now. Another one that's very important is the submit button. So you're going to see a lot of input, and when you say type, they can say submit. And by default, submit is going to post the page, which means it's going to try to do something with the page when you click it. So let's go ahead and look at this. So submit, even though it's an input, by saying type submit, it actually makes it into a button. When you have a server set up and you have a form collects data from a user on your site, and then it needs to actually send that data to your server so that you can do something with it. You can either process it, you can save it to a database, you can do all kinds of things once it gets to your server. But the question is, how do you actually get data from an HTML form to your server? And you do that through the form action. And the action is just like we've seen with the image. It's an actual href. So basically it's a URL location to some place on your website that will be expecting that form to post data to the website. Now, if I tried to post to this URL endpoint, it's not actually going to do anything because the server's not set up in order to take any sort of input, especially from a site across the entire web. Typically, when you're doing a form, you're having a web page on your website. So if it's hipstercode.com, say hipstercode.com/form is the name of the page, and it's posting to some other page on hipstercode.com. So you don't always post to other web pages. In fact, that's actually very uncommon. So where you actually post the data to is actually going to be in the action attribute. The next one is the method. There's two ways to post data to a server. One way, and typically the way that you use, is get. And a form will post by get as the default. So you don't have to say method equal get if you don't want to. But get is typically used anytime you need to communicate with a server that is going to retrieve information, and then the server will pass back information based on the form input. Now, anytime, the general rule is that you're going to use gets anytime you need to obtain data, and you're going to use post, which is the other method that we're going to use, and it is meant to be in all caps, by the way. Post is anytime you're sending data to the server that is going to be persisted, which means that anytime you're going to take data and save it to a database or store it somewhere, that's considered a valid use of post. So when you're passing elements, always use a post if you want to save those elements somewhere. The next thing we're going to look at is, let's look at our inputs again. So we're going to add an input, and we'll say, we'll give it an ID, so we'll just call this 1. And we don't need to say type or anything. And we'll just say, we're going to actually use another tag that we've never used before, which is a label. So in forms, you're going to see a lot of labels. And the label has an attribute which could be called for. And all you need to do is actually pass it in the ID of the input element that it's for. So we'll say question 1. And let's go ahead and copy some of these just a couple times. And we'll change these to unique values. So 2. All right. And because you probably want some space after this first question, we're going to look at the BR tag, which stands for break. And this is another tag that doesn't need a closing. It can have this modified, this minimal closing. But by doing that, you can see that it caused a break between these two lines. In fact, you can have two on top of each other if you wanted some separation between those elements. So now you have separation. Let's change the label here. This should be question 2. All right, so now if you look at the label, this is important. We're going to actually now look at another element that we've never seen before, which is also an input, but by using a different attribute for type, we're going to say radio. Now check this out. Radio now we'll say male, and then we'll say female, and we'll add a BR there. And now if we run, actually, you know what, we need another BR here. I'll do 2 BRs. Alright, so here is male and female, but what it allows us to be both male and female. Not saying there's anything wrong with that, but typically web forms, they want you need to select one or another. So how do you do that? Well, you use another attribute called name, and you give it the same name. So we'll say male or female is the name, and I'm going to copy this name attribute to this element, and if we run it now, if you select male or female, because they share the same name, it's going to select one or the other. So that is the importance of the name attribute on an input type of radio button. Another input type that we haven't looked at is the input. Let's add a couple BRs here again, and this one's going to be input type equals checkbox, and we'll say, do you like this course? And now, do you like this course? And I can give it a little check, which hopefully you guys are checking that as well. All right, and then finally, in order for this action to be posted to, once they've filled in all this information, we need to actually add the input type submit that we looked at in the last video. So input type submit, and then we can give this a value. So that's another new attribute, and value gives this click this joint. So this will actually give the text inside the button, you know, when we post this form. So let me go ahead and update this real quick. And if I say click this joint, you can see it now tried to do something. It actually tried to post all those values to hipstercode.com, which it won't allow it to do, because even if it could, it would fail. But that is actually how you post a form to a server. You wrap everything inside the form element. Forms consist of labels, input type text, input type radios, checkboxes, passwords, all kinds of different stuff. But none of this stuff is nothing that you've never seen before if you have any experience with the web. The iframe is a very important tag because it allows you to place embeds. If we've ever seen the HTML file or HTML videos from YouTube, you've seen that we're able to take all kinds of different content from whatever sort of channel that we're looking at, and there's always an option of being able to share a video. So let me show you here on YouTube. Here I'm at this this channel of mine, and if I go over to the share button down here, I can see there's an embed option, and in this embed option there is an iframe. The iframe is one of the few tags that allows you to take a small portion of your web page and actually be somebody else's web page. So it's code that doesn't even exist on your website or even your server. It could exist across the world. But the way it works is because it uses the source, it points to where this video can be found, and the iframe and everything else in there is actually all self-contained within this one box. So this is actually viewed right from This is actually viewed right from YouTube. So it's a very, very powerful tag. It's a very awesome tag. It allows you to do a lot of cool stuff with your website, being able to just embed. So there's really not much that we haven't seen there, like with the width and the height attributes. The source attribute is very similar to the image source that we've seen in the past. And then this allow full screen will allow you to actually click the full screen. That's Google's It's actually a Google attribute, I believe. Some of these other attributes you're not going to see very often outside of a iframe, but like the frame border and stuff like that, you can actually set that to a different value if you wanted to. And you can see you now get this thicker border around there. You could set it even really large if you wanted to be ridiculous about it. But anyway, those are some of the different custom attributes that are involved in the iframe. The next tag that we want to look at is a very important tag and something you're going to see a lot of. Whenever you're dealing with a lot of different websites, they'll allow you to take a bit of code and then plug that right into your website, and they do that using something called the script tag. So the script tag is how JavaScript is executed within an HTML page, and it's just a script followed by an end script, and then anything inside of these two tags is actually not HTML anymore. It's not CSS. It's actually a different language called JavaScript. And we've talked about it. It's basically the trio of what web development is: HTML, CSS, JavaScript. So if I wrote a little bit of JavaScript here, we're going to say alert, hello, hipster code. When the browser runs this, it's actually going to use the JavaScript rendering engine to parse that JavaScript and then run it. So you can see alert actually does this pop-up window using JavaScript. And it displayed the message that we wanted to display at the bottom. So anything within these script tags is all going to be JavaScript, and we'll touch upon that in a later module, the different course unrelated to this one. But those are two very common and important tags that you're going to see a lot of within HTML web page. We're going to be looking at something that is a very, very important concept in web development using CSS. And if you go for any job as a web developer, they're going to ask you about the box model. So the box model is a very, very important concept. And I can show you that if we add a div tag, which is just basically just a block, right? And we'll give this an ID, so it's a unique value. We'll say box model. Okay. All right, and if I run this, I want to get rid of this CSS over here. And let me right-click to inspect element using Google Chrome. And I'm right-clicking on this div ID so that way it'll be selected when I have it. Now, on the right-hand side of this panel, let me see if I can zoom in on this a little bit. So on the right hand side of this panel, you're going to see that all these different colors are being applied. This is all being applied through JS Fiddle, and a lot of it's not going to make any sense. But if we scroll all the way down to the bottom, you should actually get to the box model. So the box model will be displayed on every div container, every element that you have. So here's the actual box. And the reason why it says auto is because that is the default layout for a div container. A div container can be unlimited width, it can be unlimited height. But if there's no elements inside of it to push it higher or wider, then it's just going to be auto and it's going to be relatively small to minuscule. The padding is also something that is defaulted, and in this case it's defaulted to 0. And then there's no border, and then you have the margin. So let me try to explain some of the concepts of this. We're going to put a div inside of a div, and we're going to call this one inner box. And instead of box model, I'm going to call this outer box. And once again, this is a very, very important concept that we're going to learn here. So if you can understand this, then you'll be just fine with web development as you get all this under your belt. So if I go ahead and let's give the outer box a width and a height. So we're going to say outer box, and we're using the ID ability, ID selector for, I need to spell it right, outer box. And then we're going to say width. We'll give it 200 pixel width and then a height of 200 pixels. And then I want to give another style down here for the inner box. And this is going to be a height of 50 pixels and a width of 50 pixels. So basically a perfect box. Now we want to change the background color so that we can see. So this inner box is going to be a background color of red. And then this outer box, background color of, I'll make it pound CCC. So we use the hex value of styling. So now if I click run, you can see that by default we now have in the display this new div, which is 50 by 50, which is a perfect square inside of a much bigger perfect square. And inside this this square here, it defaults to the top left portion. So everything in CSS, it basically, you're looking at it from a coordinate of from top down. So basically this exact pointy position, if you were into like graphics and things like that, would be 0.00. And that's essentially how everything is rendered. So it's always just one value for down, one value, left and right. So just like a latitude longitude works. So in the outer box here, the box model, this inner box, has number one, no border. So let's add a border to this inner box. We're going to say border, and we'll just call it, we'll say border. In fact, I don't want to get into something that I was about to get into. We're going to say border width is 2 pixels, and then border color is black. And I actually did that. This should not say border color. Border takes 2 arguments. So this is actually something that we've never seen before as well. But border, the first argument that you give is actually what type of border you want. So we're just going to say a solid border, and then the second argument is the actual color of the border. So if we do that, you can see that it's now this, this black border. It's solid. But if I would have said dotted, then you can see the borders like this, dotted weirdness or whatever. So that actually gives 2 arguments, and it knows that each argument is separated by a space. So that's the first time we've run into this scenario. Hopefully that doesn't throw you guys off too much, but I just want to make sure that we can clearly see that the box has a border, because we want to look at the difference between margins and padding. So a margin within the box model basically says go on the outside of my border. So the outside is all around this would be the outside. And if I said margin top 20 pixels, what it's saying is just on the top here, push me down from my parent container 20 pixels. So you can see that it pushed the entire box down. So what's interesting is that because this outer box also, the contents within the outer box can also be affected by things like the margin. Some of that has to do with styles that could be applied through JS Fiddle's website or what have you. But one of the reasons for this type of behavior is because the outer parent does not have any sort of relative positioning. So let's add a position, a key value pair here called position, and we're going to call it relative. So this is the outer box, which is considered the parent of the inner box. So now by saying that this outer box has a position of relative, and if we change this position to absolute, then this is going to ignore any other sort of styles that are outside of JS Fiddle that could be interfering with this box. In addition, you can see that this desired effect, this is mainly what I was trying to show you guys, is that the margin exists on the outside of this div. So it said, hey, on the outside of my border here, push me down 20 pixels from my parent. Now, if I wanted to say also on the left-hand side, I could say margin left 20 pixels. And you can see that it moves it now 20 pixels from the left-hand side in relation to its parent. Now, because its parent is relatively positioned, the absolute positioning is always going to be in relation to its parent relative position. So when we say 20 pixels, it means the 20 pixels obviously from its parent's left border. If we give it a margin, it's not going to mess with its parent or anything like that. So in many cases, you see most web developers struggle with the simple fact that positioning things absolutely inside relative position boxes works just fine if you understand how to properly work within the constraints of the relationships to the two. All right, so that is considered the margin, the outside portion of this box model. Now, say we didn't want to actually apply the margin to the top or anything like that, and I just want to set it right back into its original spot. I could actually have the parent dictate where things are situated within it by using its padding. So instead of margin from the inner element, I can use the outer element and just set its padding, and we'll even say padding top 20 pixels. So by doing that, it has essentially the same effect, but instead, I'm going to do this as well, but instead it's being dictated by the parent element. So the parent element, and let's go ahead and right click on this. So we can see if we select the outer box and go all the way down to the box model, you can now see that there's a 200 by 200 width and height, which we set. Then there's also this padding on the top and on the left hand side of 20, and the padding is being dictated by the parent. The parent has no border. It also has no margin. But if we select the inner element, you can see it's 50 by 50. There's no padding set on that element. And then there's the border, which you can see that there's a border cleanly all the way around it. And then there's also no margin set. So if I set a margin on that child now that the parent has a padding on it, so I could say margin top 20 pixels, you can see it pushes down even further, but it pushes down not from the top position of the parent element, but it pushes down from the padding set from the outer parent's element. So this stuff can be very, very confusing and hard to wrap your head around, but ultimately having a parent that is relatively positioned can have any sort of child element from within it. As long as it has a height and width set on it, it can easily position that element wherever you want to position inside of it without ever getting interfered with by other components or other positioning. So one of the headaches though with writing CSS code is that because it's called cascading style sheets, there's many occurrences where you're going to have styles that are being applied to your elements that you're not intentionally wanting to have happen. But there's a certain cascading rule set that applies. Like when we applied a style to all paragraph elements, it uniformly went down through all the paragraph elements and applied the style. So if a paragraph element sits inside of some other element, you might find that parent element is being styled when you don't want it to be, just based on the general rule that you applied to all paragraph elements. So there is a certain pecking order from within CSS, and we'll get into that more in later modules. JavaScript used to just be this code that we'd inserted into our HTML pages, and it just rendered, and we use jQuery with some plugins, and those had a little bit of headaches every now and then, but nowadays it's a lot more complicated than that. So being a front-end engineer is now arguably harder than being what used to be like a C# back-end developer, or even Python, Django, or Ruby Rails developer. JavaScript is now that complicated, where there's so many different libraries and so many different ways of writing the code. But the whole point is that JavaScript is the only language that runs in the browser. Browsers render JavaScript differently, and the latest version of JavaScript is ES6 or ECMAScript 2015. I know that's really weird and confusing, but that's the way it is. And we have to end up using a tool like Babel to then take our modern JavaScript and turn it into older JavaScripts that still works in older browsers. And the reason why is because if your stuff didn't work in older browsers, I think your customers would get upset. So we can write in some of the latest ES6 standards, but it means that we need to have Babel. So in order to have Babel, it means that we need to have Node.js installed on our machine, because Node.js comes with a package manager that we're going to use to install Babel by default. So make sure you have Node.js installed, and you can do that here. So that'll give you access to npm so we can install Babel. We also need some way of writing our code, and I recommend Visual Studio Code. So if you just search that in Google, it's a free product, and You can use any editor you want, though. Technically, you could write in Notepad, although I wouldn't suggest it. So that all said, I have a folder that I called ES6 tutorial, and I want to go ahead and navigate to that folder. So that's what I'm doing here, and I'm going to go into ES6. I'm going to open up a command line by saying CMD. So now I have it opened up into that tutorial folder, and you can see there's nothing in it. So the first thing we need to do is we need to use npm to run this command called init. And I say init, for some reason I always pronounce it wrong. And most people say init, but for whatever, I think I say init because of the iPhone and all that stuff, and it just kind of is programmed in my head. But we're just going to call this ES6, and we'll just skip all this stuff. Just keep pressing enter. All this stuff doesn't matter. And then finally, we're going to see that it has this package.json file. And we don't have to worry about too much of what that is doing right now, because I don't want to confuse anything more than it has to be. Let's just keep continuing forward, and we're going to install two tools that we need. And those two tools are called, it says right here, npm install savedev, which is Babel CLI, which stands for command line interface, and Babel preset environment, and that allows us to write this modern JavaScript. So we're going to copy that entire statement, and we're going to paste it inside of our command prompt and run this. And what npm does is it really just goes across the internet. It grabs these projects, and we're installing two here, Babel CLI and Babel preset environment, and it brings them onto your computer, and it's gonna install them in a folder that gets created for you called node modules. So in modern JavaScript, files now consist of all kinds of different JavaScript files, and they're spread out all over the place, and we can import them and use them as needed. And then we can also use entire projects like React or Angular and things like that, and those will all be installed inside the node modules folder right here. So because we installed two dependencies, we now have a node modules folder, and the node modules folder contains all the information Babel needed. So you can see Babel's a pretty big friggin' project. It needed all this stuff for those two projects that we just installed. Another thing too is because we said save dev, it adds them to our package.json file to tell us exactly which two versions of these, basically which version of Babel CLI and which version of Babel preset environment. And the reason why that's important is because you could take your project, and without having to worry about all the node modules and stuff like that, you could just have your package and bring it into another folder on another computer across the world and just run npm install, and it will go through all the dependencies and install them for you into the node modules folder. So that's really what package.json is all about. Now, one of the things that we're going to need to do, and Babel actually tells you that it needs it, is that you need to create a Babel RC file. And that's confusing, but we're just going to copy this part, and we're going to create this file called .babelrc. And it's a special file type that Babel uses. So when we use Babel's command line interface, it's just going to work, and that's all you need to know. So let's create another new file, and this is going to be actually our main file. So we're going to call this index.js. You know what? We're going to even call it first.js, so that way we know this is our first file. And we're going to create a JavaScript array, which hasn't changed with the newer versions of JavaScript. But this is an array. It's inside the square braces, and we end it with a semicolon, and we have the variable name of x. So now, what do we want to do if we want to actually say, you know what? I'm going to take this file and I want to bundle it into another file. So we're going to pull up our command line, and here I'm going to say npm run, and then we're going to say Babel, and we're going to give it a start file, which is index.js, or no, we called it first.js, and then we're going to say -o for out file, and we're going to say bundle.js, and press enter, and this is going to run and throw us an error. Now this says that it couldn't figure out what Babel meant, so what we're going to do is add that to our package.json file, and under scripts here we're going to put an enter, and we're just going to say Babel, and then Babel, make sure there's a comma after that. So we just said Babel and Babel, and let's try this again. All right, so it's always good to have error messages because you learn a lot from error messages. There's no such thing as actually programming anything without running into errors, and And identifying those errors and not freaking out is usually rule number one, but you just build a lot because you don't know what you don't know, and a good programmer knows that they don't know a lot. And in the same sense that one of the biggest traits of being a good programmer is also being able to figure out what the problem is, being able to phrase questions, and that takes experience and really running into errors. So okay, this is a type error. This is some sort of undefined error. There's all kinds of different errors that you could have. In this particular case, this thing says, hey, it tells you what the problem is. It says bundle.js doesn't exist, so it doesn't know what you're trying to do. And the reason why is because we're running this locally by saying npm run Babel. But in order for us to pass the arguments to the Babel script, which is right here, because this just says, hey, run Babel, in order for npm to actually understand the arguments, we have to say hyphen hyphen after our Babel command. So npm run Babel and then space hyphen hyphen. Anything after that is going to be arguments that is passed to Babel. So the first argument is the file that we created, first.js, and then we're saying out, hyphen o is our out file. We want Babel to turn first.js to use bundle.js. So now by doing that, we don't run into any errors. We look here, we now have a bundle.js file created. So let's take a look at bundle.js, figure out what's going on there. So if we look at bundle, you can see that there isn't much change between first and bundle. But there is this use strict. And use strict is something that we're used to in older versions of JavaScript, because JavaScript has some weirdness to it where if you tried to access an undeclared variable, JavaScript would just create one for you and assign it to the global namespace. So we really don't need to get into too much of this, but if you wanted to read more about this, there's a lot of good documentation. You can go to W3 Schools, or you can go to Mozilla's documentation, which is strict mode MSDN, or I'm sorry, MDN, not MSDN beat. But this talks all about strict mode, but it'll prevent things like unassigned variables from being declared. So like if I said y equals, not in the compiled version, but let's do that here. We're going to say y equals, this is a script. I'm not sure what this is going to do, but we're going to try. And you can see y hasn't been declared. There's no y. Like it's just, hey, y doesn't exist, but we're going to say, hey, do something with it. So in normal JavaScript, it doesn't complain about that sort of thing. Let's press the up arrow so we can run the exact same command that we did. And this thing went ahead and created. And you can see it didn't even complain. However, if we were to reference this JavaScript file inside of our browser, and the browser actually executes this, then there's going to be a complaint file because y is undeclared. So let's go ahead and get that going so that we can actually see this inside of a browser. We're going to create an index.html file. And inside the index.html, we're going to create some basic HTML here. We're going to have HTML. Inside here, we're going to have our head, body. So that's all the standard HTML stuff you need. If you go and highlight all this and press control, not forward slash, control, no, not F, control alt F, alt F. Man, I don't friggin' know. So it's actually Shift Alt F. That's so weird. Shift Alt F, and you can see it actually formats it a little better. Probably want this to be indented like that. But anyway, inside of our head, we're going to actually load our script file. So we're going to say script source dot forward slash, and we're going to say bundle. So we want to use the actual bundled file that's being created for us, and we actually need to close this off officially like that. Alright, so now if we go ahead and we open up our folder and we double click on our index file that we created, this should open it up in a browser. And if we look at it in the browser, inspect the element, you can see that we now get an error. Uncaught reference error, y is not defined. It's like, damn, you tried to reference an undeclared variable. Typically you don't want to do that, but under normal JavaScript it doesn't complain unless you use that use strict. And that's actually a new feature of ES5. I believe John Riesig, the jQuery creator, actually wanted that to go in. But here, if I remove the use strict, there's no complaints now. Check this out. If we go to the window.global object, so if I said window.y, this is a script. Check that shit out. So even though JavaScript was like, hey, you didn't declare this variable before, it went ahead and it assigned y to the global namespace, which is the window object, without any sort of complaints whatsoever. So that means that we're polluting the global namespace, probably because we had some sort of an error. So anyway, that's what Babel's doing. It's actually saying, hey, use this older, more correct version of JavaScript, so that way, if there's some problems, people will be notified of it. However, during the compilation process of creating the bundle file, it's not going to complain about that there. That's not its job to say, hey, you need to write proper JavaScript. It's just saying, hey, you can write new JavaScript and we'll turn it to old JavaScript. But you can still write some sloppy shit, though. So you want to be careful about that. So for this first video of this series, this is where I'm going to end up. I'm going to leave this first video off because this was all about just getting everything set up. So now that we have a basic setup and we're going to be able to see our output, we're going to start actually getting into the more of the ES6 syntax. We're going to be looking at the let variable and explain its importance, really. And I think that in order to be able to do that, we need to do this by example. So what I have is, this is the bundle.js. So I know that we've been using Babel in the first video to actually compile into a bundle.js, but in this particular case, I just want to write things the old way to kind of explain the situation real quick. So if I were to give, let's just create our function. We'll create, and this is just a function, regular JavaScript function. I needed to say, obviously, equals function. All right, so here we go. And inside here, I'm going to just give it let's do a var. Hey guys, what's up? So welcome to this new ES6. Anyway, I really wish that video wouldn't play as soon as it starts rendering. That sucks. Anyway, so what we're going to do is we're going to have a variable x inside of our function that's defined, and we're just going to say this is in the outer scope. And then we're going to do a while true, or in fact, we can just even say if true. And true is going to be true, so that means this will run. We can then say variable x equals, this is a new value. And here I want to say console.log x, and then outside of the if loop, we're going to say console.log x. So in JavaScript, when the language was first created, because it was created in 20 days, the creator, Brandon Ike, said that there was no time to add lexical scoping. So what is lexical scoping? Lexical scoping is when you declare a variable inside of this lexical block, basically this curly brace, anything inside of this this curly brace right here. So you can see start, and anything inside here is lexically scoped. So var x is lexically scoped to this area. Now down here we create a new var x, and we're saying that this should be lexically scoped. X should really, the one that's declared here should really only exist inside of these braces right here. But by default, JavaScript doesn't work that way. I'm going to show you. If we go into, and I'm going to actually execute our function too, so that way when the page loads, it will actually run this code. So let's go ahead and open up our browser here. All right, so if I hold down the refresh button, I can empty the cache, because you always want to make sure the cache is empty. Go to your console here, and you can see that it actually outputs, this is a new value, this is a new value. So things, it didn't respect the fact that x was already lexically scoped to this outer function, or this outer code block. This internal code block just overwrote the outer code block. There's no problem whatsoever. But there's a new feature within JavaScript to prevent that sort of thing from happening. So the new feature within ES6 is the let keyword. So let variables are basically the same thing. You should probably always use them for the most part, because really I'm finding it really hard to come up with a circumstance right off the top of my head as to why you wouldn't want to use a let. So just use the lets. All right, so let's go ahead and take a look at this and see what happens here. And you can see that it respects the inner and outer scope. It does not change them when we use let variables. Now, one thing that's interesting is if I were to take this function and I would put it in first, and let's write it this way, so we're using the new ES6 standard, and what happens when we use Babel to then compile it to the bundle file? And we did this in the first video, so let's go ahead and take a look at what kind of output we have. And let's take a look at the bundled file. But look what it did. It took our lets and it turned them to vars. But what it did do, because lets are not actually supported in older browsers, Chrome knows how to execute a let variable, but other browsers don't. So Babel's saying, hey, you know what? We know what you're trying to do. You're trying to protect the scope of the variable. So it did it the old way, but it gave X a new name. So it basically figured out what we were trying to do automatically. So that way it will still respect the code, which is cool, in a backwards compatible way. But that is the reason why lets were created in the first place, is because you should be able to share variable names within different block scopes. And let now gives us that ability, and Babel will also give us the ability to write it that way and then change it for us on the fly. But eventually, the way that we wrote it here will be supported in all the major browsers eventually. Now this is also just for one variable name, which happens to be a string, but you could also have this same, this same lexical scoping could be applied to any JavaScript object, whether it's a string, a number, a function, because functions are just like strings and integers basically in JavaScript. So the lexical scoping applies to not just like strings. I want to make sure that that is clear. So in this video, what we want to look at is the new spread operator in ES6, and it's actually used in kind of two different ways. Like you're going to look at like there's this object destructuring where you see the spread operator kind of being explained and described, and then there's just the simpler ways, which let's focus on the simple way first. So if I were to have an array where I said variable bands equals, I'll just name two bands, so Silverstein and let's just say like 3 days grace or something like that. All right, so those are two bands and then it's in an array. Now, what if I wanted to actually insert another array? Well, I can do that through this new spread operator. So if I said variable awesome bands equals, and then I'll just put in here base side and census fail. So here's two more items in an array. I can use this spread operator to actually say ... and then awesome band. So let's go ahead and console.log bands. And another thing too that I want to focus on real quick is when we're doing our Babel compile, if we throw in another argument after bundle.js where we say -w, it stands for watch. That way you don't have to keep running Babel every time you make a change. This will constantly listen for changes and output the file. So we don't have to listen or keep doing that over and over again. So let's go ahead and open up our browser. And you can see inside here we have the array where we use the spread operator to insert another list of items. So if you see the difference here, like if I were to go, let me just say, instead of using the spread operator, I'm just going to say awesome bands. So we'll save it real quick. Let's look at the difference that gets outputted. And you can see what we have here is we have two strings, and then we have an array inside the array. So that's why the spread operator is a little bit cooler. So I can actually converge two arrays, very easily. You could also pass them in as arguments as well. So like if it was like a function variable, band function equals function, and then I'm going to say args, and for variable x equals, I'll just do, we'll just do a simple for variable actually, which var x equals 0, x is less than args.length x plus plus. So we're looping over all the arguments. We're just going to console.log args x. All right, so what we're doing is we're just going to loop through all the arguments that are passed into this function, and it console logs the specific argument that is being iterated. So now if I wanted to call band function, I could do that, and then I could pass in ... awesome bands. And each one of these arguments are passed in to the args. But what's going to be interesting, watch what happens when we execute this. You can see it takes in the first argument, which was base side, which is awesome band, but then it iterates each letter in the string for only base side. So it's like, well, why didn't that work? Well, what I could do is I need to say, I'm passing in a spread argument to this function. So that's different. So you pass in the spread, and you tell the function to be expecting this this spread operator. So now it'll iterate through the two bands that you gave it. So I mean, technically, yeah, is it that big of a deal for something like this? Because you're like, well, you know, obviously I could have just said args and not done it as a spread operator, and you get the same result doing it this way as well. But you know, the point of it is that the spread operator is also used in something called object destructuring. So let me give you an example of that. So if we were to say var a, b, and then rest, so we're declaring those, and we're going to say a, b, rest equals, and then we're going to 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so now we have this this assignment that's occurring, and what's going to end up happening is a and b is going to be assigned the first two values here, but we actually need to use the rest assignment. And because we're using the destructuring assignment and we're assigning all these values at the same time, we need to wrap them in the square brackets. So we're saying A is going to equal 1, B is going to equal 2, and the rest, using the spread or object destructuring argument, is going to get the rest of these values. So let's go ahead and say console.log A, console.log B, and then console.log rest. All right. All right, and there you see 1, 2, and then the rest of the operators. So that's called object destructuring. We're taking an object and we're making it different. And also, just to make sure that you're aware, you don't have to use the rest for that to work that way. You could even do it like this, variable AB, and this would work the same way. A and B would be assigned those two values. So you can do it that way just fine. That's no problem. You can see you get 1, 2. So just so you guys are clear, the spread operator, when I was giving this demonstration, is more along the lines of object destructuring, whereas object destructuring is kind of this new feature where you can do things by changing the way objects are outputted during assignment. So in this particular case, we just want to focus on the spread operator though, and I think that we covered it. So this is going to be about object, this new shorthand. It's an object notation. So basically in JavaScript, there's objects that you create, and this is my object. So this is the standard object where you have key values. So it's like a dictionary in a lot of different languages where you could say x equals cat, y is dog. So that way if you went and you said console.log my object.x, and that's going to return cat. So you gave it the key, and it actually returns the value. So if we go over here, you can see cat gets outputted. I'm going to zoom in a little bit on that. It's probably too much. There's cat. All right, so we have the data that's already there to create this object, but there's this newer shorthand way of being able to do it in JavaScript using ES6. And that is where we could actually have a bunch of different variables. Like, let's create like a band object. So a band has a name. So we'll say var name equals base. That's my favorite band. I always use them as an example. And then we can say var origin equals Queens, New York. And then genre. We'll just do 3 for right now. So genre, and we'll just say rock or alternative or whatever. But now what I can do is I can actually create an object that I can say var band equals, and then I give it the object name, but then I can just pass in strictly the 3 values that I've already declared. So name, origin, genre. All right, and then I'll go ahead and console log the band. All right, so I just created a JavaScript object much easier without having to identify the keys and then the values. I just simply had to say the values, and it's going to use the actual variable name as its key. So let's go ahead and take a look at this. And you can say we now have an object with a genre of rock and a name of Bayside and the origin of Queens, New York. So that's actually much more helpful than it may appear, because say you're scraping the web and you're trying to grab this and that, on each individual band, and maybe you don't have all the information to create the object. Well, in this particular case, you can just grab all your variables, create your object, all at at the very end of execution here. So it's a pretty cool, I think, feature of ES6. And really, that's just called object object notation or object creation, object shorthand creation. And that's about it, guys. So in this video, we're going to be looking at the new arrow syntax. And the arrow syntax is a new way of actually describing functions. And they're really no different than the old way. So let's look at the old way first. And we're going to say variable old way equals function. And then we'll just say alert hello world. All right, and then we'll call old way. All right, there we go. We called old way. Sorry, my phone was vibrating now. All right, now we're actually going to create the new way with the arrow functions, and we're going to say var arrow function equals, and this is where we actually do this open and close parentheses, and then we use this little lambda equal sign and then a greater than sign, and then we do our curly braces, and anything inside the curly braces is actually the return, what is being executed, the function body. And we could say hello from an arrow function. Alright, so let's go ahead and execute this one as well. And you're going to see that based on the old way and the new way that there isn't really much of a difference, if any difference at all. Hello world from an arrow function, or hello from an arrow function. Alright, so both of those just outputted just like they would. But so what are the benefits of the arrow function? Well, it's a little bit more concise because you don't have to spell out function. But you do have to use these weird symbols and things like that. You could even omit the open and close parenthesis and pass in an argument. So if I said, you know what, let's just call this arg. So I could have an arg here, and I could say, you know what, I'll just output the arg. And now when I call this function, this is a mother effing arg. All right, and it's going to be, that's how we actually pass in a variable. So this is a mother effing arg. Now, one thing to note about the arguments that we pass into arrow functions is that you can't pass in 2 this way. You can't have arg2. This is not going to compile. It's going to cause problems. But you can wrap it in parentheses and be able to do that. And you can say arg plus arg2. This is arg1. We'll put a space there. This is arg2. So this is arg1, this is arg2. So that's how you pass multiple arguments to the arrow function. Let's get rid of this old function here. Now let's take a look at what Babel did to our actual arrow function. If we look at this and we look at bundle, you can see that this is what Babel is actually doing because it's finding an older version. It actually takes it just like we had it before, and it just creates an older style of the function. So in this video, we're going to be looking at the new classes in JavaScript ES6. And classes are something really new. A lot of people bitch and whine because JavaScript's not a class-based language. It's actually more of a object prototypical, or there's like more of an object prototype pattern as opposed to true classes that output objects. Everything in JavaScript is an object, and it has a prototype leading all the way up to the global window object. So within this new ES6 standard, though, we're now introducing classes that have more traditional constructors to generate objects and to reference functions. So the syntax is quite a bit different than probably what you're used to with the old JavaScript. So let's go ahead and look at how to actually create a class. And we're going to just say class, which is a keyword, and we're going to call this band. And then you just do curly braces. So inside here, what we need to have is a constructor. And the constructor is going to take an argument. So we'll just say it's going to take name. And we'll say, you know what, well, it'll take origin as well. And now we can actually just assign values. We can say this dot name equals name, and this dot origin equals origin. So we're assigning it this this is actually the object that gets newed up from this class. So we're saying whatever object you create, you can give the name variable the name that gets passed into the constructor, and then we're going to go ahead and say, you know what, we're going to say print name, so that'll be a function, so we could say print name. And now we don't have to actually say functions or use arrow function syntax or anything like that. That's all you have to do. And we can say console.log name equals, and we can say this dot name. All right, and then we're going to do the same thing for print origin. We'll say print origin console.log origin this dot origin. All right, so there we have that. So now we need to new up an object based on that class, and we can do that now. We can say variable base side equals band, and then we pass in the name that we want. So base side is the first argument, and then we'll say they're from Queens, New York. All right, so now if I were to say base side dot print name and base side dot print origin, then we're going to see the output to the screen here. Cannot call a class as a function. What did I do here? Oh wait, I'm a dummy. I have to new it up. So there, you have to use the new keyword to new up the object from the class. My bad. All right, so here you can see name equals Bayside, origin equals Queens, New York. So that's really all there is to the new class syntax within JavaScript ES6. We're going to be looking at template literals, which is another new thing within ES6, and it really gives us the ability to more easily make multi-line strings. So if I wanted to say, you know, I'm going to create a long string argument, it's just going to be something, maybe it's an HTML page. So what I can do, instead of having to do this old way where I'm like typing like this and then I have to add more characters like that and things like that, and to be able to create a string, obviously I would assign it. You could have a long string that way, but that's like the hard way. You have to concatenate. If you wanted to do a multi-line string, you could actually do the new backtick feature, which is this. So I could say this is a long string, this is more long string, testing. So you can see that you have a big huge string, and it makes it a little bit cleaner, so that way you can have your standard formatting, and it works just like a regular string that we currently have. Alright, so if I go and I take a look at this, and you can see it just outputs the string just like we normally would. Now, one of the cool parts about this is that we can actually include actual variables from within the string, which is something that I would say it's relatively new for sure. So to include a variable within this new backtick feature in our template literals, we can just define, like, okay, let's say a band, and we're going to say it's Bayside. So that's our band name. And if I wanted to put it in here or anywhere, really, I could just simply say $, and then inside curly braces, we actually reference band. And you can even, you know, do something like band name equals like that. Now, if we run this, you can see it actually included it right into our string. So they call it, you know, template, because you could actually build, you know, effectively, you don't even need template engines anymore, because JavaScript is almost including the template engine type syntax that we need, just built into this new template literal ES6 standard. Now, there's also greater flexibility to be able to build certain things. Like you could even have a function, we'll say var long string function, and we'll just say that it passes in an argument. In fact, we won't even do it this way. We're going to do it as the arrow syntax. That way we're sticking more to the ES6 standard. So here's the arrow function. And what we want to be able to do is we want to be able to call this and be able to pass in. So we're going to console log long string function, and then we're going to pass in the name band, and you can do that. And we could also say, you know what, they've been around for, let's just say, what, 10 years maybe, something like that. So we'll have the first argument band name, and then around since. Those are our two variables. And now on using the backtick character, I can just say return this backtick string, and we can say band name is a rock band that has been around since. And here we're going to do something a little bit different. We'll just say around since, and then we'll just say, you know what, we're going to add 5 to it. So we're doing an actual mathematical calculation from within here. So let's just say, you know what, they've been around 15 years, so I'm just going to put 10. This is obviously not really the way you would want to create a function because it makes it very confusing. But my whole point is that you can do more than just referencing variable names. You can actually do computations and evaluate JavaScript expressions from within inside these these curly braces. So Bayside is a rock band that has been around since 15. Obviously, you would say some years after that, which I think they have been around for 15 years. But this is actually a very cool thing. Like I said, it's much easier these days. If you wanted to create like a new mustache type of templating engine, you could literally use JavaScript's built-in ES6 standards and probably create a few functions that make some of this stuff a little bit easier to do. But this is definitely a very cool feature of ES6. And what we're going to look at in this one, this is going to be really short. It's going to be the constant keyword. And some of you guys have asked about lets, whether or not lets are needed over vars. And it's interesting because I have a guy that I know that swears by lets, thinks that lets are going to replace vars, and that we should always use them. And then there's other people that, well, lets, they solve certain problems, right, where you can't redeclare something inside the same lexical scope, which just means inside the same level of curly braces that you're in, which is usually what you want. It's also beneficial to be able to share variable names without actually having to create two explicit different variables to have different values, like what you saw Babel doing. But I just thought I would mention that lets, I don't think, are going to just magically replace all of vars. I don't think lets solve such a complicated problem that we need to have them replace all of our vars. I just think there are going to be certain areas, and you're going to have certain people that swear by them. So it's important that that we do touch upon that. And in the same breath, that's what brings us to this video, which is we're going to be talking about the constant keyword. And if you wanted a variable to be declared and then never to change, and to know that it's never going to change, then that's where you would want to do a constant. And typically with constants, you think, okay, well, what doesn't change? Well, if there's some sort of like maybe an invoice number or something like that, and you want to make sure that within your program that nothing's going to change the invoice number for whatever particular object you could be messing with, because if somebody came along and somehow changed that invoice number and passed it around, it could maybe create problems. But that's really just the first thing that I can think of off the top of my head. But to use a constants in JavaScript, then you would just use this const, and you can see that it's a keyword. So Chrome actually supports this, so we're not going to be writing this in our text editor, because if we were to use it in our text editor and then use Babel to compile it, Babel will just turn a constants to a var, because constants is not supported in all the browsers, and then we wouldn't even be able to test our assertion here. So we're going to say basically this is an immutable string. And immutable means that once you declare it, you can't change it. So typically with functional languages, you hear a lot about immutable data types, because less memory has to be set aside if a variable never changes. It's technically not even a variable at that point, because it doesn't vary. It's just always true and constant and never changing. So there's less memory that needs to be set aside for that value. So this is a constant string. All right, so now we've declared the immutable string. So if we type it, you can see that it returns that value. So now what happens if, like, later on in our program we try to say, you know what, immutable string, you're now equal, I have changed you. Chrome's going to throw you an error and say it's not possible, you can't do that, it's a type error. You tried to change the value of a constant. So that is typically what you would want if you declare a constant in the first place, and if you really wanted it to vary, then you would use a variable or even a let, assuming you don't want to change it within the lexical scope, which is what lets are for. So let's also take a look at an interesting thing. Now, if I were to say immutable object equals, or you know what, instead of var, I'm sorry, I'm so used to var, I'm going to say constant immutable object. So constants don't have to be of type string, this could be an object, and if we look at immutable object, you can see it's an object. Now, if we go ahead and we try to change it to something else, you will get the error, but you can attach objects to it. So I could say immutable object dot test equals, this is a string added to an immutable object. So you can see that that actually worked just fine. So if we actually type immutable object and it returns what it is, you can see that it has test attached to it. So if I said immutable object dot test, it returns the string. So that, I think, sometimes throws people off, that just because you have an immutable or constant object in JavaScript that somehow you're not going to be able to mutate it. You can mutate it just fine through its properties, but you just can't change it and assign it some other value, or even another object for that matter. ES6 tutorial, and we're going to be looking at subclassing and JavaScript. So the ES6 brought us classes. We can also extend the classes by using subclasses, and to do that, we're going to create a class called member, which extends the band, and it actually does it the exact same way that I described it. So I'll say class member extends band, and then we put it inside curly braces. So now here I could actually like do something like overwrite print name. So I could say, you know what, this is going to implement its own version of print name. So I could say console.log, this is an override. Alright, so now if I were to go ahead and just say down here, base high, we're going to new up a member instead of a band. Alright, and then we can say print name. And then just for S's and giggles, we're also going to print the parent function that is not being overridden, which is print origin. You'll see that that also works the same. So let's go over here. And you can see this is an override, and then origin, Queens, New York. So we were able to carry on with the functionality that we need. Now, one of the interesting things to note is that you can see that member, since it extends band, it still needs to pass in the arguments that are needed for this, for these values to exist. So like if I were going to say, you know what, let's create a constructor on this sub one. So we'll say constructor, and we'll say origin. This isn't going to work here. Let me show you why. Okay, so we could say, you know what, this dot origin equals origin. And we'll go ahead and, you know what, that's a shit thing to do. Let's do genre. Because genre we haven't done. We're going to say this dot genre equals genre. So now let's go ahead and do a print genre function that only exists on the subclass. And we'll say console.log this dot genre. Alright, so watch what happens. If we go ahead and we say, you know what, let's pass in this third argument, and we're going to say alternative is the genre. So we would expect the first two arguments here to be assigned to these two, and then we would expect the third to be assigned right here. So let's see what happens. And we're going to go ahead and print the genre too. So we're going to say bayside.print genre. Alright, let's go ahead and try this. And you can see we get nothing. So we obviously had a compilation error. And you can see one of the issues right here. It says this. It doesn't know what this is in the subclass. And the reason why is because anytime you're going to try to reference a property from within a subclass, you need to call super. before you can do that. So you need to say super, and this is weird, but yeah, you call it super, that way you can reference the this properties from the parent class. So let's take a look at this. And now we get, this is an override, origin's undefined, and then we get Bayside. So why is origin undefined? Damn, why is it undefined? Oh, because the subclass didn't get it. So the subclass needs to actually take in all the same values. So I would have to do name, origin, genre. And then we'd have to go through this painstaking process of being like, you know what, let's keep this in order. But we would say this dot name equals name, this dot origin equals origin. All right, so we have to explicitly, state these out and take these in. And now that we're taking them in, this should all just work fine. You can see we now get all three. Now the interesting thing that you're probably thinking of is you're probably like, well, damn, that sucks. That, like, why do I need to call super then? Well, technically, at this point, I think you still do just to reference this. Yeah, you do still. Okay, so you always have to call super anytime you're going to do this from a subclass. But in addition to that, if I didn't have to have values assigned through the, values being passed into the constructor, like you could have this dot, let's just say car equals Honda Fit. All right, so now if I were to say, this dot car, in fact, I don't even have to do that. I could, we'll say this dot car equals. In fact, we'll just console log. Console.log this dot car. Let's do that. I feel like my example is getting a little bit too complicated here, but here you can see it can get Honda Fit. If we didn't have super, it wouldn't work. So let's just look at this real quick. Let's get rid of all three of these values. Let's pretend it doesn't need any values at all. It'll actually ignore the values passed in. So this time we're not assigning anything, so we shouldn't have, but it's the same situation. Like, even if we're trying to reference something that's assigned to the parent, like this is statically assigned to the parent class, it's still not going to work without super. Super has to be there. So we add super back, and you can see it's back. So the fact of the matter is here, guys, is that super doesn't have anything to do with your whole constructor arguments being passed in. Super is all about, do I need to reference this? Do I need to reference properties on the object that I'm inheriting from? And if the answer is yes, you need to reference those properties, then you have to call super. So that's all about subclassing and super in ES6. In this new one, we're going to be looking at a new way to write our for statements in JavaScript. So in writing a for statement, a lot of people use jQuery, so you could use the each function and all this stuff, because JavaScript didn't have like a very good for loop. Not a very friendly one, not like with Python or even C# for that matter. So if I were to have an array, I'll say var my array equals, and this is going to be 1, 2, 3, 4, 5, 6, 7. Alright, so I got 10 values in my array. And the old way, I'd have to go like this: for var x equals 0, x is less than my array dot length x. So add 1 to x, and then I could say console.log my array x. So that's the old way. Let's go ahead and take a look at that. And you can see that we have 10 values that are console printed out. Now, the new way is we're going to say for, and we're using let. This is why let came first of our tutorial series. And we're going to say my array. And then we can just say console.log I. So I'll let you guys be the judge on which one's a little bit more concise and easier for you to remember. As far as performance and things like that between the two, I'm not really sure of any performance differences. Looks like I'm getting a breakpoint there. That's in my source map file. Anyway, so you can see that both of those outputs, they iterate through an array of 10 values and they console log it. So this is a lot more concise using the newer ES6 standard. So there's not a whole crap load to talk about there, but just wanted to make sure you guys are aware of the new for statements in ES6. The biggest feature of ES6 is module loading, and module loading is what really is, it's allowed JavaScript applications to become just little scripts that got included here and there to actual, real programming applications that give way to React and Redux and Angular and all these other different very large projects. So they're broken up in all these different files, but how do you get all these files to actually converge together into one big file? And that you need a module loader or a module bundler. And there's a couple of choices that you have. The two popular ones are Browserify, which is the older kind of way, I would say. A lot of people use things like Grunt or Gulp, and then they use Browserify to actually import the modules that are needed. And this is somewhat of a, I think, confusing concept for beginners. But Webpack is now the new front runner as far as being the popular option for module bundling, so that you can break up your modules and then require them as necessary. So we're going to use Webpack in this tutorial because at the time of this video, that is definitely the most popular option. I'm going to press Control-C to get our watch to stop. And we're going to go ahead and use npm to install Webpack. So we're going to say npm install -- save -dev, and then we're going to say Webpack. Alright, so now that Webpack is installed, what we need to do is create a webpack.configuration file. So we're going to create a new file, say webpack.config.js. And inside here we need to say module.exports equals, and it's a JavaScript object that's being exported. We're going to give it an entry point, which is going to be the file that we currently have, which is first.js. That's the entry point. And then our output is going to be an object that has a path, and we're going to say dir name, and then file name is where we're going to say bundle.js. I'm missing a colon there. Alright, we want to tell Webpack to do the watching just like we did before, so we're going to say watch true. Now we need to add a module argument here, because this is where we're going to tell Webpack to actually use Babel in order to build our project. So we're going to say loaders, and we're going to add a loader. And this is where we're going to say the loader itself is Babel. And here we can tell it to exclude anything in our node modules folder because we don't want that to be compiled. So I can just say node modules like that. So that way anything inside the node modules will be ignored. Finally, we do need to say query because we're going to tell it to use a presets, which is actually, you know what? I'm not going to tell it to do a preset. I'm going to see if this will work without the preset first. Alright, so that should be about good. Now we need to go into our package.json, and where we added the Babel argument, we need to now do the same thing for Webpack because we're going to run it the same way. Alright, so now we have that. And if we go back to our command line, we should be able to say Webpack or npm run Webpack. Now automatically Webpack is going to look for the Webpack configuration file, and it's going to look for the first file, which, did I put that right? Let me see. Yeah, first.js. Okay, let's see what's going on here. Alright, so Webpack is thinking, so it says I can't find module Babel. Alright, so it looks like because Babel, like the Babel that we have installed so far in our package.json, we have just the Babel preset environment, Babel CLI, which works great for the command line interface, but we actually need some additional Babel projects, it appears, in order for this to all work correctly. Two of them appears to be Babel Loader and Babel Core. So let's go ahead and install those real quick. We're going to say npm install save dev. Once again, we're going to say Babel Core and then Babel Loader. Babel Loader should actually tell, I mean, I would think that this would work. The Babel project changes all the time though, unfortunately. Alright, so now that we have that, let's try this again. All right, so that's the two dependencies that we were missing that we needed in order for Webpack to actually be able to use Babel and be able to compile. So now the big question is going to be, based on what we had in first, does this all compile still the same way that we had? So it looks like we have some breakpoints here. All right, so now we're using Webpack instead of straight Babel in order to be able to build our file. So if we look at bundle here, now of course there's not going to be a source map option at this point because Babel's not building the source map for us. But here you can see there's quite a bit more now in bundle now, and this is a lot to do with what Webpack is doing. So either way, this is definitely the best approach to go, and I'm going to show you why, because we have first.js, and now let's go ahead and add another file, which we're going to call second.js, just so we can easily differentiate first from second. And what I want to be able to do is say, we're going to say export default function test, I guess I'll call it test second, and this is going to be just a simple function that says alert I'm loaded. Alright, so now what I can do is I can now import this function here from second. So at the top of my file I can say import test second from I need to give it a file path, so first.js. Alright, so I think that file path, this might throw an error, but what we're then going to do is we're going to test second by actually firing the function from the first. And let's make sure Webpack is watching. It looks like it says can't find file directory first, so I might have that wrong. So I'm going to get rid of that dot. A dependency to entry point is not allowed. Sorry guys, it's late at night and I'm being stupid. I'm importing from the same friggin' file that I'm in, which Webpack clearly tells you you're not allowed to do. We're trying to import from second. That is ridiculous. Alright. So, and I even changed this. So we can go back to having this be like this. I'll explain the differences between these two module importings in just a second. But let's go back here. Now we're bundling again just fine. And if we go to our file, test second is not a function. Alright, so let's go to the file real quick. Just out of curiosity, I'm going to see what, I'm going to console log test second. I'm curious what test second actually is coming through as, because I told you there's a difference between using these curly braces, which means that I don't have to import the entire thing. I can just import a specific function on an object, or even on a class that's being exported by using this method. But I'm curious if anything even comes over. Yeah, it's undefined. Okay, that would make sense. Alright, so the real difference here is that you want to just avoid these curly braces for a standard function that is just exporting default function, because it's just exporting this. By default, it's saying, hey, export this. No matter how you import this file here, you're going to be exporting this one function by default. So let's go ahead and show you this. This will actually work now. So import test second from second.js. We're now importing JavaScript file as needed and executing it. And you can see I'm loaded, so it is actually loading just fine and executing. So what's extremely interesting here is, this is something I didn't even notice until I tried it, but when we originally tried to do this and wrap it in curly braces, I didn't even realize that this wasn't allowed. And it's kind of interesting how it's not allowed, because if I said test second and I look at test second, you would see that this is the function that is being brought in. But for whatever reason, it doesn't work when you say, hey, I want this to be the default function. And the reason why you want a default function is that way you can import it the way that I showed you that was working. But here's why it's interesting. Because if I created another function in here that's not the default function, I said export, this is what you commonly see. You'll see export function, another method, and then we'll say alert, another method. All right, so now we have this second method, and if I were to import second or another method from second.js and execute it, then this will run no problem. So you can see another method gets executed. It didn't complain. It only complains when it's the default function, because it basically says, hey dumbass, like you don't want to import just one piece of this module. Alright guys, so definitely play around with module loading, because this is like I said, another huge part of ES6, and not just ES6 but modern JavaScript, large project development in JavaScript. Hey guys, what's up? So in this video I'm going to be telling you about one of the most important features of ES6, and literally this is literally the most important feature, I think, for any sort of modern JavaScript that every developer should know and have in their arsenal. So this is something I didn't really discover for a long time, and I know it seems kind of stupid or whatever. I'm not ever claiming to be the best developer in the world. I'm really not. I try to be up to date, but I'm simply not. So source maps is something that has been out since the HTML5 specification. It's taken a little while for tools like Babel or Webpack to be able to get them up to date, and also for browsers to be able to use them. But Chrome has the ability to use source maps to your advantage. So if you wanted to read about source maps, you can go to this HTML5 Rocks article about it and learn all about it there. But I'm going to teach you everything you need to know in order to be able to use it. And with Babel, it makes it very, very simple. But I want to explain why this is so important. So let me go over to the, we're going to go to, like, say, the React project on GitHub. Now, if you look at a lot of modern day JavaScript that's being written, and actually I'm going off the top of my head, so I don't even know if this is going to be the best example or not, but let's just see. So here you have React component. So you can see it's using these require statements, which is like Node.js module importing and things like that. So obviously this project is being compiled just the way that we're using Babel to compile our code, and it's being brought into this React.js file that we end up including into our project. But React.js as itself as a project is much greater than that. It's much more complicated. It's spread out all over different files. They have builds and unit tests and things that are being written on it. But with source maps, what it gives you the ability to do is it actually gets you the ability to step through your code before it turns into the then compiled. Like if you ever tried to step through React code, like when it's not even minified, even unminified React code, it can be very difficult because React's being run through stuff that cleanses it, and its ES6 is being changed to older versions of JavaScript. So even the code that you write when you're trying to debug it in the browser, it's different than what you wrote. So source maps gives us the ability to actually debug ES6 the way that we write it, and that's why I said it's extremely important. So if we look at what's going on here, let's run this this command here just the way we have, and just so you guys know, when we're doing npm run Babel, we're telling it to run first, and we're outputting bundle.js, and then we're saying -w, which stands for watch. That way we don't have to keep running this command every time we change our file. And it takes this first and it compiles it to an older version of JavaScript into this bundle. And you can see this compiled version is quite a bit different than what we wrote over here. So wouldn't it be helpful if we could actually debug what we wrote over here than this? Because it gets a lot more complicated when you have a file that has 25,000 lines in it and a bunch of different projects. So source maps gives us that ability, and it's as easy as doing this. We're going to press Control-C to stop this watch, and all I have to do is say -- source maps. So now what this is going to do, it's going to work the exact same way, but if we look at the folder structure, we're going to notice, or if you look over here, we're going to have this bundle.js map file. And it looks really weird, it's cryptic. You don't have to understand what's going on there, but what I want to show you is that if we go to our page here and we inspect, We look inside of our console. Let's just refresh this so you can see all that stuff is outputting the way it was in the earlier videos. But if I go over to sources and I look inside this bundle, so one of the things I want to make sure you guys have this enabled, if you go over to Chrome and click these three buttons and go down to settings, I just want to make sure you have this enabled. If you scroll down, you should see enable JavaScript source maps. This has to be set to true, and if it's not, you're not going to actually be able to do this. Now if I refresh, watch what happens. Yeah, so you can see source map detected. So we actually want to be able to see that, but we're not going to be stepping through our bundle file. The goal is to be able to step through this class file in first, even though first isn't even associated. You can see if we highlight over, it says from source map. So first isn't even, remember, we didn't even include first into our HTML page, but the source maps are finding first, and it's basically being able to map the code from bundle to first. So if I refresh, then I hit this breakpoint in first, and once again that's yeah, I might have to be careful because hitting F11 on my computer ends up shutting off my recorder. But let me go ahead and just step into the next call, and you can see. Okay, and now I'm stepping down in here, and now you can see the arguments passed into the subclass. Super hasn't been called, so I'm going to try to step out of that. But once again, the benefit of a source map is the fact that you're able to step through this code without actually having to go into the compiled stuff. So let me just get out of here. Right? Those VM files are part of the I think Chrome and the way that Chrome is executing the JavaScript. I think a lot of that stuff happens in memory. But the idea is that you would be able to put breakpoints on certain areas like this console log statement. And if you refresh it, I guess that one got overridden though. Hold on a second. Yeah, the first print name was overridden. That's why that breakpoint didn't get hit. But once again, it's a beneficial thing that you're able to step through, because especially when your code gets very, very complicated. And I've been able to do this also with React and Redux, and a lot of the ES6 that I'm writing in React and Redux. It makes it so much easier to be able to step through. Node.js uses JavaScript, and the way it uses JavaScript, and if you guys are familiar with JavaScript, JavaScript cannot be executed outside of the browser. So if I say alert hello world, I'm executing this from inside the browser. Now it's going to run because it's something that JavaScript can do. The alert is a built-in function that's part of the JavaScript language that alerts that pop-up. Now this JavaScript that is being executed, when I click enter, it's actually using Chrome's built-in JavaScript engine, which is the V8 JavaScript engine. So this Chrome engine can read the the JavaScript and know what to do. Now that said, Node.js is not actual JavaScript. It is written in C. So if you go to GitHub and you look at the source code for the actual Node project, you can see that all this stuff is these header files and everything, but it's all C-based code. So this is all raw C. And the reason why is because JavaScript can't access file systems or anything like that. It can't run outside of the browser. It's not made for servers and sockets and all that other stuff. So that is all written in C, and as you know, C requires a lot more code than a more higher level language like JavaScript or Python. So the amount of code that is being written for you with this Node project allows you to essentially create web servers using the Node technology. With about 20 lines of code, you could have a working web server, where if you wrote that in C, you would have much more code on your hands, but Node does that. Now Node says, hey, you can actually extend and use this framework anywhere you want using the JavaScript language. And when it does that, it actually says, okay, in order for us to interpret what you're actually trying to do with the Node project, we use the V8 Chrome engine to then transpile or compile whatever JavaScript that you typed which then tells Node.js what to do. Node.js is considered an event-based system. So event-driven programming is essentially this. They give the example in the Wikipedia here where it's a UI. So you hover over something, an event gets fired, and the event gets sent out to some other, some handler, an event handler, and the actual thread that is running the UI doesn't know how to handle the event. It just knows how to send the event. So that being said, the Node.js project is built so that with this event-based system, that it can handle as many requests that you throw at it. It doesn't mean that it handles it any faster than any other technology out there, although the V8 engine is very fast, and as well as Node because it's written in C. It doesn't mean that Node.js just somehow magically can handle CRUD applications, which stands for create, read, update, and delete, which is your typical database website for any sort of content type thing, whether it's Wikipedia or Spotify, anything that has to read from a database and update and all that stuff, whether you're using an API that's RESTful or SOAP based, it doesn't matter. The point is that for all these things that need to be done, like actually querying the database, grabbing data, reading from it, and so that all still takes time with Node.js. It doesn't do it any faster for the most part. However, it doesn't block. So while that request is being made, if you were going to use something like Python for a web server, it's going to spin up threads to be able to handle all the different processes all the requests that are being thrown at it. Whereas the Node system is more of like a queue. That's the way I interpret it anyway, where the request gets stacked up in a queue and it's being served first in, first out. So FIFO. And that's essentially it. So it's an event-based system. It allows you to write server-side languages, and that and it gives you much more power and flexibility than the JavaScript language normally would. But it's not JavaScript. So it reminds me of a news article that was going around the other day where some ransomware software was being sent around. And in the ransomware, in case you guys have never heard of it, it gets downloaded on a machine. It locks some sort of file. You have to pay a ransom, and then it decrypts the file and allows you to access it again. So there's been like a hospital got hacked one time, and their entire IT infrastructure had a ransom on it, and the FBI basically said, "Hey, pay it," because there was no way to really solve the situation. And I believe that's what they ended up doing too. But the point is that the entire news article was like, this is a first of a kind because this program was written in JavaScript and all the browsers run JavaScript, and basically the same kind of bullshit media that we always read about where the sky is falling and they take things out of context because they have no idea what the fuck they're talking about. And little do they know, it's not JavaScript that's accessing the file system and encrypting and all the other bullshit. It's all being done at a C-based language, on a C-based language at a C-based level that has access to all those different things. Just JavaScript made it much easier for them to write a C-based program in order that it had the capabilities. Hey guys, this video is brought to you by Dev Mountain Coding Bootcamp. If you guys are trying to get your foot in the door in the software development industry, make sure you check them out. The link is in the description tab below. They have really good reviews, and they're focused on all the latest web development technologies to get your foot in the door as soon as possible. Hey guys, what up? So welcome to this new tutorial series on Node.js. I'm going to try to cover everything that you need to know on this. This is going to be a crash course in the sense that it's going to be very, very quick. So number one, in order to get started, you got to go to the website. Node itself is just a technology stack. It's really just a library. A lot of people associate it with being JavaScript, but it's really not. It was actually started in 2009 by a guy named Ryan Dahl, and from there it ended up taking off. It was built on Google Chrome's V8 engine, and really that's an engine that was written in C and C++. But Node.js is all about being a server-side technology stack, a non-blocking, event-driven I/O that basically can handle a lot of network traffic. So that's why Node is so popular. So in order to get started with Node, you just need to go to the website, download Node. It actually is an install program if you're using something like Windows. So you're just going to install it on your machine. So in order to see if it's actually been installed correctly, you can just go to your command prompt, and then from here you can actually just type Node. And if it's installed correctly, you're going to end up getting the Node command line. To get out of that, just press Control-Z. So one thing I do want you guys to be aware of is that Node.js itself is really just a wrapper around V8 engine, Chrome's V8 engine. So it's using JavaScript to interpret. So anything inside the Node shell, you can actually write your Node code or JavaScript code right in there and see the output. So if I just want the console log hello world right in here. So it's very similar to Python where you have the interactive environment. It's the same thing because Node.js itself is just an engine. And again, like you can interact with that engine through this command prompt if you wanted to. Now, it's not really feasible that we're going to end up writing a bunch of code that way. So it's better that you end up using something called an editor, like if it's any sort of text editor. And for this tutorial, we're going to be using Visual Studio Code because it's the easiest to get started with, and it's absolutely free. There's no cost or anything, and it works across platforms. So it's one of the best tools out there, I think, right now. So go ahead and download this for Windows to get started, and then we're going to go ahead and open that up. So once you have Visual Studio Code pulled up, what we're going to do is we're going to open up to a workspace. So you just want to open a folder from the file. Inside of here, I'm just going to have a Node folder for my tutorials that I do. There's already a Node folder. So I'm going to be working out of this one. I'll just say tutorial. All right, so that's what I'm going to end up using for my workstation. You can actually have yours wherever you want. It doesn't matter. So you just tell Visual Studio to open to that location. And now when we go ahead and we create a file in here, we can create a file that Node can actually run. So we're going to just say test.js. And then inside of here, we're going to do the same thing where we just say console.log hello world. And I'm not going to update all this crap right now. All right, so now that we have this this file, so how do we run it? Well, you could go to the command prompt basically by saying open in the command prompt if you wanted to. So this uses PowerShell, and it actually opens up right to where the application is. So if I wanted to run the program, I would just say node test, and it's going to run the project, and it's going to say hello world. Now the editor itself is actually much more convenient though. So what we're going to do is click on this little bug icon for debug. And then when we go to the configurations, we're going to do the drop down and say add configuration. And then from here, you're going to see that it has Node in here by default. So you're going to want to select in here the Node, and we're just going to say, you know what, Node.js launch program. That'll work. All right, so now we have this launch program icon. So now if you go to the file that you actually want to launch and you click on the debug, then you can go ahead and run it, and you should actually see the output and a command prompt. 1 second. Oh, sorry, we didn't actually. Let's open up the launch config. You can see it's looking for a project called app.js. That's a more standard name here. So let's go ahead and change that here. We're gonna rename this to app.js. And then once again, go ahead and run it. And then we get our hello world down here. So it's much easier to actually edit our files and everything. Just go over here, click the play, and it'll run the project. All right, so now let's look at how to import and export modules in Node.js. Now, one of the things I want to mention is that ES6 Node.js is actually the module loading syntax for ES6 is not supported. So we're going to be using something that's a little bit different. It's more along the lines of a common JS module loading, which is a little bit more old school. But unfortunately, Node.js itself is not going to be supporting the new ES6 module loading syntax anytime soon. So let's go look at how we actually then make modules. Let's go ahead and create a file, and we're going to call this my first module.js. And inside of here, we're just going to go ahead and create a function. So we'll say var x equals, and this is going to use the new fat arrow syntax in JavaScript. And it's going to go ahead and take in a value. Let's just say it takes in a value. And inside of here, we're just going to go ahead and just console log the value that gets passed in. Now, in order to be able to export this function, we need to go ahead and do something. We need to say module. And then module has something on it called the exports, and exports is really just an object, and all we have to do is just say, you know what, we want it to return X. And because it's using the new ES6 short syntax here, it's actually behind the scenes, it really just means that. So really you could give it a different name if you wanted it to say this name or something like that. You could actually have it so then you could call X as a function using this name, but shorthand, let's just go ahead and just return it X. And you know what, let's go ahead and give this a better name, because X is obviously a terrible name. So we're just going to say console console log is going to be the name of the method. And we're going to return that instead of X, because you always want to be descriptive with your method names or variable names. And let's go ahead and import that into our app.js file in order to be able to call it. So we're just going to say var my module equals, and then we're going to say require, and this is actually how it requires it, and you give it the path to where the name of our module is. So my first module, and it shouldn't matter on case, at least on Windows, but other people it might. And now for us to be able to use module, you can see that the IntelliSense is like, okay, you want to use module. And if I do dot, IntelliSense is also pulling up and it's saying, oh, you can use this function called console log if you want. And you can see console log has this value. You can pass in any type. This is actually more of a TypeScript syntax that we're looking at right now. But going into here, we can see console log, and we're just going to pass in Chris, and then call this this program. And you can see that we're outputting Chris. Now, because nobody is an expert on all of the supported syntax for ES6 and Node.js, the best place to go is probably this website right here, which is called node.green. And we're hoping that everything turns green here, but clearly there is not. But all the newest stuff is actually being supported. So this is all ECMAScript 2016, or I'm sorry, 2015, which goes by the name of ES6, which is very, very confusing. But you can see there's still quite a bit that's not actually implemented yet. So it's probably going to be some time before this is all green. But if you ever have a situation where there's a syntax error and you're like, why doesn't that work? It's probably because you're using an ES6 syntax that's not quite supported on Node.js right now. So Node.js comes with a package manager that's built in by default. It's called npm, and it really is just a repository, a server that delivers bundled JavaScript code on request. So there's all this code that's already been written for things like authorization, authentication, things like that. And you just want to use npm to be able to tap into all that code. So let's go ahead and do that right now. I'm going to actually install something with npm, so it's going to create a project folder or a file for us. Let's right click inside of our folder explorer here, and I want to actually say, no, we'll just say open in command prompt. We'll just run it from there. All right, and from here I'm going to say npm install, and let's install Express, which is a web framework. All right, and you can see now it's actually installed. So we have a few things in here. We have this package.lock file now, and this is all this information is pertaining to what type of project our Node.js project now consists of. So this went ahead and created a bunch of stuff, and you can see all the dependencies for our project are actually located inside of here now. So it's quite confusing. There's a lot there. You don't have to deal with too much of that. I wouldn't actually be looking at that too much. Now, as far as the Node modules are concerned, you can see now that we have all these different things, and these are all separate Node projects that all are used by the Express web framework. So it's really crazy, but the Express framework actually, this code base right here has its own set of dependencies, and inside of here you can see in its dependencies it's going to tell you what it needs, and it needs all this stuff. So if you see this, like, it's a web framework, so there's a lot of code in here. And it's installing all that stuff. So that's what's going on here. And that's why there's so much stuff in the Node modules folder, and then also inside of your package folder, because Express is so big. You can see now we have all these dependencies. So another thing you'll notice if you take a look at this is just a JavaScript object, and it's a JavaScript object that has objects of the name of the actual project, and inside of there you're going to see the actual version, and then if it has actual dependencies, you're going to see what it is that it's actually depending on for all of these. So you may be asking yourself, why the hell is this so confusing looking? And the answer to that question is it just is. There's a lot of different projects, and clearly your project, if it relies upon another project, you want to know the exact version of that project that you're relying upon. So there's just a lot of overhead there. And another benefit of something like this is that when you go ahead and you say, I want to save all this to my Google Drive account, and I'm going to share this project with my friend, on your friend's machine, he doesn't have all this stuff installed, so it's not going to run for him. But all he has to do is go to the command prompt and go to the folder wherever he puts your project at, and then all he has to do is run npm install, and it's going to install everything that your project needs, and he's going to be able to run it then from his computer. So it's very easy to just have everything all laid out in this package.json file. And it's keeping track of so much stuff that you don't want to have to keep track of yourself. So in order to build a website quickly with Node.js, it's probably best to just use the Express application or the Express framework. It just has so much code that's already written for you. As you can see from how much stuff it imported, that doesn't necessarily mean it's a good project, but it is just because everybody's using it. So let's go ahead and write some code in here to actually be able to use Express. And we're going to use the new constant keyword, which is it's a much more memory efficient way of storing variables that are never going to change for the JavaScript engine. So if there's something like that, you want to go ahead and use that. And we're going to say require Express, just like we did in the previous example of actually using our own module or creating our own module. Let's create an app, and this app is going to be, it's going to go ahead and invoke the Express object that we went ahead and imported, and that's going to create our Express app. We're going to go ahead and set the port on which the app should listen, and it's going to be port 3000. And then we're going to go ahead and define our route. So our route is going to be the root directory of the project, and we're going to say when you match that route, go ahead and pass in your request object, which is going to have everything like their IP address and things like that. We're going to give you back a response, and this is the response object that they expect to have returned back to them. And from here, let's just go ahead and say resource.send hello world. All right, so that's the gist of that. Now we need to go ahead and say listen, and we're going to tell it to listen on our port, the port number that we assign, which is 3000. And then we just go ahead and pass in the callback function. And the callback function is going to use the arrow syntax, which is also ES6. And then from here, we're going to use also the template literal, which is a new feature of ES6 as well, and this actually is supported in Node. And you want to use the backtick character, and it's really just awesome for making templates and everything. It almost solves the template engine problem of why we have so many different template engines. This template literal syntax is really awesome. So you can see in here it just acts like a normal string. So we could say we are listening on port, and then from here I can go ahead and I could use the $ symbol, and then inside the braces here you can see it's I can now reference an actual a variable that we have inside of our application. So instead of having to say plus plus this and plus that and all this crap, we can use that, and it's much easier. All right, so that's really it. So in order to run this application, we just want to go back to our little debugger, press the play button. And now you can see that it's listening on port 3000. So if I went ahead and went to a localhost address and put in port 3000 like this and just press play, you can see that we're getting hello world back. So by visiting your localhost address on your browser, the Node.js application, it's a web server, it's actually returning an actual web page. So when I say it returns a web page, it's really not. It's returning a web response, but the web browser is treating it as if it's HTML. But the cool part is that you can actually put HTML right in here. So I could actually say, you know what, let's just do an anchor tag. Anchor href equals, and this is going to go to my YouTube channel. So we're going to say click me and close off our little anchor tag. Save it. And what I want to show you is that when we go to try to refresh this, you're going to see that it actually doesn't take effect. So you have to actually restart your application, unfortunately. So now it's listening back on 3000. And if we refresh it, you can see click me. If I click on it, it's just like HTML. So in this tutorial, and it goes to my channel. So that's really all it is. So you could actually have it return whatever it is you want. Now, in just a moment here, we're going to see how to use the file system to your advantage, so you don't have to actually write all that HTML out. We can go ahead and just have a file system of HTML pages that Node.js is then reading and returning as HTML, and then the browser interprets it. So we'll see that in just a second. All right, guys, so now what I want to do is I want to, instead of actually hard coding this response here, it's being treated as HTML from the browser by default, but what we want to do is actually have this a little bit more abstracted, you know. So like we want to have like a templates directory. So if we wanted to essentially deliver HTML pages from a local folder, we could do that. So let's go ahead and create a folder called templates. And inside of here, I'm going to create a new file, and we're just going to call this index.html. It could be whatever you want. I'm going to paste in the link that goes to my channel, and yes, you guys should subscribe if you can. So in order to be able to read that file, what we're going to use is something called the fs module. So we're going to say fs equals require, just like we do everywhere else, and we're going to say fs. It stands for file system. And then inside of here, this resource.send is actually it's a response that's being returned from this function. But what we want to do is we want to say resource.send. We're going to go ahead and use the fs module. So we're going to say fs.read file, and then inside of here, this is where we give it the path to what file we're looking for. So it's in the templates folder called index.html. We're going to say that the file type is the encoding is UTF-8. Let's just say that, and then we go ahead and pass in our function, which has two values. There's an error value and then a data value. And then inside of here, we could say if there's an error, console.log. Holy crap. So this is where you would want to probably log the error. If not, we're going to go ahead and simply say we return the data. All right, now let's go ahead and see the activity that occurs when we do this. I'm going to go ahead and run the program. Now, when we go to visit the page, what you can see is that there's no data being returned. And the reason why is the response is coming back from the server before the file system is ever read. The event system of Node.js is non-blocking. It's asynchronous to the core, so it's not going to wait for anything. So you need to have a callback function that is being executed if you want something to essentially wait. You need to have an asynchronous model. So how do we stop that from occurring? Well, what we want to do is we want to say, you know what, don't just go ahead and execute this function. We want you to say, we want the function resource.send to only execute once the data is returned. So clearly we need to go ahead and remove some of this stuff. We don't want to call the function right here. We're going to need to close off our statement here. Wait, I think. No, not there. We need another curly. No, we need that. Yeah, there we go. All right, there we go. And then we don't need that. We do need to close off that. This should be probably like that. And there. All right, so I know that's confusing there. Hopefully you guys can follow along. All right, so now instead of just saying return data, what we want to do is we want to use the resource.send data. So what is occurring behind the scenes here? Node.js it received a request the first time, and it said, okay, let me fire off this resource response. And the resource response was actually a function, and it actually was a process that was occurring where it actually needed to go in, read the file system, get all the data, and then spit it back out. And it wasn't waiting for any of that to occur. It was just immediately returning a response, which was just a blank page. That's why we didn't see anything. Now, by changing it around to say, you know what, app.get, when you get the request, go ahead and fire off this fs.read file function. And then once you're done and you've read that, you're going to fire off this callback function. And then inside this callback function, it says if there's an error, go ahead and freak out. But if not, then it is going to try to execute anyway, even with an error, unless the execution ceased. Assuming, well, no, I'm sorry, the execution would cease right here. So this is where you would end up obviously logging out to any sort of server or anything. So this would not be called. But anyway, so resource.send, it's going to send the data, and then that's it. So now it waits for that execution to occur. So let's go ahead and start the server. Pull up our browser that was returning blank before, and you can see that we now get the same result. But this time, it's actually getting the result from an actual template file. So you could actually have a bunch of index files. This could actually be a bunch of like some real HTML. Some if it's not like truly dynamic data, I mean, you could have a pretty sophisticated website that's just served up from static files. That's there's a lot of talk and discussion these days about static file content websites. Basically your typical restaurant industry or something like that. If it's like a small mom and pop type of place where they're not doing orders online, if they're just trying to show their menu or something, or information, like if it's a flower shop, you know what I mean? Like there's a lot of businesses out there that do not need database connections and things like that because they don't need it, and they're not interested in it. So you could be like a consultant making a bunch of static sites, maybe, I'm not sure, who knows, but that's wherever you guys go with your Node.js development. It's up to you. So thank you guys for watching this course. I'll be expanding on it, and then also if you guys look at my work, there's a bunch of courses on Udemy, including this full course will be on Udemy as well. But make sure you guys check me out there, and I appreciate all the support. You guys have a good day. Bye. Last where we left off, we used the Express framework, got it running with the Hello World example. And now what I want to just jump into, which is one of the harder parts, is actually getting it hooked up to a database. Node and Express works with a lot of different databases out there. I typically like to stick with the relational database. I've used Mongo. Mongo's okay, but it's just very unfamiliar for me. So I just want to use MySQL. So if any of you guys want to go along the same route, you can do the same thing. Just follow along. So what we need to do is we need to use npm to install MySQL. And first things first, you also have to make sure that you have MySQL installed on your machine if you're going to be using that. And to be able to log in on Windows, you would go to where it's installed and then go into your bin directory. This color is friggin' terrible. One second. My God. Yeah, that looks a little better. Sorry if this is hard to read. I can't make it any bigger. But if you go to where it's installed under the bin, this thing's going to ask you for your password. So I'm going to put that in, and then, oh God dang. That is not cool. Oh, there it goes. I was just typing it wrong over and over again. So once you do that, you should be able to log in, and let's go ahead and cancel out of this. How do I do that? See, oh God dang it. Maybe I can type exit. Alright, there we go. Alright, so we're out. So now let's go over to where our folder is, and here's where the app is listening on port 3000. I'm going to end that by pressing Control-C, and then we're going to use npm install MySQL. So let's go ahead and see if that actually did anything to our config file that we have. Remember, this package.json file is the actual configuration settings for our Node app, which it doesn't look like it actually changed anything. So let's go ahead and grab, I'm going to just do a copy and paste here over to my app file, and we're going to find out if we have a connection problem here in just a moment. But let me just paste it underneath all this other stuff. I'm going to say variable MySQL, and I'm requiring MySQL, and then I think I'm root, I don't remember, and then I'm just going to put this password. Since this is a local password, I don't really care. So you need to put your password there. I'm going to leave the connection string. It'll probably throw an error, but I'm wondering whether or not this will give me an error if it actually can't connect, because I don't remember if my username is root or not. I also need to make sure that MySQL is running. I think it should be. It should be running by default if you installed everything correctly. So let's go back over to where our project is, and then we're going to go ahead and run our app. So you can see that the successful output there is the solution is 2. So that means everything was working right. So I had MySQL installed. I had the server running on my machine. I was using the default root user. I put in the password to the locally running database instance, and it actually connected to the database just fine, and then wrote out that basically test query. Alright, so let me go back over to my command line here where I have MySQL. I'm going to log back in here. And I'm going to create a database called post. So I should be able to then use post. And you can see the database was successfully created. So if I go back over to Node here under this password, I can actually specify here a database. And we're going to use the post database that we just created. And I want to kill Node for a moment and then restart it. And it looks like we're able to connect to it just fine. So I've actually never created a database table in MySQL shell without actually an ORM, object relational mapper that does it for me, and like things like Django and stuff like that. So this will be my first attempt, but we're going to go ahead and create. So I want to make sure I'm using the database. So I should say show tables. And there's no tables there, so we're going to go ahead and create table. And we're going to call it video, I guess. You know what? Maybe, yeah, let's call it video, because this is what it's going to be about, YouTube videos. And then we're going to give it a name, so I'll say title is the name of the column. It's a varchar, probably 50 characters. You know, maybe I'll do 100, just in case. And then we're going to say URL. This is going to be the same thing, URL space variable characters 100, and I think that's all I'm going to do for right now. Do a semicolon, so that went ahead and created the table. So if I say show tables, you should see that we now have a video table. Now let's go back over to our app. So I'm actually going to get rid of this connection query. So I'm going to remove the whole thing here. So we're going to insert into video, which is the name of this thing's looking for a variable title. So we'll just create a variable title real quick, which is testing. And then we'll create another title for the URL. I don't know that I made those fields mandatory in MySQL, so we'll just see if we can just enter in a record with just the title. So stop node again, and then we're going to try to do it. It looks like it's thinking a little bit here. Oh, actually, we're not even displaying that console log message anymore because I got rid of it. So let's see if we can look at the records inside the table to see if anything got added. So I could try the select all from table. See if that works. Oh, look at that. Title testing URL is null because we didn't add the URL. So let's go back over here. Alright, good. So our title got inserted into our MySQL database. So that is a success, guys. So that is how we hook up MySQL to Express and Node.js, and just do a simple insert query. So in future videos, I'll probably get into more of how we can manipulate the database using raw SQL is crazy to me. I've been using Django so long that I've never had to do that, so I appreciate you guys' patience while I was trying to work my way through that. And thank you, and please subscribe. Bye. And I have my database password and all that crap shown here, but it doesn't matter. It's just a local database. It's just used for these tutorials, so I'm not concerned about that. But what you have here is, in the previous video, we just went ahead and we hooked to MySQL. But we were doing some raw SQL to actually query the database, and this is just something that's not that great when you compare it to something that's called an object relational mapper that exists, which also is known as an ORM. Frameworks like Django or Entity Framework and .NET, they have this higher level abstraction that they call an object relational mapper that actually handles a lot of the querying of the database for you, so it does it in an efficient manner. Django has their own built-in one, and there is a project in Node, or just a JavaScript version, which is called Sequelize, and Sequelize is it's still a young project, but it has a lot of support right now, and it seems to be the best bet to have an object relational mapper in your Node website as of the recording of this video. So a couple of the requirements, though, is that if you haven't followed along in the previous two videos, you do have to have npm install MySQL, because that is needed for Node to be able to communicate with MySQL, and it's also needed for Sequelize. Now I've already actually installed Sequelize, but I'm going to do it again. And all we have to do is just say npm install Sequelize. And then you should see that it was successfully installed. Alright, once we do that, we need to go ahead and actually make use of it. So just like we've done in previous spots, we're going to go ahead above our app here, we're going to add this little using statement, variable Sequelize, requires Sequelize. And then now we need to go ahead and set up our connection string. Here's my MySQL database. If I show tables, there's no tables. The name of my database is called Post because the project is called Post. So I'm going to go ahead and create the connection string down here, and I'll go ahead and say this is the connection string. Not really a connection string, but connection object. And you can see that the name of the database is Post. The name of the user is root, and then the password is testing123. And then down here you need to say that the host is localhost, and then dialect, and make sure that you have your commas in here because this is just a JavaScript object. Now this is just the required settings off the bat, and we're not going to mess with that, but just have this for right now. This is going to be just the default. Alright, so in order to make a database in Sequelize, we need to go ahead and define that as a JavaScript object, since this is all JavaScript. We're going to go ahead and create a video table like we did in the previous video. So let's go ahead and say Sequelize define, and then we're going to give it the name of the table that we're defining, which is going to be called video. And then down here, if you've ever used like Django, or if you're setting up your models file and MVC.NET, it's similar. Of what we're going to do here, we're going to go ahead and just key value as a JavaScript object. So our title is going to be just a string. So Sequelize, we're going to make use of that. Sequelize dot string, and this is all capitals. And then we're going to have a description field. And then once again, we're going to use Sequelize dot text. And that needs to be all capitals. So let's go ahead and create this database. And the way we do that is we actually have to call Sequelize sync. So I'm going to copy this down here, and we're going to say lowercase, and it's a function call, so we have to use the open and close parenthesis. And this will create a database table if one does not exist already. So if one doesn't exist, this will go ahead and create it. If it does exist, it'll be ignored. So let's go ahead and test this out here. This is where I'm going to start my server. So I say node app.js and it'll start it. And it's just listening, and we don't have to actually look at the website right now. But what we're going to do is we're going to go over to the MySQL shell, and now we're going to look at our tables. And you can see that we now have a videos table. In fact, I wanted to call it video, but I guess videos is fine. We have now a table called videos. So if I went ahead and I queried everything, I could say select all from videos, and you can see that there's nothing in there. So it's just an empty table. Now let's go ahead and add something to that table using Sequelize. And we're going to do that under our, I'm going to say this is our model schema. Okay, and then this section, add to table. I'll just give it a videos table. So here we're going to go ahead and create another JavaScript object. We're going to call it video. And we're going to, actually, you know what, that's not what we're going to do. We're going to use the video model that we've already created. So we have this object that we've already created, so we're going to make use of it by saying video.create. And then in here, we're going to actually give it the values that we need to go ahead and set. So we have a title value, and this could be whatever you want your title to be. So we'll say node tutorial, and then a comma, and then it's going to be the description. This is a great video. Now we're going to use a shortcut, which is probably the best way to just get this thing done. We're going to say then function, and we're passing in the actual object that we just created. Dang it. Go ahead and close that off. So hopefully you guys can see this here. So just take a moment. This is, and so we're basically we're saying then, and then we're passing in a function that takes in the object that's getting created by this video.create command. And we need to call task.save. And it's a function call, so go ahead and have the open and close parenthesis. But we're passing this in. So what we're doing is we're basically saying create this object, put it in a database table, and save it to the database. Instead of actually creating an actual object and then having to call it save, it's better just to do it in one swoop. So that is what we're doing here. So let's go ahead and we'll stop our server. And when we run it again, you're going to see that it gives two commands. It runs on the port 3000, and then you can see that it went ahead and it actually inserted some data into the database. So now if we go over to our MySQL shell, and we're going to go ahead and select everything from videos, we now have one result back, which is the result that we just added. So node tutorial, this is a great video, blah, 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 and then automatically it does created that and updated that, which is a MySQL thing. So anyway, guys, that's how we get started with Sequelize, how you set up a table, a database schema, how you insert into the table. And you know, we might as well go ahead and take one out too, so we can do that as an example. All right, so if we want to update, let's go ahead and close this thing back down. And I'm going to kill the app too. And what we want to do is we actually want to comment this out, because what we do, we don't have any sort of restrictions on this, so we can actually duplicate. Like if this thing ran again, if we started the server again, this thing would execute again, and you'd have a duplicate entry in your database table, and you probably don't want that. You probably want some sort of check going on, but we're not covering that in this particular video. To query the database, let's go ahead and comment that part out like I just showed you, and then we're going to create a comment here that query the videos table, and then we're going to use the video object that we've already created, and we're going to say find all. And then down here it's going to say where, and then we pass in the actual argument of what we're looking for. So we're going to say node tutorial. And then after this, we need to go ahead and chain another function onto this. So we're saying function, and we're passing in, and we'll just call this found object. I have an extra parenthesis there. So we're chaining on a function to that database call, because otherwise, because of the asynchronous nature of JavaScript, it wouldn't wait for the result of querying the database, and querying the database is always going to be your slowest bottleneck. So that's why we need to chain on this additional function to say, hey, after you get the data, then do this next function and pass in the found data that you have. This could be null, and we probably want to check for null, but we're not going to do that for this thing, example. We just need to get on with it, and we're going to say we found this title plus found object. And because find all returns a list, I need to actually say return the first object dot title, because this could have more than one object, and typically if you have more than one object, you'd probably want to actually run this through a loop. So this is a piss poor example, I apologize, but you would normally run this through some sort of for loop to iterate over every object. But in this case, we know there's only one object that can be found in the database, so we're just going to assume it's there. Alright, now if I go ahead and I'll run the app, and we're telling it to print out to the screen, so you can see it did find it. So we said we found this title and then node tutorial. And that's where we actually found our object. Once again, because this returns a list of objects or an array in JavaScript, you would iterate over each one. And you would obviously want to do a null check, make sure found object's not null. And in case you guys haven't heard, but the Pug template engine that is used for Node.js and also in other places is actually formerly known as Jade. So Jade's project changed over to Pug, and it's basically the cute looking pug dog, but ultimately what it is a template engine that makes writing HTML a lot easier. So to get started, I have a basic Node Express.js app, and if you check out the beginning Node tutorial series on hipstercode.com, you can see from the first video how we got to this point where we have just a basic application running. We have the Pug view engine already set up, and we have a views folder which actually has all of the Pug files that we need. There's an index file here, and you can see from our app that index is being served here. We have a title and a message being passed back to the Pug template, and you can see that they're being used here. So the first things first when getting started with Pug is that if you want to specify a doc type, you just have to simply say doc type. If we go and we look at the code that is running, and I say inspect, you can see that the doc type HTML was added at the top. Now you probably wondered, okay, is doc type necessary with HTML5? It's actually an optional thing with HTML5, so it doesn't hurt to have it there. But you definitely need it for earlier versions, earlier browsers if you're trying to go backwards with support. We've already looked at the title, which exists inside the head. So the title is being set from a variable passed to the template, but I could also just simply give it a bunch of gibberish if I wanted to. So if I gave it a bunch of gibberish, you can see that it's going to throw an error message. The reason why it throws an error message is because this title needs to be in string format. So if we wrapped it in double quotes, it would not throw the error message. So let's put some double quotes on this. So if we surround that with double quotes and we refresh, it works just fine. Now you can see it changes the title up here. If we view inside the head, you can see the title is given right there. So that's how we change the title tag. We already see the h1 tag is just simply saying h1 equals and then the message. Since we're using Node.js, the message is being passed here, so this is why it displays this is a temp message. If we want to do a paragraph tag, this is a paragraph tag. So you can see that this now shows up inside of a paragraph in our body. So it automatically surrounds us with the opening and closing tags required for HTML elements. All right, the next thing we want to look at in the Pug library is how do we do anchor tags. Anchor tags are links in HTML, and we use it like this. So href, and then we give it the actual path to where we want the file to be opened. So we'll say hipstercode.com. And then the next argument after that is you just simply say this is the link text. So you can see this is the link text. If we click on it, it takes us to hipstercode.com. Now, one thing you'll notice is that if we look at the HTML, the way this is structured, the A is not wrapped inside of a P. Well, it's like, well, what if I wanted to put my anchor inside of a paragraph tag? You could easily do that by just simply indenting inside the P. And now when we look at this, there's one P and there's an anchor embedded inside the P tag. So in order to embed items inside of other items, you just simply indent. That's all you have to do. Now here's another example. Let's use the list item. So UL is unordered list, so LI, and we'll just say first element, LI second element, LI third element. Now this does the unordered list with the list item elements. So when we look at this, you can see they're in bullet points, which is standard LI element, and you can even embed this inside of a P tag, which I'm not even sure, to be honest with you, if that's valid HTML or not. Yeah, it's really not. It tries to put it inside the P tag, but it's definitely not valid HTML. Now, if you just want a simple div tag, that's you're going to see a lot of that. So our simple div tag, and then we can put the UI or the UL right inside there. Make sure we indent it. And now you can see we have a div tag with our UL elements inside of it. All right, so now let's look at form elements inside of the Pug template engine. So all we have to do is just say input name equals our name. Second argument is going to be its type, which stands for text. This is actually a default, by the way. So third one would be ID, our ID. And you can see that we have an input. So how do we put a placeholder in there? We could just say, just like we did everywhere else, placeholder equals our placeholder. All right, and that uses the HTML5 placeholder, so you can see it has our ID and everything else. Now, how do we put a label for that? Because obviously input elements constantly have labels. So we'll say label, and the argument here is going to say for, and we give it the name of the label that we're looking for, so it's going to be our ID. So label for our ID, and yeah, that's really it. Now we need to give it the text, so this is the label text, is the next argument for labels. And you can see when we look at this that you can see the label is for our ID. So that's how you do labels and inputs. And inputs have different types, so this is just simply the text type, but we could actually change this from text. We could just say password. And when we type, you can see the dots, which is the standard password. All right, the next example with Pug is we want to look at some of our tables. So let's go ahead and say table. and then we'll have a table row, and table rows contain table data elements. So we could say label for, in fact, we don't have to give it a label. We'll just say label name, and then we'll do also another data element here, and we'll do a input name equals name, ID equals name. So let's just, we'll stick it to that, but when we look at this now, we now have a table format, and we could have multiple rows if we wanted to, just by simply saying, giving another TR with embedded TDs. This is a label, another name, TD, and then input. So you guys get the point. So if we want to do any sort of table element, you can do that. So now there's two tables stacked on each other and they're perfectly formatted. All right, the next tag we want to look at with Pug is the format, or the form tag. So let's go ahead and inside of our label here that we created, let's go ahead and just put our form here. So we'll say form method equals post. So obviously forms can either post or get. And then we can give it an action, and this is actually where the method should be posting to. So we'll just put our, just the / the root domain, since we're not going to really be posting this. But form element should also have a submit. So we need to actually put our input down here, and we're going to say type equals submit. And then we can also give it a value, which is going to be the value that shows up inside the button, and we'll just say our value. All right, so if we look at this input element, we can now see that we have it wrapped inside of a form, and we also have the input type submit, and that's why the button is here. If we submit it, it will try to submit the actual form to the URL that we specified, and this is all just standard HTML. All right, the next thing we want to do is we want to look at how to link to external style sheets. So in my public folder here, I have CSS, main CSS, and since I'm using Node.js, it actually is going to point to the static URL, so I'll give an example. All right, so inside of our head, we want to do our actual link. So we're going to say link relation equals style sheet. Now keep in mind, this can be either single or double quotes. It really just depends on you. href is going to be the actual static. CSS main.css. So if everything goes well, it should actually change our h1 message to make it red, since I have one color in here to change the h1 to red. And if we refresh our page, you can see that Jade is now pointing to our static CSS file, and it's now changing our tag to red. All right, now in the same way that we referenced the CSS file, we can also do the same thing with a JavaScript file. Let me add a new directory here called JS for JavaScript, and then inside JS we're going to add a new just main.js file. So this is just going to be an alert statement. Hello hipster code and pug, and this will just fire immediately. So if I go to the index.pug, and just like I did with link, I'm going to copy this entire thing, and I'm going to change this to script and remove the relation because that doesn't matter. But I do need to change this also to source. I probably didn't need to copy any of that, but anyway. And now we're just going to reference the what do we call it? Main.js, right? So now when this loads, it's going to do an alert message. Hello hipster code and pug. So that's how you reference external JavaScript pages using the Pug template engine. All right, the final thing I want to touch on within our Pug tutorial is a relatively common thing, which extends layouts, and that's a really important thing. So let's go ahead and in our view, we're going to create a new file, and we're going to call this layout.pug. All right, and in the index, we want to go ahead and just copy this entire thing. I'm going to Control X, and I'm going to paste it inside the layout. So we know the layout has all of this stuff. Now, I want to go ahead and just the form part, I want to get rid of the form part, and I want to say block content. Okay, and then in the new index page, we want to say extends layout, and then we also want to say block content. And then inside the block content, I'm going to paste what we had and make sure it's indented. And if we refresh the page, now the reason for this error is because the index project, or the Jade project is being updated to the Pug project. And you can see by default with the Express.js engine, even though we're using Pug, that there's a bug in the tutorial where it says, hey, we're looking for layout Jade, which doesn't exist. So I need to actually specify layout Pug. And this is probably only going to be a temporary thing, but it's because the project's in the middle of a transition. So if I say extends Pug though, we get the output that we want. So hello hipster, the script file, and now look at this. The form element that we embedded shows up, but now we can use template inheritance just by using the extends keyword. So this extends filled in all this layout stuff, and where we said block content, all it focused on for the index page was just this piece. So you can use template inheritance to prevent any sort of duplication of your templates all over the place. So that's a pretty cool feature, guys. The Pug template engine is cutting edge, bleeding edge, and this is how to use it. If you guys have any further questions, feel free to leave a comment. Also, check out hipstercode.com for more tutorials on everything from Django, Python, JavaScript, Node, whatever it is that you're looking for. There's probably a tutorial for it. So thanks, guys, and have a good day. Bye. So number one, Python programmers make bank. They are making an average of $103,492 per year, and that's in the United States. Those figures are actually several years old, and the salaries have actually gone up from there. So I wouldn't be surprised if those salaries are quite a bit higher than that at this point. Yep, and according to this article by ZDNet, it's actually Python that is the fastest growing language now, and you can see in the chart comparison that they show that Python has now surpassed all the other popular languages that we might have thought were actually more popular than Python. A lot of that has to do actually with the data sciences and the machine learning that has just exploded, and Python being the front runner in that arena. And this article here is several years old, but it shows that YouTube was actually written in Python, so that's one of the major successes of the Python language. And it's actually one of the reasons why Python is so popular as well, is because Google used it not just with YouTube, but also with its original search engine was all in Python. And here's some more evidence of the job growth from Indeed.com. So Python's also responsible for a lot of popular websites like my own hipstercode.com website. It's also responsible for lesser known websites like Instagram and Reddit. and that last image of Reddit there is actually the article that got featured a couple months ago. It was like the front page of Reddit, the #1 story about Udemy using some of my content illegally. That was a big to-do, but you can see that was a pretty popular article there. Another reason why Python is great is that it is an open source project, which means that everybody that contributed to Python did so freely. Companies contributed to its financial success by donating money, but ultimately it is a product that is owned by the community, and it works for the community. Companies can use the code base for their own betterment, but you can see the actual Python programming language itself is written in C. And it's all available on GitHub, so you can see the actual source code, and you can even contribute to it, assuming you know enough about C to be able to write some of that code. So another reason for Python's job growth and its success and why it's the #1 fastest growing language is because it's in so many different areas. It's not concentrated in like web or robotics or anything like that. It's actually in web, robotics, it's in gaming. You can see here that TensorFlow is actually a machine learning library that is created by Google. It was an open source project as well, and that is actually using Python. And the Google chart shows the trends of Python. It has showed gradual improvement since about 2004 or so. Hey guys, what's up? So in this video, this new tutorial series, we're going to be looking at the latest version of Python. And there's multiple reasons why you want to learn Python. It's actually the most taught language in universities around the United States. It's been growing a lot since 1990 when it was first created. And Google used it as its primary language for its stack back in the late 90s and early 2000s. They still use a lot of Python. YouTube was originally created in it. So there's still a lot of demand for Python. Right now where it's exploding the most is in data sciences and machine learning. It's considered to be an easier language than a lot of other languages out there. And there's a lot of math libraries for very complex calculations that you can easily tap into if you're trying to learn or do machine learning or anything like that. So Python has a lot of those libraries out there for data scientists. And typically a lot of those jobs do require PhDs or at least masters and or bachelor's degrees, because biologists and physicists and things like that, they would prefer to use Python over something more difficult, probably like C#. But Python is also used all across like servers, so websites are using Python for their stack, like I mentioned, YouTube. Now, as far as like full stack frameworks, Python has frameworks like Django, which Instagram, Pinterest was built on it. And then you have things like Flask, and Flask is now used by a lot of different companies for microservices, for just setting up like a small API. Because these days, a lot of server-side technology is on the less and less, and we're trying to do more and more inside the browser. And that means JavaScript. You're writing a lot of JavaScript that runs inside the browser, but ultimately, where is that data coming from that hits the database and returns data and makes sure that the requests and everything was legit? And that's all server-side code, and Python's a great server-side language for that type of thing. So you'll see that Python really shines in the web development world as well. So Python is considered to be an object-oriented language, although you can procedurally write it. The difference between that is that in object-oriented languages, there are languages like C# and Java that are fully object-oriented, so you cannot write them in a procedural way. Procedural meaning that programs are read top to bottom, left to right, so just like you'd read a book. And obviously you're going to call functions and other files and things like that, but ultimately that's how that execution is working. Now, with object-oriented languages, it's somewhat similar, but there is no everything from the main function of your application. There has to be some sort of class and object stamped from that class to build your application. Where Python, you don't have to deal with that. So for a lot of beginners, that might seem confusing to them, but the bottom line is that Python is a very fast language to write, and because of the fact that you don't have to organize your programs, you can write quick Python scripts that just do all kinds of stuff. For instance, so as an example, I'm a C# developer. I write C# code day in and day out. I could have spun up a C# project, like a console application, with a few clicks of a mouse button, but there's quite a bit of boilerplate code with any sort of .NET project. And what I was trying to do is I had a list of files in here that all these different file names are actually the ID of the YouTube video on my channel. So I have it all in here, and I'm like, I need those IDs for the file name, and I need some sort of JSON object so I can iterate through, a list of objects and get that ID. So while I could have wrote it in JavaScript using Node, or I could have used C# or many other languages to do the same thing, I choose Python, even though I've written Python now for 8 years, but I've never actually had a job where I wrote Python for a company, which is, I think it's interesting, but it tells you a lot about, like Python as a language itself. It definitely has grown on me. I like it. I use it for little things like this. So one tiny little script, and this is procedurally written code, can read through that list of directories there. And then it's chopping off the last name, and it's building a list of objects there that you end up dumping to JSON format, or serializing it to JSON. And then I put it out in this test.json file, which goes into, let me see. So if I go in here and run the program name, which was build, actually I don't remember what it was called, build videos. And you can see just how quickly that script ran and was executed. And we now have this test.json file. So that's how I was able to generate that JSON object that I ended up putting into, like I said, a constants in ES6, so I could export it around and use that data from within my components and everything. So that's just an example of why Python is just quick and dirty. It's a dynamically interpreted duck type language, so that means by default, like, it is just not going to compete on a speed level with like something like C# or Java, which is compiled. However, the amount of time that it takes you to write something like this to solve a problem like that, like I wrote this in like 5 minutes, so I was able to solve that problem of building that object based on that folder structure. And that's just one particular thing that you could use Python for. There's so many different things, but the speed of being able to do that in Python just it outweighs any sort of performance hits that you might have using Python. Now, because Python is something called a garbage collected language, which means that Python deals with looking for unused variables and things like that, so it does something called garbage collecting, so it frees up memory for memory that was set aside for those variables. Because think, in programming, any sort of variable that you have, it's called a variable because the value can vary. And typically, in most languages, you have types for those variables, right? So there's things called strings and numbers, and we're not going to get into all that because this is not a beginner level programming course. Hopefully you guys know about some of those basics, but the variable can obviously change, and if it can change, then it means that it does take up memory and consumption and things like that for the programming process that is running. So Python automatically cleans that up for you, but any sort of garbage collected language is not going to be as fast as other languages that give you full control over memory management, like C++ or just raw C. But anyway, guys, that's really all I got in this first video. You can use Python for all kinds of different things. We're going to see throughout this tutorial series that we're going to use it for practical purposes. That's the point of this series. Thank you, guys. Bye. So first things first, to get started with Python, we need to go ahead and download it. So we're going to go to the main Python page at python.org. If you just type that into Google, you'll get to this page. The latest version as of the time of this video is 3.6.5. So we've had a Python 3.6 series or at least Python 3 series for the last 10 years or so. But Python goes back a long ways. So like the original Google Foundation was written on Python 1 series, and then like when Python 2 came out, a lot of web applications and things like that were written with Python 2. So there's actually still quite a bit of applications out there that only work on Python 2.7, which is a very popular series. So you could see like Python 2.7 down here at the bottom. So if you're going to use a Python 2 series for whatever reason, you probably should use 2.7. But here I'm just going to go ahead and modify and make sure. One of the things I want to make sure you guys do is to make sure that you have this thing added to your path so that it actually runs. And this is where you want to make sure you say add Python to your environment variables. That needs to be checked, because if it's not, you're going to have a bad time. And then just click install. So you can see I already had it installed, like nothing changed there. If everything goes correctly though, you're going to be able to open up a command prompt and you're going to be able to type in Python, and it's going to run the Python emulator. And I'm going to make this bigger. So inside of here, we can actually write our Python code. Hey guys, what's up? So if that is working correctly, then you can proceed to the next video. If not, you need to look at how to add Python to your path, and you need to restart your computer, because sometimes, depending on your operating system, it may need a restart in order to take effect. So try that if it's not working first before you try to troubleshoot beyond that. The next thing we need to do to get started with Python is download a text editor so that we can actually write our code into it and get helpful hinting and things like that to make our lives easier. Visual Studio Code is actually created by Microsoft. It's free to use, and it's cross-platform as well. So even if you're following along on a Linux or Mac environment, this still works. So we're going to use this Visual Studio editor. It's really popular these days. So go ahead and just download it, and we're going to run the executable. So now let's go ahead and run through the install. We're going to say yes, and we accept the terms, and we're just going to install it to the default location. And you can create the Visual Studio Code on the Select Start menu. That's always helpful. I'll even create a desktop icon. And yeah, let me see. So yeah, we want to make sure it's added to the path as well. That's important. And then go ahead and install it. All right, so now that we've done that, let's go ahead and launch Visual Studio Code. And this is just going to give you a folder. I already have some projects and everything open, but we're going to go ahead and create a new folder. And we're going to put this under our projects. I have a tutorials folder that I put all my tutorials under, and I already have a Python, so we're going to say Python v2. Wait, oh yeah, I need to create that folder, obviously. Python v2. All right, so now I'm going to select that folder, and this is going to open up into the folder that we just created. So let's create our first Python program. We're going to say new file, and we're going to call it hello.py. Now, in Python, you could type your code into a actual text editor, and it would work the same. Like if you said, you know what, this file is going to be called, I'm going to say, we'll do the same, print hello world. All right, and if I save this file, just using Notepad, and I go to, I'm going to go to my projects again, tutorials, Python v2. I'm just going to save it here, but if I said, you know what, change it to all files, and I say test.py, I can actually create a Python file. You can see I have the syntax highlighting and everything. Now, you might not have this coloring, and it may not even recognize it, so what we need to do is make sure you have the right extension installed. Click on this icon to your left that says extension, and in here we're going to say Python. Now, you're going to want to grab the biggest one that has 12 million downloads and 4.5 stars, and you're going to go ahead and install this thing. You can see I already have an install, but when you install it, it's just going to restart. So make sure you install this plugin. Another thing you might want to do, well, yeah, this is really all we're going to need for this tutorial series. You're going to see some squiggly lines and things like that. Those are not errors. That's called linting, and linting is actually an optional thing. We can disable it if we don't want. And that's probably what we're going to do in this tutorial series, because a lot of linting has to do with more advanced concepts and coding habits and things like that you would learn along the way. But this is a beginner course, and we don't really want to get misguided or misdirected, you know, down like a side path that is just not necessary right now. So you can see in both cases I was able to create a Python file, one using Visual Studio, and we'll even say this is using Visual Studio. All right, and then then we have this test. So with two different files. Now, if we want to run our program, what I want to do is make sure I have the file that I want running selected. I'm going to click this little debugger icon, and then when I click play for the first time, you're going to have these configurations, and by default it's going to add a new configuration, but we can just select add configuration and click play. This is going to ask you what type of environment you want, and it should detect that you have the Python environment installed. It's going to look for Python on your path. So if Python can be found by Windows on your path, then this should work just fine. You're gonna select Python, and then here you can see that in a moment it's compiling, it's running, and things like that. And then you can see it does a lot of like basically just like warnings and like logging and just information that you might be interested in. You can actually disable that as well, but this is just running right here. And the debug console is probably the best thing to look at if you're just trying to get the output. But if you wanted to get feedback from what's going on behind the scenes, the terminal is the place to go. But look at the debug if you're just looking for any sort of console output and things like that. So you can see this is Visual Studio. If I go back to my file, I select the other one. I can run it just the same by clicking play. And obviously I'm going to select Python again, and then you can see that it says hello world. So it's pretty annoying to have to select your debug option every time you want to run the program, and that's really not what you want. So we want to make sure that we click this option and make sure the add configuration option, and then if you select Python, it's going to create this new directory with this VS Code with a launch.json file. And this is like where you can set it up to actually run Django projects, and it gives you starter code to how to get started with Django. So basically, when you're running from Visual Studio, you can pass in arguments and things like that to your Django application so that it does so it behaves in a certain way. So there's all kinds of different configuration options here. We're going to press Control S to save that config. Go back to our hello.py, and now if we have our debug option, we can go ahead and select one of these. You can just say Python current file. That's probably the easiest thing to do, but you have all these other options too if you're trying to run like a Flask or Django project. So let's go ahead and just press play. And now you can see it constantly is just like, we can just run play over and over again. You don't have to select it over and over and all that stuff. So that's pretty cool. So now with this cool Visual Studio Editor extension that we installed, it's Python is actually telling you about all these different little tiny things. It's like new line missing and stuff like that. So those are like tiny little things. But if you wanted to satisfy them, it's just telling you, hey, you need a new line right here, and then it's saying that you need a final new line, so like something like that, at least one. If I press Control S, some of these error messages start going away, at least that one. Even if I were to say, just if I click on this little green icon, it also gives you the information as to what the error message is. So there's multiple places you can go. So if we want to change the behavior of this so that we're not getting all these different like nitpicky messages back, I want to go to File, Preferences, Settings, and this is where I have a few settings. This is where the Python linter is enabled and things like that. So you can see I have a special Django plugin because like there's different linting rules that you want to follow for Django versus other things, and that's why that's in there. But you can just add different settings. I even have TypeScript settings and stuff like that. Make sure there's always commas after every new setting that you're adding. And one of the things I want to do, there's actually, so I already have a pylint args for this this Django one. So it's just a list of string values, and we're going to touch on those in just a moment. But I'm going to go ahead and add this other value and remove this duplicate title. So now we have, I'm only concerned with problems that would result in the error of the file not compiling or running. So that is a much better user setting, I think, for just people that are just getting started. So again, like the nitpicky stuff, you don't see the warning messages. But if you end up doing something like some sort of keyword that doesn't exist and press save, then you're going to see that the problem still exists. It's like undefined variable. We have no idea what that is. Like you're trying to call this as like a function, it has no idea what it is. But yeah, so that's what you want, and that's what we're going to do. All right, guys, thanks for watching. We'll be back in the next video. Alright guys, so this video series is by Practical Example, and I had a video series that I did on Python back in 2016 that was quite popular, but I started the series off with like giving some practical examples, and I think that was really the popular part of that series. But then I kind of went astray with just kind of focusing on syntax and showing all the different built-in types in Python, and I was showing like things that like weren't really, you know, practically used all that often, and like it just like kind of just doesn't really captivate the audience anymore. So that like I'm trying to like at least lead by some sort of programming example problem or whatever that we're trying to solve when we discuss the different types and things that you're going to do inside the Python language. So the first thing we want to do is focus on the string. This is actually a string value right here. So if we were to put this inside a variable, and we'll call this my variable. In Python, you're going to see commonly that local variables typically have, they're all underscore with this, they're separated by the underscore, they're all lowercase. A lot of Python code is written in that way. The linting is going to give you hints as well as far as how to write properly. So if you want to go ahead and disable and put it back to its original setting, you can do that. But by convention, we're going to just name our variables in this way, all lowercase, all words separated with an underscore. And we could say this is a string. So a string in Python, it's going to look at this variable, it's going to assign a memory slot for it, and then it's going to assign memory to hold data that it contains. It's also going to listen for any changes that are made to that variable so that it can end up stamping out a new object with that new value. And if we wanted to actually use the variable instead of this hard-coded string right in there, we could do that, and we could say my variable, and we're going to print that to the screen. So if we go ahead and run this, we're going to see in the debug console this is a string. So it works the exact same way, but Python has a built-in, I can go ahead and see the type of, or just type, actually type of is JavaScript. So I could say type, and then inside a parenthesis after the type, because this is actually a built-in function within Python, you can see that it's class type, takes in an object or name, and that's what we're passing in right here. So it's gonna, that's the first argument. It's the only one that we're worried about. Those other two arguments are optional, but you could read more about, you know, passing in those arguments and seeing what your results are and things like that if you wanted to. But for right now, I just want, you know, what it is, what type of variable is my variable. Is it a string or is it something else in Python? So if I run this in the debug console, you can see that it is a class string. So that tells you there's this built-in class within Python that is a string, and you're like, what is it? And if you were really nerdy and wanted to read up on this, you could actually go pick your version of Python 3.6, and you can see that there is all this documentation on the official python.org website. This is all the nitty-gritty details. So if you really want to be like a you know, thick glasses nerd Python developer, like reading through all the semantics of all this stuff, like you're going to learn a ton about the language and what you can do. You're not going to use half of it probably, but it's all there for you. So if you ever wanted to like deal with, okay, there's some sort of built-in class within Python called string, and that's the case. So you would never want to create your own class called, you know, str, because Python has these built-in classes already. So those are like the most important concepts around some of these features, and like even the lesser known features that you might not deal with, like range operators and things like that, which you do kind of deal with those a lot. But just as an example, say you didn't, then you would still want to be aware of those edge cases, so you're not like overwriting some of the, you know, core language of the Python runtime or whatever. So anyway, linting also will help you with that as well, maybe even the compiler. So let's go ahead and look at a few other types real quick, because I want to show you how to practically use the string type. But let's go ahead and create just some other type. We're going to say other type. What is this? I'm going to assign a number to it. So in Python, that's all you have to do. You don't have any semicolons or anything like that, like if you've ever seen JavaScript or other languages. None of that stuff matters within Python. And now let's go ahead and, like, we're going to look at the type of other type. One of the things that Visual Studio Code gives you, which is really cool, is it gives you this code hinting. So like anytime it pops up like that, you can use just the tab key, and it's going to pre-fill what it is that it thinks you want to type. And that's like 9 times out of 10, that's usually what you want to type. So having a text editor like this is really cool. Now in the debug console, you can see that's a class of int. So we have this integer type. Let's see, another type equals, like, what if I said 1.4? What is this? You can double click and to select the whole thing, tab again, press play, and you can see that we have this now floating type. All right, so there's all these different types within Python. We're not going to discuss all of them, but the fact that the thing I really want to explain is that, like, we have, we'll just say 1 int equals 1, 2 int equals 2. And I'm going to get rid of these real quick. And what if I wanted to say 1 int plus 2 int, and then just print that out, press play. You can see that we're still getting a type of int. So we can actually add 2 variables together and we can still get their type of. Let's go ahead and get their value by removing that type statement and the parentheses, and make sure you do that. Another thing too is that if you highlight over the start debugging option, I thought it was going to give you a hint, but you could press F5 if you wanted to, and it's going to start the debugger automatically. So you get the value of 3. Now what happens if you try to do something that's not mathematically possible, and that's try to take, let's just say this is not possible. So we're trying to take a string and we're going to add it to an int. So we have 2 different types within Python, and we go ahead and press play. You can see that we get this error, and it says unsupported operator. You cannot add an int and a string. That's not mathematically possible. It doesn't make sense. This isn't a mathematical value. It doesn't represent anything, and you're trying to combine the two as if they do. So Python's going to freak out on you whenever you try to deal with two different types like that. The interesting thing about JavaScript is we could do the same thing. 1 int equals 1, and then 2 int equals this is not possible. And then we could say just go ahead and add 1 int plus 2 int. And you could see it adds two different types. It doesn't complain. That's because JavaScript is a weakly typed language. Python is a strongly typed language. A lot of people think Python is like some sort of weakly typed language like Perl or PHP or JavaScript, but it's not. It is strongly typed. It enforces those types. It makes sure that if you want to do that, you have to explicitly try to do that. So like in this case, I'm going to say, you know what, 2int, I'm going to force you to be an int. So I could say int, and this is called typecasting. What we're doing is we're taking the type of string and we're casting it to a different type of int. And we're going to try to force Python to behave in that way. But now you're going to see that we're going to get this invalid literal for int with base 10. Basically, Python in its built-in int type is expecting actual numbers that the computer understands. It's getting string values that it doesn't understand as numbers. So this is simply not going to work ever. Python is going to prevent that type of bullshit from ever occurring. Whereas, you know, these weakly type languages like Python, or not Python, but PHP, JavaScript, and Perl and things like that, they will just let you do it. They won't complain about it. That is one of the main reasons why companies do not use a language like that. Most of the time, you're never going to want to do some crazy stuff like that. But in this case, you're forcing Python to try to do it, and it still doesn't understand it. So like those other languages shouldn't understand it either, but it just tries to figure it out, and it auto-magically figures it out for you. And if you've ever heard of the term magic with a framework and things like that, that's what they're talking about, like, you know, magic that goes on behind the scenes. Ultimately, there's some sort of decision by a developer who was developing JavaScript or Perl or whatever to say, you know what, we have these type collisions, don't even care, force one or another into it. You know what I mean? Like, so they know that, like, in JavaScript, you can't obviously force a string into an actual number, so it's going to go the opposite way, and it's going to force a number into a string. So, but it's just weird behavior. So anyway, let's go ahead and talk about a practical thing that we can do with a Python string. We're going to actually write a simple HTML page, and we're going to say the thing's going to have everything that an HTML page needs. There's going to be a title in here. Test page, and we're going to close off the title. So just try to follow along with what I'm typing here. It's all just regular HTML, so hopefully it's familiar to you. And then we'll just say hello world. Let's close off our body tag and close off our HTML tag, and now we can go ahead and close that off. And we're going to go ahead and instead of printing to the screen, I mean, we're not going to do that. We're actually going to create an out file. So we're going to say my out file equals, and we're going to say open, look for a file that is called test and the current directory. And if it doesn't exist, go ahead and open it. We're going to make sure that the test is dot, and we're going to call this index actually. We're going to call it index.html. So it's an index.html file extension. This dot says go back to our root directory or the current directory that this file is sitting in, / and it's going to create this index file. This W says write to it and open it, like create it if it does not exist. Now sometimes you're still going to get these error messages where like the linter is stuck, so you're going to want to just press Control S so that the linter will go away from its error messaging. So what you can see is if we go ahead and we try to run this program, and we go to our directory, you can see that I created the index.html file, but there's nothing in there. But that's pretty cool that Python actually created an actual HTML file. If I go to where my directory is located, I can go ahead and double click on that file, and you can see that it's actually opening up this page into a web browser, so that's pretty cool. So now I want to show you that we can go ahead and alter this program to say, you know what, after you go ahead and create the file, I want you to go ahead and write to it. And if I go ahead and say dot after my variable name, you can see that we have all these different options that we can read a file. But what I'm going to do is say write. I want to actually write, and I'm going to write my variable value into it. So we're going to write our string value, which is actually an HTML page with this content. So we should get a page title in there. And also a hello world tag and everything like that. So if we go ahead and we run this, then we can do that, go back to our files, double click the page. You can now see that our index actually has the values, so that's pretty cool. We can also reveal in the Explorer and then double click on it, and you can see that we have an actual HTML web page, which is pretty cool. Python generated it for you just like that. So you could have had whatever sort of value inside of here as your HTML. Maybe it's a file that you open up and you like inject all that, but this is all you really need. So you could have this index file sitting on an Apache server somewhere, and you could deliver it to the entire internet, you know, and it's just as simple as that. So even without databases and things like that, like you could literally set up something so basic where it's like, I have an Apache web server and I run a Python script that writes a bunch of HTML files based on like data that I scrape across the web or whatever. And then I write these HTML files, not even to a database, but to a straight file system on the Apache web server. And it could just literally like serve static HTML, displaying the data that you've assembled and things like that. And nowadays with like client side, these serverless servers that they're talking about, that's all they really are. And they make a lot of sense because you could pass down a lot of code, including JavaScript and all kinds of stuff, down to the client that is just like rendering most of the UI, if not the entire UI. And all that thing's doing is just making like maybe AJAX calls out to some sort of RESTful endpoint. That could be like a Python Flask server or something like that. And it's just passing data back and forth. Like literally you could start an entire operation with just Python code. So the thing about being a good coder is that like we have to be able to tap into the code that is actually written by people that actually know more than we do. So you never want to reinvent the wheel in programming, and a lot of the code that we need to tap into to do a lot of the things that we need to do has already been written for us. So being a good developer in a lot of ways is actually how to assemble tools, how to learn quickly, and how to actually know which tools to use, which just comes with experience. And unfortunately you can't really fast track that, but you could do a lot of blogging, as far as reading blogs or vlogs, following my channel, things like that, like to try to keep up to date with everything. But it's going to be impossible. You'll find that it's impossible to keep up with everything. And just experience over time, you accumulate way more than you thought possible. But it's just a timing thing. So let's go ahead and look at how we can actually use somebody else's code, like an actual library. We're going to create a new file. And we're just going to call it, we'll just call it module imports.py. So if we want to install something that we can use from other people's code sources, we can go to the command line. And it doesn't matter where you are in the command line, but I can say pip install request-html. Now this is a project that was written by the Python request people, but it actually has JavaScript support and all kinds of different stuff. So if you ever tried to reach across the web to grab, HTML or like scrape a web page for some data or something like that, this is a great tool to use, and we're going to see how to use it in just a second. So we need to go ahead and import it, and to do that from Python, you need to say from, and then what it is that you're actually requesting, and then you're going to say import the actual thing that you want to use. So like the request HTML is the module library, and then from that module library we're trying to get one piece of it, which is called HTML session, and then we're going to use that session object, really the session class that we're importing, to new up an object that we're going to call session. And just to let you know that we can see what type of object it is, we're going to go ahead and say print session, and before let's actually go ahead and see what the output is if we try to print the session to the screen. And we'll see whether or not we can even do that actually. So you can see that you get there's some sort of session object, and this is the actual object stamped out in memory. This is like where in the memory location you could find this object that is called HTML session. If I wanted to say the type, I could do the same thing, just print the type of it. And you can see that it is a class. It tells you it's some sort of class called request HTML.html session. So again, you're importing just a class on this HTML module. You're newing up an object from that class. And this is all object-oriented programming in Python. And then we want to go ahead and new up another object, which is really going to be a string variable that we're going to call session.get. Actually, this may not be a string. But now I want to do the session.get. I can go ahead and just give an HTML page. I'm going to give a page to a website that I own, so that way I don't get any I don't get in any trouble for like sending a bunch of traffic to somebody else's website. So now if I wanted to go ahead and like tell me what, like I'm going to go ahead and just print the value of R. So you can get this response 200. So in HTML or HTTP, actually, which is Hypertext Transfer Protocol, the responses that you get back, like 200 is a good response, 404 is page not found. A lot of people are familiar with that, but this is what you're going to get back by default. So you could actually say if R, if you're checking for a response of 200, but let's go ahead and just print something else out. And if you wanted to, you could say dot, and you get this text highlighting, this text helping. So if I wanted to get the actual text of the page and print that out to the screen, I'm actually going to get much more data coming back. And you can see I actually get the HTML. It's all formatted properly for me and everything. But it's the HTML homepage of my website. You can see all that stuff in there. It's a really ugly website at the moment, but it's just, it's always under active development. I don't really do anything with it anymore. But that's the story behind that. But if I wanted to say, you know what, I'm not interested in all that text. I just want all the links on the page, because I'm going to go ahead and I want to see how many links there are. And I'm going to like maybe scrape all the links and start following those links, you know, because like we could do all kinds of crazy stuff. So here's our output. So you can see it doesn't find any links on the page, but that's because we didn't reference it right. The thing we need to do is we need to say, you know what, instead of all that text, which is HTML, I want to say, you know what, get me the HTML and then get me the links. This is going to use a built-in library. I believe this is using Beautiful Soup. I'm not 100% sure, but I think it's using Beautiful Soup. But now when I run this, because I said HTML, it's going to parse through all the HTML looking for any sort of links that it can find. Now, most likely because it's using Beautiful Soup, that's why it's really slow. But now if we look at the debug console, you can see the only thing that we're getting is we're getting anything on the page that are links. So you can see that we have these full spelled out links, and then we have these relative links. But those are all the links on the home page. So I could actually like assign those out to something like a list type. And a list type we haven't seen too much of, but we'll say my list of links equals. In Python, you use these square brackets. So if I wanted to actually say, you know what, I'm going to assign all those links to my list of links, I'm going to say, instead of assigning it to an empty list, I'm actually going to assign it to this value. And then we can go ahead and we can print this, my list of links. So the value type that gets returned here is actually a little bit unique. One of the reasons why, if we look at, if we hover over it, you can see that it returns a type of set. So set is very similar to a list in Python. And we're going to talk about all three of these different types all in one video here. My list is, you use square brackets, right? If you want to add an element to my list, I can simply say my list.append. Inside of these parentheses, I can just say string value. That's fine. I'm going to append a string value, just a string that has this name. In fact, let's just make it a little bit more interesting. I'll just say it has my name. And now if I want to go ahead and print my list, I can go ahead and do that. So another really common, really important thing I want to show you guys is that I can set breakpoints on my program using Visual Studio Code so that I can inspect certain things like my list. So if I say print type of my list, I mean, I could put breakpoints wherever I want and I can stop the execution. So if I press play now, I'll actually hit my code here, and like you can see it gives you all kinds of information on these variables, and we talked about all these different variables that we have, and you can look at like my list of links is this variable, and you can see, okay, what is it? If I highlight over it, it looks very similar to a list. Again, it's unfortunately this doesn't actually tell you. You can change its value, but it doesn't unfortunately tell you what it is, I don't think. Yeah, anyway. The point is you can find all kinds of information. Here's our R object, so you can see all the information that we have available to that. So we could say, if we wanted to go from one page to the next, you can see that there's this cookie jar in there. There's all kinds of stuff in there that we can interact with. And here's our HTML, so you can see all that HTML code that we printed out to the screen. There's our HTML. Here's our links. Here's LXML. So if we wanted to parse through using actual XML syntax, we can scrape the web using that. There's certain JavaScript and things that we can inject onto this object. So there's a ton of code written around all this that we didn't have to write. And the point is that using the right tools for the job is like half the battle. So I want to keep going down. If I want to go to the next line of code, you can see I have these different options where I can step over, step into, step out of. So I'm just going to go ahead and F10 to go to the next line. And now you can see that if we look over here, we have this my list, and it's an empty list of values. And lists in Python actually keep their order. So that's one of the main reasons why you'd want to use a list. Lists are also very flexible. So lists in Python are types that can they can hold an infinite number of like strings or numbers. They can hold other lists. So you can have lists that hold lists that hold lists inside of them. So you can have very complicated like tree data structures using lists, and you can actually take values in and out of them. So they're more memory intensive because you can do that. Now sets actually cannot have duplicates, so they're very similar to a list. That's why this my list of links looks very similar to some sort of array or list. But if there were duplicates in here, it would not allow them to go in. So that's the big difference. So if you don't care about duplicates. Another thing is too, this is just automatically ordered, so it's just ordered based on whatever sort of internal settings are within Python. So you can't order this in any sort of way. So if order matters, you cannot use a set. Another thing that I want to talk about with lists is that you can also have something called my tuple in Python, and you see these sometimes too, and this is also very similar to a list, but these values can never be changed. So the big difference is that once you declare a tuple, it's basically read-only, it's a constant, the values cannot be retrieved, they cannot be pulled out of or like anything like that. And once they're set, they're set. So like 1, 2, 3, and I'm gonna go and just break this here. And now I can even dynamically add the code, which is even crazier. But the program will freak out at that point, so you have to rerun it. So let's go ahead and do that. So now if we look over here, we can see that my tuple is very similar, as these two values, or I'm sorry, 3 values, and also looks very similar to something like a list, which looks like that. And then you also have a set. Now again, sets can't have duplicates, lists can. Tuples are much more memory efficient, just because if the values are never going to change, then the tuple is immutable. Immutable means that it cannot be mutated after you've created it. And if you want to type Visual Studio, you can see things like my tuple dot. You can see that there is no there's nothing in here that indicates that you can like do anything to change the structure of it, like add a new value or anything like that. You can get the count if you wanted to, and so you're probably asking which one should you use, and for the most part, until you really know what you're doing, you probably just want to go ahead and use lists for any sort of data structure where you're trying to have a bunch of values. So I could actually like assign this this list to so my list is a list type. So I could actually say my list now equals my list of links, which is a type of set, but I can actually force it to be a list by saying, you know what, make yourself a list. And then I can get the values from the set, and then I have my list is now a list of links, plus now Chris is going to be inside of it because we've appended a value to my list. So let's look at my list, and you can see once again, this is now a list type, and we can actually say if we hover over it, let's see. Yeah, unfortunately, it's just giving me the values. I keep thinking it's going to give me the types, but it's not. That kind of sucks. Anyway, all right, so my list is a list, but you can see Chris is now at the bottom of this. So we grabbed all the links, and we have Chris. So why is a list important? Well, it's very important because I'm going to stop this program. I'm going to show you what we can do is we can say, you know what, I'm going to have a huge string, and we're going to call it huge string equals, we'll just say it's an empty string for right now. Sorry, my cold's killing me, sorry. So now I have this huge string, and what I want to do is I want to iterate over the list of values that we have in my list. So I'm going to say for item in my list, and then make sure I have a colon, and then this is going to automatically indent to the proper indentation that Python expects. And for every item in our list, and remember there's like 15 values or so, we're going to say, you know what, I want you to try to turn the R object to that value. And we could say huge string equals huge string, which is the current value of it, plus R dot, we'll say text. So now every time we go through our list, we're actually making the shared huge string variable. We're going to make it bigger for every page that we try to get. Now, the thing is some of those pages that we're going to try to get, we need to go ahead and say, you know what? I want you to go ahead and get the item and not this hard-coded value. And then it's going to append it to this huge string. So let's go ahead and run it. And in a for statement, I want to put a breakpoint here because I want to show you that for every item in the list, so here's our first value, it's going to go through every item in the list, and it's going to run this request session.get. So now we have this. Now huge string is right now empty, but if I go ahead and I play it, I'm just going to tell it to continue. You're going to see that we get to the next URL and it blows up, but before, if we could have done that, we could have actually seen the huge string. So it's actually a value that is not working. So I want to show you the error message that is actually going on down here. It actually tells you that the built-in library is actually saying it doesn't have like an HTTP or HTTPS or something like that, and that's what it calls the no schema supplied. So it tells you, like you gave this relative path, but we have no idea what the relative path is. So now our program gets a little bit more complicated. So in the next video, I'm going to show you about logical operators that we need to start looking into. Hey guys, welcome back. So in this video, what we want to look at is how do we get past this error message, because we can't go through our list of links there because some of them are relative. And what I mean by that is if we looked at those values, some are just /, which means relative to the hipster code domain. And other ones were fully spelled out URLs that Python requests could make sense of just fine, that had its proper schema, which means it included an HTTP in there. So that's what it's really looking for. So what we want to do is we want to look at a few things here. Number one, we're going to look at commenting out code. So I don't want this code to run, so I just want to highlight the code portion. And if I press Control /, it's going to automatically inject and turn these things green. Python comments actually start with this #. So anything after that's going to be ignored by the compiler. So you could put whatever sort of comments to give yourself whatever sort of notes on your code that you want. For right now, I'm just commenting out because I don't want it to run. And now we're going to look at the logical operator that says, you know what? We want to look at the if operator. So what we could easily do in our list, we could just say, you know what, if we're going to say if HTTP in item, which is the value in the list, and we saw once again that we go through every list item in there, and we're looking for the value of HTTP and whether or not it exists. And if it does, we're going to say, print the item to the screen. So now every time this runs, I want to put a breakpoint on this print screen so we can see every time that there's a match that it works. Now this part, don't worry about the linting rules. You can see that it's just bullcrap linting stuff. But anyway, we're going to press Control Save, and this thing should still run just fine. And again, a lot of those linting errors go away when you actually press Save. So now let's go ahead and now we stopped it on the if. So we're like, does login, and let's see where we are in my list. So we're at login. So we're at the first value, right, which is login. So we know login has no HTTP in there. So this print statement's not going to get hit, right? So now we're on the next item, and this is one that does contain the HTTP. So let's see if we actually print it out to the console and hit that next line, and we do. See, because we matched, it said, oh, it contains HTTP. It went ahead and it's going to print it out to the console if we let it proceed, and there it is. And let's go ahead and remove these breakpoints and check our logic and make sure it goes through it and only does that. Ready? And there you go. Those are all the links that are fully spelled out. So those are only the links that we want to get using this code that we had before. So I can press Control or just right click, cut, and instead of doing this, I can go ahead and paste this in here and then select it all. Once again, Control / and it actually uncomments it out. And now we can say we're only going to append this huge text of values or whatever for these proper URLs. And you know what, I want to go ahead and print at the outside of all of our for statements. I'm going to go ahead and print the value of our huge string. So I actually want to see that after the list is run and all that stuff, because this is all procedural. It's all read top to bottom, left to right. Eventually this is going to be hit when it's all done, and I want to see what that value is, because we're not doing anything with it. So as soon as we hit this code right here, the the values are gone because we've killed the program. So because I have a lot of visual, like video processing going on, and also because Visual Studio Code is actually relatively slow when you have a lot of stuff going on, that's one of the downsides. So you will see, like, especially on like when we're appending a huge string like this, it's going to slow down a little bit. But there it is. Like, we just requested all that HTML stuff, and we just made it, we printed it out to this huge thing. But what if I wanted to go ahead and say, you know what, I want to go ahead and use my code from where we were using this out file here, and we're just going to copy this out file code right here, and I'll put it in the module imports. Instead of printing the huge screen, huge string, I'm going to write the huge string to, we're just going to say test.txt. So we want it to be a test.txt file instead, because it's not going to be valid HTML since we're just jumping or bundling one HTML thing on top of another. Let's go ahead and launch this. So our program launches, and because there's less going on, hopefully, there's definitely the video processing still going on, but since we're not generating such a large string and trying to keep it in memory inside the Visual Studio Editor, it might be a little bit faster. So when we go ahead and try to execute our code, what we're going to get is this character encoding error. And what it is it's run into this new thing that does not, it's like a Unicode error that Python cannot write, that basically so we need to encode it to UTF-8 to at least force it to work. And this part is where we have to do a little bit of crazy string casting. We have to say, you know what, I'm going to cast to a string the value that gets returned from huge string dot encode, and then I say, you know what, I want to encode it to proper UTF-8, and then I need another parenthesis. So there's a lot going on here, but basically what we're saying is that this is going to return bytes of data, and we need to convert it to a string, so that, because write only works with an actual value of a string that gets passed in, so it won't work with anything else. So you can't just simply say huge string.encode and think that that's going to work. This is where we have to get crazy into our little typecasting. But by doing that, if we go ahead and we run the program, we're forcing Python to go ahead and encode anything it doesn't understand the UTF-8, and it's going to ignore the errors. And then When it does that, you can see that there's no complaints. If we go over to our file, we now have this test.txt, and we are able to effectively take the values of 5 or 6 different web pages, and we combined it all into one text file, and it took about a second. So it reached across the web. The value is all dynamic. Every time you run the program, you're going to get different values, obviously, depending on whatever's going on the websites that you're requesting data from. So there's all kinds of stuff, like I said, you could do to just even build. Just even in this tutorial series right here, it showed you that you can actually reach across the web. You can grab data. You can write to files. You can even take those files and make your own HTML files with it. And then from there, you can throw those files on a web server somewhere, and you can have a website. And all by doing so without any database. Not saying that's your best architecture. Not saying you're going to start Facebook that way. But simply put, like a lot of small one-man operations and things like that could have pretty dynamic and interesting looking websites, especially portfolio websites and such, that are just running on some sort of just Apache server serving up raw HTML that was generated by Python or some other tool. And that's actually taken a storm lately, where like the serverless stacks that you see written in like Go and other languages, and ultimately they're just Python. They're just code that are generating HTML pages and such, and like instead of and so you could just do that yourself, really, is what I'm saying. But or you can do whatever you want. So what if we were like, this huge string isn't very usable. You can't obviously combine all those HTML files together. What if I said, I want to create separate HTML files for every one of them? Well, you could easily do that, and you would actually do that inside of your if statement, where you'd actually say, instead of huge string r.text, what I can do is I can say, I'm going to paste this in here. I'm going to say, open this file. But what I want to do is have this file name be dynamic, because the problem is that every time you get this match, it's going to overwrite this file. So you need to have a dynamic file name every time that occurs. So there's a built-in way that we can do this in Python, where we can get the index passed in. So we can say, item and index, and we're going to say and we're going to use a built-in enumerate function. And enumerate, we just have to enumerate the list. But by doing so, we can keep track of this index value. And now I can say, test, and I'm going to say plus index plus, now I'm closing it off. So this is how we're doing something called string concatenation, or concatenation, where we're taking 2 strings. We're actually getting 3. We're taking 1 string, 2 strings, 3 strings, and we're combining it into 1 string. So that's what we're doing there. Now we're also going to outfile write, and now we're going to have the ability to have this, test 1, test 2, test 3, or whatever index number this value shows up in. So let's go ahead and do that. And now instead of huge string, we actually need to say that we're going to be looking at the r.text, and we want to encode that as well. So now by doing that, let's go ahead and run this. Now this is where you get the the string problem. See, the thing is that index is a type of number. So like, let me go ahead and pause this real quick, and I can show you guys. So we haven't looked at the number type too much, but index is an actual number. So if I hover over it when we actually hit our breakpoint, all right. So now if I look at the oh, that's interesting. So we have this actually backwards. So the thing is the index and then the value. Sorry, I totally jacked that up. So anyway, I'm not perfect. This is your index, and then this is going to be your new item. So that makes sense. Now, however, there's still a problem. Index is a number. So in number, you're trying to add a number to a string, and Python might not like that. So you're going to want to cast that directly to a string. And by doing so, we can now say, I'll even put an underscore to make it prettier. So we can say test_1, test_2, blah, blah, blah. Or whatever the index number is for the match that we have. All right, so let's go ahead and run this again. All right, so now we get no error messages. And once again, you have where those values showed up. So now we have test1, test2, all this stuff. So now it's like, well, maybe I don't want that. Maybe I want the actual straight HTML page. Can I get that? well, we can do that. So let's go ahead and go back over here, and we're going to say, instead of writing a text file, I want you to write an HTML file. Instead of encoding and all this other stuff, let's go ahead and just simply write the r.html. And let's see if we can get encoding errors from what is being returned from that HTML function that's attached to the built-in HTML request object that we were working on. So now it's like HTML.2. So I guess I can't get it. So I have to just get the raw text. Let's see if the raw text. Yeah. So that kind of sucks. Okay. So we're gonna have the character encoding problem on all this crap. All right. Whatever. So we're going to encode this thing, and we're going to save it as a .html. So we're going to see what kind of malformed HTML we end up getting here. So if you look at the output of the files, if we double click on those, you can see that we are getting these different test files and stuff. Like if we go to test 0, that is that Twitter link that we found. Now we obviously have, like, we're missing style sheets and stuff because you can't request on a local file all the files and everything that Twitter needs in order for this thing to work. But there you have it. So that's how you could dynamically go through some lists, sets, or tuples to just go through values and request one thing after another. We looked at logical operators that basically said if something is, if some string exists inside of a string, do this. If not, just, don't do anything. So we've looked at those logical operators, and that's actually really what programming is all about. We also saw in this that we had some character encoding issues, and because we're using this library, not HTML parser. I actually tried to use that real quick, but because we're using this HTML session object, which is a part of its own library, there are certain things that this code is doing that if you wanted to F12, you could actually go into it. You could press F12 and it'll take you right into the code, and you can see that there's quite a bit of code here, but it's doing quite a bit of stuff, and you'd have to spend a lot of time reading through the source code of this project. But there's certain things that it does, like looks at the character encoding that's declared inside of the HTML page, and if none exist, it's going to try to do the default ISO format, and a lot of pages are in UTF-8. So anyway, you're going to end up having the page blow up on the encoding, especially when you try to write it out as just a regular string. So you have to have it properly encoded to a string that that write command understands with Python. So Python's always been a little bit of a challenge with character encoding and UTF-8 and things like that, but we did see how we could force it to be UTF-8 encoded. So that is how you kind of get around that. But you really need to research, okay, why is request using this default? What should it be? Things like that. So you have to add more logic to your program itself to look at the content headers and everything. But because this is a beginner course, we're not going to get into all this, complex Python code. This is stuff that might take you years, if not, 5 years, to actually truly understand how to read something like this and truly grasp, how to extend it and make it better and things like that. Hey guys, welcome back. So in this video, what we want to look at is our code logical operators that we had before. There's a lot more complication that you can do with this this if statement inside of Python. I'm going to clean up all these test files here. I don't actually want them cluttering up my workspace. I'm going to remove those to the recycle bin. I'll get rid of this big text file as well. These are all from the previous videos. We're going to create a new file that we're just going to call if elif.py. Now, a lot of times, you're going to have quite a bit of complication when it comes to okay, for instance, if you wanted to build a program that asks a bunch of questions and stuff like that, then yeah, we could easily do that. So let's go ahead and look at how to build an actual program that's going to take in some value. So it'll say, let's go ahead and say, let's to keep our program running, all we have to do is we could just say while true, and this has to be capitalized. That just keeps the program running literally indefinitely until you run out of power or the end of the world occurs or your computer dies. But it'll go forever. And we can go ahead and create this question object that we're going to say, the value equals, we're going to say raw input, and then we just ask the question. We're going to say what is your favorite language? All right, so now that we've asked that, we can assign that to the question, and then we're just going to say while true. Let me show you how we can crash the program. We're going to say print the question. Now, this is just going to continue to be like an infinite loop, like I said. So let's go ahead and do that real quick. So my days with Python go way back to Python 2.0, but if you're following in Python 2, then you are going to use raw input. But nowadays, it's just input for Python 3. So if I say, I'm going to ask what is their favorite language, and I go ahead and run this thing. So let's go ahead and add some logical operators to this statement here. So instead of just printing the question, having the thing go over and over again, we can actually say, you know what, if question equals Python, then we could say print you are awesome. All right, so we're going to do that. And then also I want to import a library that we can use a lot in Python, which is called import sys. And after the print statement, I want to go ahead and just say sys, sys. If I could, dang it, if I could type exit. Is it exit? Yeah, I think it's exit. All right, good. So sys.exit, and this will actually be able to bounce out of the program if they say that they like Python. So let's go ahead and run it. Is this thing running? What are you doing? All right, let's restart it. Now it's running. What is your favorite language? Python. Oh, you are awesome. Now it exits out of the program. So that's how you could do that. Now let's look at how we can do elif. So let's say elif question equals, so they put in the response of Ruby, right? And we'll say print Ruby sucks compared to Python. And then we can also do sys.exit, or you know what, we'll just keep bouncing around until they can say, you know what, I want you to basically say Python, else equals, we'll say C#, and I'll make that lowercase just to make all this lowercase, and we'll say print C# is not as good as Python. Clearly I'm trolling. I actually like C# a lot. But anyway, these give you some different, outcomes and everything based on what they're typing. But only if you type Python does it actually exit out of the infinite loop, because everybody should love Python, right? So what's your favorite language? Ruby. Ruby sucks compared to Python. Ruby sucks compared to Python. Ruby. Let's try C#. Now we get the C# message, and then if we try something else, we just get the same message over and over again. So let's go ahead and do a fail-safe on that. So we're just going to say the final elif. So by the way, if you don't know, the if is just going to go if. Okay, do that. If you could just have it over and over again and say if. But elif actually lets you understand. It's like I expect it to say, okay, if it's this, then do this, or if not, do that. Basically, it's indicating that you need to do something. Like we don't just want. It's not just if else. Like typically, if it's not if or else, it's some other if else kind of thing. And that's really what elif is doing for you. The final thing you can have on the end is just else, and this is going to be our fail-safe, and just say you suck balls. Or I shouldn't say that. Just say you suck. All right. So because it doesn't understand, I'm freaking out. I don't understand what you mean. So obviously our program is not very good because it only understands 3 commands. Otherwise it doesn't do anything. But let's go ahead and run it. So we have it. What's your favorite language? Now if I type something else, I'm freaking out. I don't understand what you mean. And if I type Python, we go back and we have you are awesome. So you could create a program in this same fashion that all you do is like this is how you would create a command line program. So basically when they type Python, instead of just printing out to a screen, you would actually execute some sort of like Python specific script or some script related to what it is that they typed in. And that is really all programming is. It's forks and logic. It says you hit a fork in the road. Are you going left or right? This isn't quantum mechanics. You can't go in both directions or exist simultaneously or whatever. Eventually we're going to get there with quantum computing. We're not there yet. It's either one or the other. So it's all atomic. Anyway, thanks for watching. Hey guys, what's up? So in this video series, what I want to do is look at TypeScript. So I want to get started from the ground level of what TypeScript is, how to get started with it. This actual module series is going to be used in conjunction with other different modules that I actually have. I have courses on React and TypeScript. I have courses on just generally TypeScript and also Angular, which is using TypeScript. So this is something that is definitely catching on. It was created by Microsoft several years ago, and it was really just to bring type safety to JavaScript. JavaScript as a language itself is considered a weakly typed dynamically interpreted, duck-typed language. And really all that means is that it's going to suffer from speed because there are no real type safety involved. So the compiler, every time it runs the application, has to figure out what type of types it's dealing with. And then there's a lot of different nuances and things that occur when types collide and smash together within JavaScript that can really create a lot of headache. So the TypeScript was created to try to solve that problem. It brings things to the JavaScript language that don't normally exist. Classes exist now, but if you look at classes with JavaScript compared to like other types of languages like C# or Java, they're not even remotely similar. In fact, JavaScript itself doesn't even have the concept of classes. It's actually it's really just objects and prototypical inheritance if you look that up. But the bottom line is that with TypeScript, you can use classes in a more sane way, and then you can also use things like interfaces that the C# language has to make programming a lot more powerful with reuse and polymorphism. And JavaScript itself does not have that type of support. So TypeScript is aiming to solve very, very complicated JavaScript applications, and we've already seen a lot of major, large JavaScript applications rewritten in TypeScript for that sanity that it provides. So in order to get started with TypeScript in the series, what I need you to do is you have to have an internet connection. We're going to have Node.js installed. So most programmers already have that, but if you don't, just go to Node.js. It's cross-platform. You just have to pick your installer. It's going to install it for you. But we do need Node.js because we have to use that in order to actually install TypeScript and use it. And then beyond that, you need some sort of editor to write your code in. And I like to put my code in Visual Studio Code because this is a cross-platform free text editor, so everybody has access to it. So this is what I choose, and it's also just a great product, really. And what we're going to do is we're going to go ahead and open up a folder to where we're going to have our project code be situated. So I'm going to say open folder, and I put all my tutorials inside of here. So I'm going to have a TypeScript folder, and we're just going to call this TypeScript. And oh, we already have one. That's not good. I'll just call this TypeScript update. I got TypeScript 2018. That'll work. All right, so we're going to go ahead and select that folder. So Visual Studio Code will open it up to that folder. And then now what I want to do is just right click and say Reveal in Explorer. And then from here, what we're going to do is type in, we're going to go into the TypeScript 2018. I didn't mean to do, and then we're going to press CMD. This is going to open up a command line to the folder that we just created. And what I want to use is npm. So if you've installed Node, like I said, then you're going to have this npm option. So if you type in npm, you'll be able to see which version you have. And we're going to use that to install TypeScript globally on our machine. So we're going to say npm install -g, which stands for globally. And that means just that it doesn't get installed locally in like your local Node modules folder. Inside of here, it's actually going to go in your main Node installation directory where the Node modules exist. And then here we just need to say we want to install TypeScript. All right, so this will reach across the web, and it's going to pull down the latest version of TypeScript, and it's going to update it, install it. I have version 3.2.1, which is the latest version as of the time of this video. And then just to verify that we have TypeScript installed correctly, we're going to be able to now use the tsc command, which is for TypeScript. So if I said tsc -v, that's going to give you the version number. So that tells you that TypeScript is installed on your machine and that we're good to go. All right, so in this video, what we want to do is create our first TypeScript file. So our TypeScript files are going to have the .ts extension, which is short for TypeScript. So if I said, test.ts, the Visual Studio Editor, I'll make this bigger, is going to be smart enough to recognize, oh, that's a TypeScript file. So it gives you the icon that it associates it with. So that's good. You want that because then it's going to be able to give you syntax highlighting and all kinds of stuff. And it's going to even be able to help you fill in the blanks and things like that. So what we can do is we can have just a simple alert hello message. So this is just regular JavaScript. Hi, I'm just JavaScript. All right, so this is standard JavaScript. Now, if I go to my command line where we have this, and I go into my directory, you can see we have this test.ts file that we created. And if I want to run that, I just have to simply say tsc, which is short for TypeScript, and say test.ts. Now, this is going to compile the application, and it's going to spit out the outcome. Now the output to a TypeScript file, when you compile it, it turns the convention is that it's going to create a test.js file. Like it's going to be the same name as your TypeScript file for whatever you try to compile. And you can see here that there was no compilation that really needed to occur because this TypeScript JavaScript is older JavaScript that just works in all the browsers. So no compilation needed to be done there. But what if we wanted to use more of a newer version of the syntax? Since we're targeting an older version of JavaScript, let's use a new feature of JavaScript that is like the constant keyword. So we have constant X, and this is a constant string. Now this takes less resources for the JavaScript engine because constants never change, so it doesn't have to worry about those values changing and things like that. So it has to devote less memory and things to that happening. So if you have something that doesn't change, you definitely want to use a constant. But let's go ahead and look at what happens then when we go ahead and we compile this again. So we're going to say, I didn't mean to say test.js. We're going to say tsc test.ts, and then once again, it doesn't look like anything happens, but it compiles, and then it creates this new test.js file. Now, here's the interesting thing. This is the constant that I was telling you about, but what happens is in the compilation, it turns it to the regular old var, because the constants aren't supported in the newer browsers. But in a nutshell, that is how you actually compile a TypeScript application and turn it to just a regular JavaScript application using the command line. Hey guys, what's up? Welcome back. So in this file, or this video, what we're doing is looking at the TS configuration file. The TS configuration file is very important for TypeScript because TypeScript, you can have multiple different ways that the application is compiled. You can target newer browsers, you can target older browsers. And when I say older browsers, I mean really old browsers, or you can target just ones that are a couple of years old. But TypeScript gives you that ability through the TS configuration file. So let's go ahead and create that now. We're going to say new file, all one word, tsconfig.json, which is a JSON file. And if you put this in brackets, since it's a JSON object, as soon as I do a double quote, you're going to see all the different things that I have on here. And I have this compiler options. This is where I can give it a target value, and this thing says ES3 by default. We want to say ES5. And then we can say, you know what, source maps is an option, or a source map. And we're going to say the value is true because we want to use source maps. And what source maps does is it allows us to debug our code inside the browser, the actual TypeScript code, before it got transferred over to this .js code. So let's look at how we can actually get this and see this project in action. Let's change this real quick. I want to go ahead and just say alert, so we can see that something is going on. We're going to alert our constant. And then also on the TS config here, what I want to do is there's an option to watch, and I want that to be true as well. That way we don't have to keep restarting our compiler every time we make a change to the test.ts. So when I go back, oh shoot, sorry, I almost cussed. But if I go back and I want to, let's open in the command prompt. Can I do that? Yeah, all right, that's cool. We're gonna open in the command prompt within this. All right, so cool, so here it is. So now if I just said tsc, and we say test.ts, you can see that it's gonna automatically pick up. So if you wanted to manually compile, you can do it from the command line. But in this, I want to show you how we can actually, and by the way, you can go over here, you can see that it actually did compile the way that we want it. But what I want to show you is if we wanted to use this tsconfig file in order to run this, what I want to do is go to task, and we're going to say run build task. And then up here, I can say, you know what, I want a ts watch on the tsconfig. And I'm going to click that, and you can see starting compilation in watch mode. So now as I go ahead and I make these changes, I can change this value to say Chris was here. And we go ahead and save it. You can see it's automatically detecting the changes. And we go over here, and you can see that it changed it to Chris was here. You're also going to see that we now have this .js map file, and that's for the source maps that I was telling you about. And let's go ahead and see how we could actually see the benefit of all this in action. Let's create a new file here, and I just want to call this index.html. This is going to be a standard HTML page, so let's have our HTML tag at the top. It's going to have a head. Inside the head, there should be a title, test application. And then after this, we'll put our body here, and then we'll put our h1, hello world, hello, we'll say TypeScript. And then let's see, now we want to go ahead and reference our actual file that's being outputted. So in our script tag, we're going to say, you know what, we want the root directory, and then go ahead and find the test.js file, because that's what we want the application to serve. We want that to serve the actual compiled code and not the TypeScript code, because otherwise the browser will freak out because it doesn't know how to handle that. Browsers only speak JavaScript. So let's go ahead and go to our application, or we want to pull up this this actual file here. So I can actually double click on it from here and say reveal in Explorer, and then just double click here, and this should open it up in a browser. And you can see we actually have our JavaScript code, so and we have hello TypeScript. And the benefit, like I said, is that as I go through this, and I'm like, let me make some changes here. Again, I'm going to go back to my TS file, and we'll just change this. Chris, change one more time, and press S. And then if we go back to the browser, and that's not it. It would be helpful if I still had it open, unfortunately. But I'm going to go back over here, just double click on my index, and you can see change one more time. So there was no recompilation or anything like that. It's going to listen to the files and everything's going to be fine. Hey, so in this video, I want to show you the benefit of the source maps that we set up in the previous video. If I right click and say inspect element from the browser where the application is running, and if I can either say F12 or right click and say inspect element. If I go over to my sources, this is where you're actually going to see that I can actually put a breakpoint on my TypeScript code. And if I refresh the page, I'm actually going to hit the breakpoint, and you can see that I'm actually debugging the code. But what is the code that's actually running in the browser is not the TypeScript. But because of source maps in HTML5, we're able to actually debug our TypeScript even though the browser is actually executing this raw JavaScript. It uses the magic of the source maps in order to figure out where in this code before it got compiled it should it hit and things like that. Sometimes there are some little quirks with the source maps, but for the most part it works really well, and you guys should know what that is doing for you and how it benefits you and how you could hit breakpoints from within your browser. So anyway, that's definitely an important feature. All right, guys, so let's go over to, with our command prompt open, let's go to the console here, and I just want to type in some raw JavaScript. I'm going to make this a little bigger so you guys can see it. And I just want to show you some of the benefits of what TypeScript is doing. There are types in JavaScript, right? This is a string, right? And then if I say type of X, you can see the type of X is a string. Now, this is just JavaScript. They're the same basic types from within TypeScript, but they're not exactly identical. So here is the TypeScript type. So these are all the different types that TypeScript has. But a lot of the different things are very similar. So you have string, and you can see that the way you declare types from within from within TypeScript is a little bit different. You do have to declare the actual type of value that it is that you're setting. Now, the thing about TypeScript is that that's what you should do, but it is not a requirement, and that's why linting tools are very, very important, because linting can be set up on a project, especially with multiple developers, to enforce that people are using types and things like that. Because if you're not enforcing types within TypeScript, there's really no reason to use TypeScript. So TypeScript is aiming to solve this problem to prevent normal bugs from occurring when you're trying to add strings to numbers and things like that. And why do I say that? Because if I went back to my browser here and I said, in JavaScript, if I said X is a string, obviously, and I said var Y equals a 3, so that's an int, right? So type of Y is going to be a number. And then if I were to say, I want the value of, we could just simply say alert, we'll just say X plus Y. Now, you can see that it just simply appended a number to a string. It didn't complain. There was no problems whatsoever. Almost every other language that's not dynamically interpreted and weakly typed is going to complain about something like that, because typically that's not something that you want to do, like, ever. Now, there are other quirks and weirdness to this, but that is just one example of why I wanted to show you that TypeScript is aiming to solve those types of issues. Because believe it or not, those types of bugs where like a weird type collision can occur like that can really be the source of most bugs within a JavaScript application. So expanding upon the previous demonstration that I showed you in the browser with JavaScript where it didn't complain whatsoever, let's go ahead and look at this. So constant is, let's change this to just a let, right? So let, and we're going to use proper TypeScript. So we're going to say that this is a string. So we're saying let X be a string, and we assign the value to it. Let's go ahead and say let Y is going to be a number. And we'll say it equals, and here's where it's going to complain. Like, so if you try to assign a string then to a number, you can see let is a number, and this isn't going to work. If you highlight over the actual red, it's going to tell you the exact problem. It says type 2 is not assignable to type number. So it says, it doesn't even, like, it says type, meaning it should tell you that it's a string. It doesn't really know. It just knows that it's not a number. So that's why it's saying that whatever this is, it's not what you need it to be. So by simply changing this to an actual number, you're going to get that problem to go away. Now, what happens if we went ahead? If we went ahead and we tried to do what we did before? We said x plus y, and if and under certain circumstances, TypeScript will make inferences based on the type of data. Now, if you have a string and you try to add a number to a string, you know that you can't add a string to a number and get any sort of valid response. So it's going to say, you know what, I think what you want to do is add a number to the string. So basically, that is considered to be acceptable behavior within TypeScript. And I know that that can still be confusing. But what is interesting is then once you have an actual value of y and it's a number, it's not going to simply allow you to change that value to something else. I can't just say y equals this is a string. It's going to protect you from being able to do something like that, because it's like, no, you declared y to be a number. So this is where mainly it's going to say, you know what, once you've declared that it's going to be a number, you're not going to be able to assign it. But if you do need to go ahead and change it to something else, then you can actually convert it if you wanted to. So in the previous video, I did say that you can convert values, but one of the things I want to show you is that once you use the let keyword and you declare the variable of x or y, like we have in this example, you can't then just change it to whatever you want. Now you can change the value of it if you wanted to. So I could say, because x is a string, I can change this is a different value, and that's not going to complain. That's fine. Y, I can even change it to a number, a different number. Let's change it to 3. But you can't change it to a string. But what if I wanted to change, y to a string? Well, you can't redeclare y. So that is something. Let's go ahead and look at that. What we're going to have to do is create a new variable that I could say let test equals, and this is going to be. And what we're going to do is use a built-in keyword here, and we're going to say I want to use the string, and then I'm going to pass in the value of my number that I want to turn to string. So then I can just say console.log test. Now this is called converting. So what we've done is we've taken a number type and then we declared a new variable, and we said, you know what, take that number type and then change it to a string. So this is called converting. And we converted a number to a string. And the concept is similar if you needed to turn a string to a number or any other data type that will be able to convert just fine. Not all things can be converted very easily, as you'll see later on, but for strings, ints, bools, things like that, you can easily turn them from strings to numbers and booleans and things like that. And if we pull up our application, refresh, if everything's going well, we're going to have a error message here. 1 second, I think. Oh no, it's it's console logging. Yeah, a console log test. I'm sorry, I didn't mean to do that, but let's just console log type of. We'll use the type of. And that way you can see that it did actually cast it or convert it to, it's not casting, by the way, it's converting. There's two different things in TypeScript, but it did convert it to a different value type. So instead of printing the actual value, which is a string, you're going to see that it actually prints the type of the value string. So even though it's a number, it's actually a string. So we turned a number to a string, and that's how you convert in TypeScript. All right, so in this video, what we're going to look at is how to do function parameters or arguments passed to a function in TypeScript, and how do you declare those. So declaring a function in your application is just like regular JavaScript. You just say function, and we'll say my function, and we'll just say this is going to be a print function. And the print function is going to take in what it is that we actually want to print. So what is the actual argument? We're going to say value, and what type is it? And this is where you actually declare the type of value that's going to be passed into this function. This actually does a number of things, because in normal JavaScript, it's going to look like just this, and you have no idea what value really is. You don't know if value is supposed to be a number or whatever it is. But with TypeScript, we can say, it's going to be a string, and if you try to pass anything other than a string, it's going to puke and freak out on you, where it wouldn't in normal JavaScript. So here, let's go ahead and we'll declare a constant. So we'll say constant my const equals you suck. All right, and then what we're going to do is here we'll go ahead and just alert the value that's passed in. And in order to call our function, we're just going to simply call it, and then we're going to pass in the constant that we have just declared, which is called my constant. And by doing that, we can now recompile, and then this should just go ahead and print. And if we refresh, you can see that we get the page "you suck" or the alert message there. And the interesting thing of note, so if you had an array or different types of value types that you have from within TypeScript, you could do that. But here you can see that it's like, okay, you have an array, but we don't like this isn't going to work. And the reason why is because in TypeScript, you have to actually say when you're dealing with an array, you have to say what type of an array am I dealing with? And it's going to be an array of string values. And I don't know why this thing is automatically formatting like that. That's really annoying. But you have to delete that. And this actually signifies to TypeScript, okay, I have an array of string values. So now let's go ahead and loop through our array. So we're going to say for let x equals 0 if x is less than value.length, and then we're going to say xx plus 1, and then here we're just going to we'll alert all the values, and we'll alert x. All right, so now we have this constant can't be a constant. You can see it's freaking out because it's like, oh, you're trying to pass this string constant into a function that only accepts an array. And you can see here it tells you, it says it needs an array of string values, and that's what it's saying. It's like you have to pass that in order to satisfy that. So how do we do that? Let's go ahead and create an array, and we're going to say my. And the array is it's a little bit different. So after you declare, okay, I want my array to be called my array, you then need to say what it is that it's an array of. So it's an array of string. And if you remember, the message said that I needed to pass in an array of string, and it gave the string array with this type of symbol. So that's how we know to do that. And you can see it's complaining right now because it's like, oh, you haven't assigned any variable to that. So we need to go ahead and pass in a list of strings. So now that we've done that, we can say 1, 2, 3. So we have three strings in our array. And then instead of here, we're not going to do this, but we're going to call the new function that we have. So we're going to say print, and then we're going to pass in my array. And now you can see that there are no error messages. And this is going to loop through the array, and it's going to console log or alert to the screen, every one of these values. So 1, 2, and 3. So if we pull up our application again, I refresh, and you're going to see 0, 1, 2. And then why did it do that, right? Because the values itself were the reason why is because I referenced the index, which is really stupid. That's just a normal JavaScript a bug. It has nothing to do with it. We're just alerting the actual index value here. That's not what we want. We actually want to say, I want to alert the value of my value, which is array, and I want to say get the index of that array, which is whatever sort of index number it's on. So 0 is going to now print 1, and 1 would print 2, and 2 would print 3, because computer programs or computer languages and operating systems, computers count it, starting at 0. So anyway, all right, let's go back. And instead of actually alerting the index, we're now going to get the values of the array. All right, so in this video, we're going to look at the built-in type for TypeScript, which is called the enum. And the enum is something that comes from the C# language. It can be a little bit complicated to actually wrap your head around it, but really it's just about having a clear type annotation to be able to reference data. So you declare an array, or not an array, but an enum, by just simply saying enum, which is the keyword, and then you're going to give it the actual name of the enum that you're looking to use. And we're just going to use the color example here. So this is the color, and then I can go ahead and pass in a few values. We'll say red, green, and blue. They should be comma separated or delimited. And then what I can do is let's go ahead and see. Let's go ahead and create a variable. We're going to say let x, and x is going to be of type color. So we want to say, it's going to be an enum of color. That's the type that it's dealing with. Again, this is probably hard to wrap your head around, but what I can do is I can actually say, since I'm dealing with color, I can actually assign the value of x to be color dots. I can give any one of these, but you can see the IntelliSense is actually giving us the information we need. So we get that dot annotation on our enums to make things a little bit easier. So now what is this? So let's go ahead and alert x. And then we're also going to alert on the same one. We're going to say type of x. I want to just show you what's going on here. So 2 alert messages to the screen. And we'll refresh our page, and you can see that we get the value of 1, and then we get that it's a type of number. So why is that? So enum's returning a type of number. So by default, because we reference and computers start counting at 0, we reference the second value of the enum. The enums get a default value of an integer. And we could actually say, you know, I don't want red to be equal to 0. I can actually say, you know, I want red to be equal to 1, and the counting will start at 1 then, so that green would then be 2 and blue would then be 3. So if you don't want it to count from 0, which a lot of people don't with enums. So again, now if I refresh, it's going to start with 2 in number, because that's, if I, let me just, I'm going to do red here so you guys can see that instead of 0, it's going to be 1. I think that could also be derived from the last number that just got printed there, but that's how you can start, you know, the different values of an enum. So another thing to look at with this is this can be confusing. What if you had like 1,000,000 records in here and you started at 1 and you're like, you know what, I need to get the value of blue, but I have no idea what number it is. Now clearly it's number 3 in this one, but what if there, like I said, there was 1,000,000? You're not going to sit there and count all those values to figure out you know, what number that is, but you can actually get the actual value and not just its underlying numerical value. So if you wanted to get the actual name like red, green, blue, or whatever to be returned, we can do that. We can actually say, let's create a new variable. We'll say my var equals, we have to declare the actual type, and we want to say my var equals a string, because we want to get the actual string value of the enum. So we're saying, you know what, have that be a string, and then we're going to say it equals the color of, and then you could pass in the actual index number if you had it, and then it's going to return the actual numerical value. Now that doesn't actually solve the problem of how do I get the actual numerical value. Well, that's why you get the numerical value using the dot annotation from the enum, and then you could reference that numerical value here. So I could even do something as crazy as like color dot blue, right? So I'm going to select blue, and it's going to assign that value. So what I'm going to do is my var is now going to equal blue. So if you needed to, like I said, if there's 1,000,000 records, it's easier to just say, you know, I need the textual representation of that value in the enum, but I need to find the index number. And how do you do that? Well, you're going to reference the actual string value, and you can't have duplicate string values in here. So you can't have multiple greens and stuff like that, or it will freak out. And just so you know, if I typed in green, you can see it freaks out. Duplicate identifier. You can't have duplicate identifiers in an enum. Enums are really about dot notation. If you needed to have like certain features, like okay, you know, toggle.on is one and toggle.off is 0. You know what I mean? Like it's easier to read set toggle, you know, set toggle.on versus you know, set toggle to 1. You know, it doesn't really signify as much, right? One, you could kind of, from a programming perspective, you know, 1s and 0s, you know, open and close, but for the most part, like it's just the enums are they're all about dot notation and making your code easier to read. So here, let's go ahead and alert the value of my var, and I just want to show you that this is going to return the value of blue. And when we refresh here, you can see the value of blue is being returned as opposed to the actual index number that blue is from within that enum. So I could also change this to a number if I wanted to. And you can see that because it's returning an actual string, it's going to freak out. It says a string's not returnable. So this is where I can use that dot annotation and be like, you know what, I want green. I'll just say green, right? So because this is going to return a number, you can assign it a number and you can actually get it output. So if we refresh, you can see that we get the value of 2. So that is how you use enums. It's all about dot annotation, just to make your code easier to read. You don't have to use them, but they are very beneficial, especially for large, complicated programs, and you at least have to know how to use them. So here what we're going to do is look at the any type. And the any type is basically, it can be an escape when you don't know what type of variable you're dealing with. So I can actually say, you know what, let x equals, let x be any, and equal, and we could just declare it, right? So I could say let x be any. So x can be anything it wants. It could be a number. It's not going to freak out because you just said, you know, it can be anything you want it to be. So I could say var y is, this is a string, obviously. And then now because I said that x could be whatever I wanted it to be, and we'll just go ahead and say var z equals a number. So I could actually say let x equal z. and it's not going to freak out because you didn't specify exactly what you wanted it to be. But I can also declare it to be a string as well. Now you want to be very, very limited with any though, because it's kind of like a backdoor. It's a way out of the type system within TypeScript. Sometimes you do not know what type you're dealing with until runtime, so that's why you need the any keyword. Other times you just simply want to get by really quickly, and you just start throwing any's out there all over the place. But that's not what a good TypeScript developer should do. But here, like you said, it's just kind of a get out of jail free type of card, where you can declare that type anywhere. Now, just like we saw with functions that could pass in strings, and you declare a parameter and what types those are, you can do the same thing. So any one of these types, any could be used anywhere you see strings, numbers, and all that other stuff. So that's really all about the any keyword. When you see it, it just simply means it could reference any type. Hey guys, what's up? Welcome to this new tutorial series that I'm making for Udemy. And in this series, we're going to be looking at TypeScript and React. And those are two different technologies I just want to briefly touch upon right now. So TypeScript was created back in 2012 by Microsoft originally, but it's an open source project now. So it's actually a community-driven project. So even if Microsoft were to decide not to use TypeScript, it could still go on in existence. It would be just fine, just due to the community support. But because Microsoft is behind it, it's a huge company. It is a very good language. It's bringing static type checking to JavaScript. I have videos on the subject, but JavaScript is a weakly typed language. It does not care about strings and ints and numbers, and you could pass anything around. There's nothing to indicate on functions when you're reading the code as to what type of data structure certain functions expect. And ultimately, it can be very, very confusing for large-scale development. And there's a reason why large languages and fully object-oriented languages, what I mean by that when I say fully object-oriented, but languages like Java and C#, there's no way to procedurally write the code. You have to write it out into objects. You have classes and interfaces and things like that. Well, JavaScript normally doesn't have classes and interfaces, although it is getting it in the latest versions of the language. TypeScript brings classes to the language as well as things like enums, and you can also write some of the latest JavaScript using it, like arrow functions, promises. A lot of the libraries and everything are using it as well. So React is a project that is written by Facebook. So it's a front-end framework. It's for the Vue and MVC. It assists, so it doesn't matter what your stack is. It can just run inside the browser, but it does very good state maintenance, and it's very component-driven. So those two tools together make a lot of sense. So that's what this tutorial is going to cover, just quickly how to get those tools up and running so you guys can start developing in TypeScript and React. Now there's a couple of dependencies you need to get started with this tutorial, but also just in general. You need to have Node.js installed, so make sure you have that on your machine. Node.js comes with a popular package manager that we're going to be using called npm, and it's important that you have that. In addition to that, you also need some sort of editor to write your code into, so something that makes your life a lot easier, because you technically could use Notepad, but it would be terrible if you were to ever use something like this to write your code. It's possible, but it would be awful. So that's why we use things like Visual Studio Code that allows us to get proper highlighting. It gives you error support and things like that, like hints about what your problem could be. There's all these different plugins that are community driven. The product's also free and it works across platforms. So I would recommend that you guys use that, but you don't necessarily have to. You can use whatever sort of text editor or IDE that you like. So now that we've seen what React and TypeScript is, why would you want to use it? Well, number one, it's growing a lot of support within the corporate world. There's a lot of jobs that are in TypeScript, and it seems to be growing, at least in the United States, every single day. TypeScript developers also make a lot of money. I know people that are making $120,000 a year writing TypeScript. That's not an uncommon thing. A lot of big tools are being written in TypeScript as well. Even tools that were written years ago, like this popular WYSIWYG editor that's a word like runs in the browser. This is a popular project that goes back at least 10 years. But it's being rewritten in TypeScript because TypeScript makes a lot of sense, even for that open source community that has nothing to do with Microsoft, but it just makes a lot of sense for their project to use TypeScript. a lot of people say once you start using it, you find no other reason to go back to JavaScript. The thing is, a lot of people don't really understand as well with TypeScript is that it's a superset. Hey guys, of JavaScript, and it just means that it runs on top of JavaScript. So your code is going to be executed, and then it gets turned into raw JavaScript. So that can be considered transpiled. Some people just call it compiled, but that's what TypeScript is doing behind the scenes. You write in a TypeScript specific way, but you don't necessarily have to write your TypeScript out in TypeScript. So a lot of people know that, but just making sure you guys know that. So in the following video, we're going to see how to get started with our project. So if you've used Visual Studio Code, or if you download it like I suggested, what we're going to do is open up the folder, and we're going to open up to a location that I've created called Projects, TypeScript, Udemy. You can put your project wherever you want. It doesn't really matter. But we're starting fresh in here. And what I'm going to do is right click with my mouse and say Reveal and Explore. I'm going to remove this and type CMD so I can get to the command line. And I need to dir into my project in Udemy. All right, so now I'm going to say, make sure you guys can see this. I'm going to say npm init, which is going to create my new file. And we're just going to call this a music file. It's a project. So we'll say my Udemy tutorial. And index is fine, so we'll just press enter for all this stuff. I'll get credit for this. And we'll just put okay. All right, so then we're going to go ahead and npm install a few dependencies that we're going to need in order to get up and running with everything. Now, this is going to be really long as far as this list of things you have to install, but unfortunately, it's all like necessary, and we just have to go through this. So we're going to say Webpack CLI, and make sure there's spaces every time you're typing in something new. We're going to install TypeScript. We're going to install TS Loader, and that's TS-Loader. We're going to install React and React DOM. Those are two separate projects. There's also these types that we're going to be installing because, as you know, TypeScript is a strongly typed language. And if you wanted to define objects that the React and React DOM libraries need, the type objects, it would take you forever. So somebody's already done that. That's why we're installing those. Other than that, that's really it. I know that's not a ton right now. There's going to be one, a couple more probably. No, really one more, because we're going to need to set up a server as well. So, 1 second. What did I type? Oh, I didn't type. Yeah, you got to say npm install. I'm so stupid. So I'm going to go back here and just say install. So you need to say npm install to install all those separate dependencies. Now, this is going to reach across the web. It's going to install every one of those dependencies. And every one of those dependencies also has like a package.json file that has a bunch of dependencies on its own. So it can get crazy complex when you're looking at a dependency tree. When we created that init command on the command line, or we executed it, it created this package.json file. And this is just a JSON serialization of data. It's all just very dictionary-like key value. Values can be, obviously their own objects and dictionaries and things. So obviously, I think most people probably know what JSON is, but this is a configuration file that's going to be basically the cockpit of your project. It has all your dependency, everything that your project needs in order to function. You're also going to have special commands that we're going to add right now. So one of those commands is going to be called build. And in here, I want to put Webpack. I'm gonna just it's funny, you're gonna see how this works, but when we do npm run build, it's gonna execute this script and it's just gonna call Webpack, but it's not gonna call the global install version of Webpack. It's gonna find the Webpack that's local in your node modules folder. So that's one of the tricks of being able to not have to install everything globally. Another thing we're gonna do is I'm gonna have a run command. You know what? Let's call it start. I like start better, and this is going to call something called HTTP server. You know what? Let's scratch that. We're gonna scratch that. I'll get back to that in just a second. I'm gonna address that in a different module. All right, so let's definitely have this command in here that says build in Webpack. Now, you're also going to have this package lock file that gets created for you, and that's after these node modules get installed, but sometimes you have to delete that if things get buggy. But if everything worked okay, you should have a screen similar to this. You might get some warnings and things like that, but you should get no failures, so everything should be good. Also, we're using the latest version, the stable version of TypeScript. If you ever wanted to use the latest, you could end up, you could do npm install TypeScript. I'm trying to remember the syntax, and I think it's at latest. If you executed that command, it would actually grab the nightly build version, the one that's literally just out. So if you wanted to get a head start on the latest version, that's how you would do it. Hey guys, what's up? Welcome back. So in this video, what we want to do is actually set up our Webpack config. That's going to be a separate configuration file, and we're going to take a look at that now. Let's pull up our editor, and we're actually going to create this new file, and we're going to call it webpack.config.js. And inside of here, it's important that at the top you're going to say constant path equals require, and we're going to be requiring a module that we want, which is path, and this is actually just going to make our lives easier. So the next thing we want to do is we want to write module.exports equals, and this is going to be an object. So we're going to set our entry point for the project, and the overall entry point is going to be in our source directory, and we're going to have an index.tsx file that we're going to use. And then we're going to go ahead and define our module, and our module is going to have a few rules associated with it, which is a list, and it's a list of objects, and those objects have key values. So the first one is going to be a regular expression. We're going to say basically we want you to work on all files that end in a TSX extension, and that's the regular expression for that. And it says when you find that match, you're going to use the TS loader plugin, which it's going to look for in the node modules folder, which we installed earlier in an earlier video. And then we're going to say, you know what, I don't want you to look through node modules folders because that's going to take forever, and it's node module, and that's going to take forever because there's a ton of stuff in your node module folder, so don't mess with that. Next thing I want to say, the dev tool, I wanted to use source maps, because that gives us the ability to debug our code before it got compiled. Now we also have a watch as well. We want to watch, that way we don't have to keep executing the build. We can just say, you know, webpack run, and it'll just watch constantly for any changes made to the files, and then it'll retranspile or compile them based on that. So finally, we want to say, overall, we want you to work your magic on converting files that end in a TSX, a .ts, and probably a .js, obviously. Your extensions could be all kinds of different things here. That should be about right. And then finally, we want our output, and this is a object that needs to have our file name. Our file name can be whatever you want it to be, but by convention, I'm going to use bundle.js, which a lot of names are called that. Finally, we want to say the path to the directory where that file can be written to, and that's where we want to say path.resolve, and we're using this dir name directory name, and it gets the directory from where this webpack config file is located. We're also saying when you output this bundle file, put it in a distribution file that sits inside of this root directory, so you can see I said file, but folder, I mean, but you can see in here that there is no folder for dist, so we're going to go ahead and create that. And then we also need to go ahead and create a source folder, and that needs to stay out of the dist, so it needs to be in the root directory. And then finally, we have this index.tsx file. So in the next video, we will see what we're gonna do with that. Hey guys, what's up? Welcome back. So in this video, what we want to do is actually set up our Webpack config. That's going to be a separate configuration file, and we're going to take a look at that now. Let's pull up our editor, and we're actually going to create this new file, and we're going to call it webpack.config.js. And inside of here, it's important that at the top you're going to say constant path equals require, and we're going to be requiring a module that we want, which is path, and this is actually just going to make our lives easier. So the next thing we want to do is we want to write module.exports equals, and this is going to be an object. So we're going to set our entry point for the project, and the overall entry point is going to be in our source directory, and we're going to have an index.tsx file that we're going to use. And then we're going to go ahead and define our module. And our module is going to have a few rules associated with it, which is a list, and it's a list of objects, and those objects have key values. So the first one is going to be a regular expression. We're going to say basically we want you to work on all files that end in a TSX extension, and that's the regular expression for that. And it says when you find that match, you're going to use the TS loader plugin, which it's going to look for in the node modules folder, which we installed earlier in an earlier video. And then we're going to say, you know what, I don't want you to look through node modules folders because that's going to take forever. It's node module, and that's going to take forever because there's a ton of stuff in your node module folder, so don't mess with that. Next thing I want to say, the dev tool, I wanted to use source maps because that gives us the ability to debug our code before it got compiled. Now we also have a watch as well. We want to watch, that way we don't have to keep executing the build. We can just say, you know, webpack run, and it'll just watch constantly for any changes made to the files, and then it'll retranspile or compile them based on that. So finally, we want to say overall we want you to work your magic on converting files that end in a TSX, a .ts, and probably a .js, obviously. Your extensions can be all kinds of different things here. That should be about right. And then finally we want our output, and this is a object that needs to have our file name. Our file name can be whatever you want it to be, but by convention I'm going to use bundle.js, which a lot of names are called that. Finally, we want to say the path to the directory where that file can be written to, and that's where we want to say path.resolve, and we're using this dir name directory name, and it gets the directory from where this webpack config file is located. We're also saying when you output this bundle file, put it in a distribution file that sits inside of this root directory. So you can see, I said file, but folder, I mean, but you can see in here that there is no folder for dist, so we're going to go ahead and create that. And then we also need to go ahead and create a source folder, and that needs to stay out of the dist, so it needs to be in the root directory. And then finally, we have this index.tsx file. So in the next video, we will see what we're gonna do with that. All right, so in this video, what we're going to look at is how to actually get our code to compile and go into the dist folder. If we remember from the earlier videos, we edited this build and we said to run webpack. Well, now we have this webpack config, so when we go to run that, it's going to look at our config, and it's going to know how to load modules. It's going to know to look for TSX files and JavaScript files. It's going to know to look inside the source for an index.tsx file, which it's looking for, and that's going to exist. And if that doesn't, you're going to get an error message. But if everything goes well, you're going to want to go to your command line where we've installed the server. And really, I'm going to go ahead and open up another command line. So let's go ahead and where the project is located, I'm going to cmd into here. And we're going to go ahead and run our npm run build. All right, and you can see that it's just firing off the webpack. Webpack is being found locally. Webpack's reading the config file that we just created. It bundled up modules. It loaded like React for us. It put it all into one JavaScript file as well as a map file in there because we are using source maps. So that means that if I go to the browser, and you may have to clear your cache. So what you're going to want to do is right click or press F12. It'll open up your developer console. And by doing that, if you hold down the refresh button, you can say empty cache and hard reload. And that'll make sure it grabs, you know, the latest version of your distribution file, because you're going to know, and you'll find that the browser is constantly caching that. Now another thing, because the HTML file changed, normally I shouldn't have to do this, but it seems like it could be caught up as well. But sometimes you might have to kill your web server and run that over as well too if you made changes to some of the files that it's listening to. So now you can see when we look at this file and we refresh, we can see hello dude. So the spectacular thing behind that is, if you recall, if you go back to the HTML page, there is no hello dude in there. It all got bound to the div ID, and the hello dude came from actual React code that you wrote in JSX using TypeScript with a TypeScript compiler and a TS loader and all kinds of other stuff. So that's what you did in this video, and you should be proud of yourself. Hey guys, so I want to take a moment to look at the two different types of components that exist within React. You have the stateless functional components, and then you also have the class-based components. I told you the differences between the two really were that the class-based one has a state and the other one does not. And that's really a big difference. State has a lot of overhead that has to be maintained within the JSX, or not just JSX, but the React library, because it's listening for any sort of data changes and re-rendering itself and things like that. So there's a lot of work that goes on there. So if the component doesn't need that, then it should be a stateless function component. Now, so basically, if you have a component that does not change or mutate itself based on some sort of action, then it should be stateless. And if this header is only ever displaying text, like this is the perfect example of a stateless component. You don't need to have a class on this. Like, text shouldn't really change. I mean, it should be just a simple control. If you have simple controls, make them constants, make them use this fat arrow function syntax to make them stateless. Where your component has more complexity, like our videos module, that's where they should have state, and you're going to see in a moment why this is important. Let's go ahead and set an initial state, and we're going to say testing state is the name of our key, and we're going to say this is crazy. So now, instead of saying this.props, like the value that gets passed in, we're going to say this.state, and then we can say testing state. So now if we go back and look at the code or the browser, you can see that we get the latest result. This is crazy. So now, real quick, I'm going to go ahead and create a click event on this this item right here, and we're going to call this just test click. All right, and then we're just going to alert. Actually, instead of alerting, we're going to change the state. So we're going to say this.set state, and we're going to pass in a new value for the testing state key, and we're going to say we change the state. The component new. All right, so now what I want to do is I want to go ahead and have a button here that has an onClick event that's going to call this.test click, and inside we're going to say click me, and then close off our button. So now that we've done that, so this is going to be firing and changing the state when we go ahead and execute it. So to see that in action without any sort of page refreshes or anything like that, you can see we now have the original message that we assigned when the component got rendered. And then we have this click me, and when we click me, it's going to call the local event, but it's going to cancel out, and it's going to say set state of undefined. Why? Now this is a beginner, very big confusion for React, especially ES6 and its classes. This context gets lost when it's executed from within this JSX, so that this no longer refers to the class video. So in order to make sure that this that gets passed around is always attached to this class video, we want to go ahead and bind it. So we're going to do that now. We're going to say this.testClick equals this.testClick dot bind, and we're passing in this parameter. So this ensures now that from within our function, if we ever need to reference anything attached to our class video, that it will know how to find it. So that gets you around that problem. So now when we click this, we have the state changed, and it says the component new. So every time we're clicking this, it's actually, React knows that the state is being updated, but it also knows when it changed or not. So this is not even being re-rendered even when you click me over and over again. It's not trying to update the same state with the same value over and over again. Well, it is, but it's not actually doing it. All right, so guys, in this video, we want to go ahead and use that module that we imported up here at the top. So that's, we weren't using it before. I got rid of some of the test data that we had from our previous video. I'm going to get rid of this state change and get rid of this state value as well. I want to keep state there, but I'm going to get rid of the testing state value. All right, so I want the button to still be there as well because we're going to make use of that. So let's go ahead and write the YouTube component. And it doesn't even take any arguments or anything like that. So if you wanted to use it though, you need to pass in the video ID, and the video ID should be some sort of ID that you want to use. And if I go to my project, I have this data, and this is all the videos I've ever had. So I'm just going to go ahead and just click any one random video. I don't really care. And go over here, and I'm going to paste that video ID in. And now that we've done that, let's go back to the browser. And now when we go to refresh, you can see that we now have this this ability to be able to view the video right into the browser and things like that. So that's pretty cool. And we didn't have to write any code behind that. All we had to do was just simply npm install something, import it, and then assign a video ID. And somebody else created all the work that calls out to YouTube to get the data and like populate an iframe and all that stuff. So probably not a ton of work, but it still saves us a lot of time because there's all kinds of components that we can tap into. So we've looked at two different ways of being able to pass data to our components. One that we passed in for the stateless components, we actually just passed in simple data that we referenced via props. Now the props that get passed in, you can see that the difference is that number one, props are they're immutable, so the values never change. They should never change, especially on a functional component. And so if the data doesn't need to change, then it doesn't need to have state. It doesn't need state listening for any sort of data changes to it. So therefore, if you have data that doesn't change, you should use props. And if you have data that is dynamic and does change, you should use state. So the difference between, like, if you wanted to use your control, if we're using something like the control that we have to pass our data into, like if we go to the main page, when we used our button component, we passed in data by setting the value of text. Let me show you. Basically what I mean is if we were to go in here, if I wanted to pass data to my control, I can reference my controls dot, I'll say header, and then remember header gets props. So this is how to pass props. So you're always going to pass props via these attribute tags that you pass into the actual component that you've created. So that's how you pass props in. State you're not going to really pass in unless you wanted to assign some prop value to your state. You could do that if you wanted to. The difference, and another confusing thing is that the way that you pass props to your controls can be either can be passed via the same way via whether it's a stateless control or a stateful control. It doesn't matter. You still can pass props to both the same way. So what do I mean by that? I mean our video object could actually take in some sort of props that says this dot testing props, and you can see it's going to complain. It's like, I don't know what that is. And that's where we're going to go ahead and define it. We're going to say testing props, and it's a string. And if I could actually spell this right, it's testing props is a string. And you can see that in just a moment here. This needs to say props as well. Geez. All right, so now that we're saying testing props, so now when we go to look at the video, you can see it's complaining. It's like, oh, now you have this missing prop. So if I said testing props and I pass in, now it's happy with me, and we go and review, you can see that our control is using all this stuff. It doesn't matter. So state control can also have props as well. So just know that even stable controls that are class-based can have props. All right, guys, let's look at how to also be able to transport some data. I wrote a quick and dirty Python script that I can show you guys in just a second, but it basically is it just went through a directory of file names that I have, and my file names are actually the IDs for all the videos that I've ever done. So I've done like 700 videos on YouTube, and I have all of those videos in a directory. So my Python script just, I can't even share it at the moment, but it went through the directory, it created a big large JSON file, and I'm going to go ahead and actually add that to my project because I'm going to be able to show you guys very dynamic nature of why you want to use React and TypeScript together. But it makes development fun, I think. So let's go ahead and create a new folder inside here. I'm going to call this data because it's just like mock data. I'm also going to go ahead and I need to just go ahead and copy my file from this other location. So I went ahead and pasted this file in. Like I said, it's just a huge JSON object, but you can actually export data as well. I mean, it's not even a JSON object, it's a list, but it gets serialized to JSON, but you can see you could export it just like that. So if I wanted to use something like that and like a very dynamic control, let's go ahead and do that. I'm going to create something. So we're actually going to use a third-party library in this this video because it's going to be really cool. I'm going to kill our watch for right now. I'm going to stop it. I'm going to say npm install, and we're going to call on React YT. And this allows us to use YouTube. It's actually just, there are so many components out there that are in the React infrastructure that can just save you so much time just installing it. You know, work that somebody's already done developing a control. So for instance, I'll go ahead and in my module, I'm going to create a file that I'm going to call video. It's a video. I should have a .tsx extension on that, so I'm going to do that .tsx. And then inside here, this is going to be a full-blown stateful control written in React. So again, we have to do import all as React from React, and we're going to import the YouTube object as well from the project that we just installed. This is the component that was just created for us without having to do any work. And then finally, I want to go ahead and import that data that I was exporting from the from earlier in this video, and that's going to be located in. I need to tell it to go to back up a directory, go to data, and then find it in the videos data. So there we go. All right, that'll work. And then yeah, that's really it. So now what we need to do is we need to create our class. And we're going to call it a video object, and it extends react.component, and this takes in an argument. There's two arguments. The first one says I need to know what type of data you're going to be dealing with, so we're just going to call this iProps, which is just like we're going to use this shorthand interface to identify what our props should be. And then finally our state is going to be a cop out for right now. It's going to be just any object. That's the state that you can that the component has. We need to go ahead and have a constructor function, and this is going to go ahead and take in the props, and for right now the props is going to be the iProps that we have not defined. You can see that we're getting a complaint on that, so let's go ahead and just create our interface real quick, and we're going to call it iProps, and there we go. And now you can see that this is fine, but our constructor function needs to be finished off, and inside here we need to call super, which is going to call the React component, the React base class, and it's going to call its constructor function and pass in the props that got passed to it. Next, we're going to go ahead and say this dot state equals an empty object. So every React component has the ability to manage its state, and this also needs to be inside the constructor function. But every component that is class-based from within the React library that's not a functional stateless component, like we talked about in earlier videos, is going to have the ability to maintain its own state. And it's pretty cool, and we'll see in a moment why. All right, so in this, and after the constructor, let's go ahead and we need to go ahead and call the render. We're going to have a render function, and it's going to return a bunch of stuff. And we tell render to return. For right now, we're going to say testing the video. Close off our div tag and fix this nonsense. All right, finally, we need to be able to, at the end of our class, we want to be able to export our class. So we're going to say export video. Why does it keep doing that? Stop doing that. All right, there we go. So everything looks good there. You can see we're not using these other objects yet, but that's fine. We're going to see in a second how we can do that. Other than that, let's make sure our project is actually compiling again. So let's go ahead and run the build. Okay, now I want to use this new video control within the main page. So instead of all these other controls, we're going to say import video from dot controls video. Wait, no, not that, modules video. All right, so now we're doing that. I'm going to get rid of this stuff. In fact, I'm going to get rid of all this crap. I just want to have the video class that we just brought in. You can see it doesn't require anything. Like our props didn't say that you needed to pass anything, and it didn't care. So now the video module is being loaded and all this stuff is being done. If everything goes well and we look at our server, you're going to clear the cache again, and you can see that we're getting the value now that got passed in. So let's go ahead and make our application a little bit more dynamic. We have this click me button that is on here. All right, so what I'm going to do is instead of, when it fires the test click, what we're going to do is we're going to say, you know what, the video ID is going to be something very dynamic. It's going to say data, and this is the data objects that was, remember, it's just a list of videos in that data that I've imported. So inside of there, I'm going to say that the video ID is going to be equal to, in fact, we're going to assign this to state. So we'll say this.state.random number. So we have this random number, and for now we're going to say random number equals math.floor, and then we're going to call the math.random function multiplied by the data.length, which is the amount of elements that I have in there. And then the +1 is basically, it means that you find a random number between between however many numbers of videos that I have, between 1 and that many number of videos that I have, which is inside data.length, which is roughly like 700 something videos on YouTube or something like that. So you guys should make sure you subscribe to me. Now the test click function is going to go ahead and it's going to change the state of this random number, but let's go ahead and see if the random number is first working. So you can't just reference the random number as the video ID. That's not going to work. So we obviously need to say data, and then the argument for the data number is going to be, that's not right. We need to look at the actual structure of the data file. I realize that these are all, they're actually, it's not an array of string, it's actually an array of objects that we need to reference by ID to get the value. So we could still reference it randomly, but we need to say, you know what, the string that you're passing in is the ID value of that random object that you're getting. So let's go ahead and see if this works. So by setting state initially, it should just give it a random number every time we load the page. And it's not working, but again, it's because you have to clear your cache. And now every time we refresh, we're getting a new video. So that's pretty awesome. So that's how you could have some very dynamic behavior. Finally, let's go ahead and in the test click, when you click the button, instead of having to refresh the page, we're going to say this.setState. And you update the dictionary object in here. So we're going to say random number now equals, and we really have to call this duplicate logic. We probably could have extracted this out into a function or something, but we're going to essentially say, you know what, and because we can't do this kind of complicated logic inside of a JavaScript object, we're going to go ahead and just create a random number. So we're going to say let random equal math.floor, and we could copy this same line up here. So this is getting a new random number based on our logic that we had from before, and it's assigning the random number to the random variable that we just created. And that should be pretty good. So basically every time you click the button, this should be fired. It should update the state and the video should change, and it should all do so without any sort of page refresh at all. So I'll make sure I clear the cache again. And now you can see that if I click, we're getting new videos every time. So this no page reload, nothing, just random videos. We did all the logic, like it's pretty cool, right guys? So make sure you follow me on YouTube. A lot of these videos I've been teaching on there for years. I have over 100,000 people following me on YouTube. So hopefully you guys can also join me on that platform as well. I provide a lot of free content there. Let me know if you guys have any questions, and thank you for watching. Bye. All right, guys, so we are at the end of this course. So you're probably wondering, where do you go from here? Well, you've already seen how you can create components. So those components can be used for everything from header tags to navigation. React should be used as the view from within your MVC framework. So that does not mean that it's like a full-scale framework. It's not like Django. It's not like PHP. It's not anything like that. It's client-side JavaScript code. So you're going to end up using something like TypeScript to build out your React UI and components. But ultimately, your data is going to be coming from databases and network calls that you're going to be making. I have tutorials on the subject, actually how to set up stacks using things like Python and Django, available for free on YouTube. But some of my newer stuff is just exclusively on Udemy, so it is unfortunately paid for, but I have to make money somehow. So I apologize for that, but I do try to price these things right, but I have a ton of knowledge out there, like just sharing on how to set up Django and Flask, or if you want to use PHP or Python or C# or whatever it is you want to use, that is up to you. So I would recommend you guys check out my tutorials, and if you have questions, you guys can feel free to reach out to me. And then as far as the available resources, there's a ton of resources out there for TypeScript. TypeScript itself is not that strict or I think difficult of a language. After a few months, you should be pretty good to go with it for doing what you need to do. I would imagine you can get complicated, obviously, with TypeScript, but it's fairly easy. So anyway, guys, thanks for watching, and make sure you subscribe to my YouTube channel. Bye. So the reason why you want to use Gatsby.js and other static site generator technologies that have come out is it is all the buzz lately. And the reason why is that there's so many websites out there that do not need the complexities of full-scale stacks that we see with multi-tier architecture, database connections, user login, authentication, authorization, things like that. And so if you do not need that, and a lot of websites do not, like a lot of even things that might even have a contact us form, it could be possible through external resources, even with a static site generator. So the thing is that static site generators they're not the best for every type of website. So if you need user interaction, you need any sort of authentication or authorization, any sort of state management, meaning that you have some user that is using your website and they're on a journey, they're on step 3 of 4 or 5 or something like that. That's not going to be a good site for that. But if you have a static website that is just displaying content, maybe you have a spider that is going out there and researching a bunch of stock market prices, and every day you write some script that updates your static site content, and your site is updated with a new data, or maybe it's just a new page of your application so that you retain the old one. But there's different things you have to work around. Obviously, it's not like your data is going into a database for the most part, although you can still get your data from a database using a static site generator. But the thing is there's all kinds of options that you have with it, but it's not the best for every type of application. If I was trying to build any sort of thing with multiple users, if I needed some sort of administration, like backend thing where people are like a content management system, I would not use it. But you'll see in this tutorial series that you can actually use it for all kinds of different things. So you can build some really cool websites, and there's some creative workarounds too as well, if you know how to write server scripts in order to have your site appear very dynamic, even though it's static. So in order to get started with Gatsby, you're going to need a few things installed. Number one, you're going to need Git, and Git is something, especially if you're on Windows, because the project generator is going to require that, and you'll see that in a moment. But You're gonna need npm, which comes with Node, and since this is a Node static site website, then you obviously need Node. So you're gonna want to go ahead and download that. I'll have the links in the description tab. So if you're on Windows, you're obviously going to download the Windows version of this, and there's an installer there. But once you have Node installed on your machine, make sure it's actually working, and you can just pull up a command prompt, whatever operating system you're on. You should just be able to type Node, and you can see that it should type it'll pull up the Node interactive environment there. Now, finally, for this tutorial, I'm going to be using Visual Studio Code to actually write my code into, because it's very easy, it's popular, and it's open source and cross-platform. So once you have Visual Studio Code installed and opened up, you're going to want to open up to a folder where you're going to have your work put into. And I have mine in a Gatsby folder under my projects directory. So it doesn't matter where yours is, but what you want to do is you want to pull up in your terminal, you need to pull up the location to where that project is. Now, there is an awesome feature of Visual Studio Code to just go ahead and open up your command prompt. And you have to do the control plus the backtick character on your keyboard. But if you do that, it's going to open up this this terminal, so we don't have to switch between screens and things like that. So it's very convenient. Again, that's control plus the backtick character. All right, so from here, I want to go ahead and install Gatsby, and we're going to go ahead and say npm install -g and then Gatsby. And I already have mine installed, but this is going to take some time on your machine if you don't have it installed. But this is going to go ahead and download everything you need for generating Gatsby projects and things like that. So you'll see that we'll even have the ability with just installing Gatsby that way to use the command line to start up new projects using Gatsby. All right, so if everything goes well, you should have a screen that's similar to this, showing that everything was installed. There's no red characters or anything like that indicating any sort of error message, so you should be good to go. So Gatsby has a convenient command line interpreter, or command line processor that will take arguments and generate new projects and things like that. So all we have to do is actually just use the keyword Gatsby from our command prompt in our interactive terminal here for wherever we want this project to be located, and then you just have to use the new keyword, and then the next argument is going to be whatever the name of the project you want it to be called. So in this case, we're going to build a music website, and I'm going to say new music. And this is going to go ahead, and it might take some time, but you're going to see that if you're on Windows, you're going to end up getting this error message. And this is something that I was telling you about with Git. The reason why I get this error message is because my command prompt, the Windows command prompt, does not understand the Git argument. I actually have a Git bash installed on my Windows machine that I use to process any commands that require Git. So whenever I'm using Git, I'm using it through this Git bash. So that's what you're seeing here. So again, in order to be able to do that, if you're on Windows, you're going to want to go ahead and go to where the folder is located. And I didn't spell that. Is that it? Anyway, I just CD'd into the directory here, but you want to be into the directory where your project is located, and then from here you're going to use the Gatsby command because it's going to be using Git, and it understands Git from this terminal here. So Gatsby new project, and then again it's going to be called music. So this is going to take some time. It's going to have to create some projects and stuff like that. It could take up to 5 or 10 minutes, so it's not locked up to just, even if you have high-speed internet, it could take some time. So now once your Gatsby project has installed, we want to go ahead and CD into that. So we're going to CD into the music drive. And you're going to see all these files that the Gatsby project created for us, and all this is really cool. We don't have to understand all of this right now. I want to go ahead and fire up the project so that we can actually see it on our web browser. And here you can actually use this from the Git bash if you wanted to, or I could actually switch back over to my interactive terminal, which is what I'm going to do. All right, so if I go back over here, I'm going to go ahead and CD into my music folder, and I'll say Gatsby develop. And this is going to start the built-in web server, and we'll see that in just a moment here, the code and everything. But you're going to see that it's going to listen on port 8000. It should indicate that somewhere. Yeah, right here. All right, so you can see localhost. You can even click on it if you're using VS Code. You might have to control click in order to get over to it, but once you do that, you can actually see it in your browser, and we have this awesome static site. I don't know why the font is so basic on all of these static site templates, but we're going to get much better than that. So let's go ahead and take a look at some of the files that Gatsby spun up for us for this project in order to get everything working. You have your node modules folder, which is anything that you should be accustomed to for any node website, because these are all just node projects out on the web. And they're all dependencies that your project needs one way or another in order to run. You have your public folder, and this is where all your static content is going to go, like your images and icons and things like that. Your actual index, your HTML file is going to be generated by the server and passed down into one big joint. You know what I mean? With some, it's going to be all built down and passed. We'll see this in future videos. You don't have to understand how all of this stuff works right now. We'll get into it, but for right now, just keep in mind that the source is where the actual JavaScript, the actual React stuff is actually being built. So this stuff is all where your code is going to be edited, and it's all going to be compiled then for you into a working production site. Now, even static websites, unless you're going to embed images, which would probably be a bad idea because it's going to increase the size of every image by roughly 37% or so. Assuming you base64 encode it, but you are probably still going to have references to external images and things like that, so you could have a static web server set up to deliver that content. And that's what this public folder is located there for. So any sort of content that needs to come from something like that, you would want that to be there. And then you have a git ignore file, and that's where I actually want to go back to my git bash, because it's a good idea to always use git in order to track your stuff. So I'm already in my music directory. If I want to go ahead and create a new git bash, let me go ahead and I want to, the thing's always on the bottom. All right, let me see. I'm going to make this a little bit smaller so we can see. All right, so all I have to do is say git init and then dot, and this is going to go ahead and create an initial git repository here. I'm going to make this a little bit smaller so we can see. So you can see I now have a git repository, and you have a master branch checked out. So if I want to go ahead and look at that, I could say git status. I can see I have all these files here that are new, and it's detected them. So I want to go ahead and add those. I can say git add dot, and that'll go ahead get this will make them all green here. So they're all ready to be checked in to your initial commit. So we want to do our initial commit into the master branch. So I'll just say git commit, and then I need to say -m for the message, and then inside of a single quotes I'll say whatever my commit message is, and I'll say initial Gatsby commit. All right, and then when we do the git status, you can now see that we have a clean branch. If we ever needed to go back into our history, we can go back to the original structure of the project in case you messed something up, and that's why we use git. But that is optional. You don't have to continue to do that throughout this tutorial. In fact, I'm not even going to really be covering on it, but if you guys want to learn about git, I have tutorials available on both YouTube and newer stuff that's going to be coming out on Udemy that's more in depth. So make sure you guys check that out if you're interested. So luckily this already has a git ignore file for you, which is good because it's going to ignore a lot of these big files like node modules and stuff. You don't want to have to deal with that. Now, one of the things that this does have is that it makes use of Prettier, and Prettier is an extension that actually automatically reformats your code into a specific format that you want. So when you get your white space all messed up and things like that, this thing will automatically handle it. There is an extension available for Visual Studio Code, and I don't think I have it installed, so we want to go ahead and install that. And it's this one with 3.4 million downloads, so this is the one you want. And we're going to go ahead and install this because it's going to work with the existing project in order for our code to remain pretty. All right, so now that that's installed, we just have to reload it, and this will just kind of refresh Visual Studio Code. We go back here, and now Prettier should actually be able to work. There's an update here. I'm going to mess with that later. There's always an update for Visual Studio Code, it seems like. So here we have our package.json. This is where actually all the project dependencies come from. You can see everything that your project needs to run is actually in this dependency section here. You have the optional developer dependencies because clearly Prettier is not needed by end users that are viewing your website or even for the website to run. It's actually about maintaining your code and making sure that it doesn't turn into a jacked up pile of garbage. And then in here, you can see that this thing makes use of React and React DOM. React DOM is a separate project spun off from React, and I know that's confusing, but several years ago, React decided to get into mobile development, and by doing so, they wanted to split off their HTML section of what React does for HTML building and DOM manipulation and things like that. And they wanted that spun off from the actual core React project, which was more of a design philosophy that they wanted to extend into other areas, which they've done with React Native and React VR and other things like that. Now, this also makes use of GraphQL, and you're going to see in this tutorial, we're going to cover on that, but I have also tutorials that are going to be coming out specifically on GraphQL and how to make that very much more robust than what we're going to see in this tutorial, but make sure you guys are on the lookout for that as well. So another thing you may have noticed is that this is making use of package.json, and there's also Yarn. It's independent. Like, you can use either npm or Yarn, whatever your flavor of choice is. It doesn't matter. The project supports both. And in my case, I'm just going to continue to stick with npm. npm's kind of making some updates, trying to compete with some of the newer things that Yarn is doing that people are excited about. So we'll see which one wins, but both of them are suitable. Finally, the core of what Gatsby does is going to be all inside of these files here. And a lot of this stuff you actually don't need to worry about, at least right now. And then finally, I want to touch on that there is a few built-in commands. So there's the build if you just wanted to develop the project, if you build the actual project. I'm sorry. Develop is actually firing up the developer server that we saw from the previous video. And then the format is actually how you actually run the prettier project. So if you wanted your code to go ahead and get all prettified, then you're going to run that command. So how do you run those commands? You actually go to your command and you just simply say npm run and whatever the name of the script is. So this one is format. That's it. And it would go ahead and look inside your scripts folder. I would see that you have a format command, and then ultimately it's just executing this on the command line. So essentially there's really not a whole lot of difference between that and something like, wow, that's a cool noise, something like this. But yep. Hey guys, welcome back. So this video, let's go ahead and edit this this content of our website, because we wanted to make this a little bit more personal to our website, and I want to explain some of this stuff. So like I said before in the previous video, all the code that you're going to be editing for this project is really going to be in your source code for the most part. There's a lot of stuff already built in here for you, like the 404, but the interesting thing is that all these pages that you have of your app, and right now there's only 3 pages that your app has, and obviously that's why that's in the pages folder. So if you have more pages, that's where they should go. But it makes use of this layout. So if you wanted to navigate to this layout, you can actually you can right click and go to definition, and it's going to pull it up inside of here. And then you can just click on the layout and it'll take you right to where you need to go. And you can see that it's open up in the layout. And you can see here, this is all making use of React. So this course is going to require some background knowledge of React. And if you guys are new to that, I have tutorials on React that are both on YouTube and Udemy. I recommend the Udemy ones because they're more modern. But I'll teach you all about how to use React. I've actually developed React professionally for multiple years. But make sure you guys check that out for more information. Whether or not you want to do it in TypeScript or just raw JavaScript ES6, I have tutorials on both. So because I got into programming many years ago with a website, rock music website based on a rock band, I'm going to go ahead and have this be a rock music website for whatever reason. And maybe I even use my old domain name that I haven't done anything with, that I've owned for almost 10 years or so now. But either way, we're going to go ahead and just say an awesome music information website. We don't even know what this is really going to be about, but I figure it's going to be some sort of data-driven website that's going to be generating static content on like a daily basis or something. That's most likely what I'll end up doing with it. And you guys could do anything with it as well. Music, just say like rock, rap, pop, country, like all this bullcrap. All right, anyway, so we have all these keywords. Now this metadata here could be passed into your app and really, yeah, your layout, you're going to override. And some of this stuff should be probably the same, I would think, across all different types of pages that you have. But you can also add to this because there are certain pages, if you want to make use of like extensions, like, Google Analytics and, other custom meta tags that you might need. Like there's different types of custom meta tags for search engine optimization and things like that you might want to tap into. Now, if you'll notice that this data, this content is actually being fed from this GraphQL query, and right now it's just a static query, but you could actually make requests to a server to get a bunch of content if you wanted to a different server, obviously not this server, but you'll deal with cross-site header stuff, but you'll see. We'll get into more of how this GraphQL stuff works here, but this is where your data is going to be coming from. And then your data just gets plugged into these different layout. Now this children is the important part, because the children is what is actually getting rendered in all these different pages that are making use of the layout. So you can see it makes use of the layout, and then any of these DOM elements, no matter how many there are, they're going to be inserted into that children section. So you can think of it as like a render body section if you're familiar with C# and Razor syntax, or something like, a Django block content if you're familiar with that, or Jinja 2 with Flask and all that other stuff. So I'm sure you guys get the gist of that if you've ever dealt with any sort of templating systems before. This is all React code though, so I should make no mistake about that. This is all modern ES6 JavaScript writing out a JSX syntax, which is specifically built to work with the React library. So if we want to go ahead and continue to make this a little bit more custom, so instead of this hi people and all this stuff, we're just going to say, you know what, this is called, so I have this website that I've actually, the domain, it was like, it's a long story there, but it's, yeah, I'm stuck with it, unfortunately. But anyway, let's go ahead and just say a music website. So we just want some just general content in here. I want to show you guys that there is an image component. If you right click, you can go to the definition of it. Again, if you click on the actual top part here, it'll take you right to it. So you can see how this works. The placeholder is actually you can see that it's getting the value from a GraphQL query, and then it's referencing that right here. So you can see placeholder image, child image right here, fluid. So it makes sense. It goes right down there, and it says get this, which is just a spread operator, and this is, let's see, if you guys are not familiar with this is actually just spreading out an existing object. All right, so I want to show you guys how to actually throw an error message. If we start monkeying with the data of our image component here, and we take out this this query right here, and we go ahead and say, you know what, I'm just going to put in a file that's not going to be found. So we can see that it compiles correctly, no problem. But then on demand, like when we go ahead and pull that up, you can see that we're not getting a page here. And when that happens, you need to go to the console. You need to look at this. Now, this can be very, very cryptic, but you need to basically go through this and click on one of these links here, and it should take you to the approximate location of where this error message is. So you can see that it got thrown inside the core of this React project here, React error overlay, probably something to do with the image. But if we highlight over this is the stack trace. You must start at the top. So you can see in static query at image.js line 17. So start with the top. That's the problem. So we go to image line 17, and this is really important that you guys know how to debug your own programs. And you can see in line 17, this is where we got all jacked up. And why? Because we referenced a file that doesn't exist. So now if we go ahead and we add an image in here called test, or if we gave it a full path, and this is a good idea to take a moment to talk about this GraphQL. So there is an image component that is making use of a project, a separate project that we saw that was actually throwing the message. Gatsby image is a separate project. You can see that it's using GraphQL to create thumbnails. They're optimized, so it has all kinds of optimizations already built in. But you have to use the Gatsby image, but there are certain things that you have to abide by. And it says inside of here that you can see that there are certain things that you have to pass to it. So, and it says you write GraphQL query using one of the included GraphQL fragments. So I want to show you guys, if we go ahead and we change this back, there is an actual config. If we locate the config here, and you can see that the plugins that we have here is that there is a Gatsby image plugin. Where the heck is that? And it's actually right here, because what Gatsby is doing, it's actually optimizing your images, meaning resaving them and things like that. So this is important that you actually specify where your images are going to live. So this is how it knows to look for your images in the source images folder, which is inside of here. So this is where any sort of image, if you're going to add an image, you need to add it here. So this will optimize it. Now, that's only if you want to have images that your server is going to be serving up optimized yourself. You could still actually reference third-party websites, and we could do that here. So you can see this is using the image tag, which is really it's an image component, and the image component itself is actually using the Gatsby image project, and it's using the image from the Gatsby image project. I know that's confusing, but there is this GraphQL structure that you have to follow. And here, we're just going to go ahead and just change this real quick. And we'll say test.jpg. All right, so now obviously I need a test.jpg inside of here. So we're going to create a new file. In fact, I'm just going to go ahead and copy a file from the internet, a free image, like a musician image or whatever from the internet, the first one I find. So I went ahead and copied a free image in there, and if I refresh, so now I have this test.jpg file in here, and if we wanted to reference it as a as just a normal URL, we can do that using React. It's no problem. You don't have to use the image tag once again. So you would just simply use the normal image tag, giving it a source of. I need to give it a source of. Well, number one, let me just show you that if the file's there, the error message obviously goes away. And it's going to optimize it. Just 1 second. So here you go, just to show you that the server should automatically optimize your image when you inspect on it. It's doing a lot of stuff behind the scenes when this thing is being built. But luckily, it's a lot of things that you don't have to use. Now, once again, you don't have to use this image. If I wanted to just go where this image is located, which is on Wikipedia, free to use, I could just go ahead and copy the image. I'll copy the image address, and then if I go back to my source code, we will just add a normal image tag like I was about to do. And now we're going to have 2 images when we go ahead and recompile this thing. Now, another thing that I want to touch upon, this will actually give you warnings because there's ESLint enabled, or linting enabled for, I guess this is coming from Prettier actually, but no, it's ESLint. Okay, that's what I thought. All right, so anyway, it's giving you warnings and it's saying that your image tag has no alt. There should be an alt and a title probably on your image, but we're not worried about actual web standards at the moment. So if I refresh the project, you can see that there's 2 separate images. There's one that's pointing to the Wikipedia location third party, not using the plugin, and then there's one that's using the plugin that's located statically, and that one is a much more optimized image. It's going to be faster for your end users. All right, so I discussed in the previous video that our website is rather drab looking, just the fonts and everything. So you can see that the font family is being set here inside of our layout CSS file. Now you could actually replace like all of this code with like a bootstrap CSS if you wanted to, but for the most part, you probably want to start with what's in here and just start editing things as you see fit. So like, let's just say, I want the Georgia font instead, and see what kind of effect that gives. Now, as you edit your site, the server should automatically reload and start using the latest standards here. So if we look at this, we want to see where this style is coming from. So you can actually see, here's the H1 and the layout CSS, and you can see that this is where the font family is coming from. So inside of here, so if I took that off, you could see now I'm probably getting my my Georgia font, which would come from the body right here in Georgia, right here with a serif background. So anyway, you want to go through and start editing your CSS. You can do whatever you want here. I mean, you can see that all this stuff is just, it's all found inside of the CSS file that you have here. And you can just start editing over here. So everything that's inside of the layout CSS, that should be up towards the top. You can start just messing with all of this stuff. So another helpful tip is like when you're looking at something like this and you're like, well, I hate the purple background. Where is that coming from? You want to use your editor, highlight it. Over here, you can see if it says element style, then this value is being passed to a component somewhere, or a DOM element somewhere that's being set as a inline style. So what you would probably want to do is go back to your project and do a Control-Shift-F and then just paste that value in here. And you could probably see somewhere quickly that the header component here is taking in some values. There's some properties that you can pass in. Here, this is all being set statically. I probably wouldn't even do this, to be honest with you. I'd probably have more along the lines of, instead of just a div, I'd have like a component with an actual class on there. So some of this stuff is rather opinionated and shitty, but it's still okay. All right, so I want to take a moment to go over what GraphQL is, and really what this is it's a schema language for your API, and it's a service type of almost like middleware that sits between your actual application that you're building and then the communication to the backend data from where this comes from. So the problem with like any sort of complex websites, even static websites for that matter, is that your data is coming from all over the place. It's coming from multiple different databases. Sometimes it's coming from multiple different databases depending on even just an environment that the application's running in. Depending on how sophisticated things go. So it can be very, very complicated to be like, for this request, I need to go to a MongoDB, and the other one I need to go to Postgres or MySQL or something like that. Well, GraphQL actually simplifies a lot of that for you because you're just communicating from your application to the GraphQL client, and then all the complexities of where those connections are being made are actually set up in GraphQL. So it gets out of your way so that you can start developing right away. So I want to give you guys a demonstration on how to get started with GraphQL, and it can be rather daunting. It's somewhat difficult, but what I recommend is that you go to this website here on GitHub. There's all these different APIs that you can play around with, and the one that I want to play around with is going to be, since we have a music site, let's go ahead and use the Music Brains one. This is fine. Now it gives you like an example. This is a rather complex one, so let's go ahead and just get rid of that real quick. So the first thing you want to do, as you can see, that you must provide a query. So you want to go ahead and create your query. So we're going to create our query, and we can just call this whatever we want, but I'll call this test. And then as soon as you do that, like if you highlight, and I know this isn't very big, so I'll make this bigger. If you highlight over it, it immediately tells you that, okay, there's some sort of name or something that it belongs underneath test. So you need to start somewhere. So press Control, space dot, or wait, no, not space dot, control space, that's what it is. So press Control space, and you can see that there's all these different options. So this just kind of goes through, and I mean, you can query Spotify, Last.fm, whatever. In my case, I'm going to do a search, and then you can see if you highlight over search, you can see that the search query must have a selection of subfields. So anytime it says that, you want to go ahead and do a subfield, which means that you need to do another bracket, and then you highlight over the bracket, and you can see that this is expecting something as well. So you're going to do Control space, and then this is going to tell you, okay, what are you trying to do? So I'm going to be looking up an artist. Now here, artist, if you look up over this, it says artists of type connection must have a selection subfield. So we've seen that before, but it also says field artist argument query of type string is required but not provided. So anytime you're adding an argument to something, in this case, we are adding an argument to artist because it takes an argument. How do we know that? If we go over to our documentation and we start going down this query, we can see that this is the root, and then we have the search. So we're going to look down here for the search, and then we have artist. So we're going to look down here for artist, and we're going to click on that. And you're going to see that artist takes in 3 arguments. Now this one, though, you can see is required. That's why that exclamation point is there. So you have to at least provide a query. So we're going to do that, and we're going to go with my favorite band name, Bayside, which is a rather standard thing that I do. So now you can see that we satisfied that first argument, but now we have another child that we need to satisfy. So it's like you need to do something here. So Control space again, and it's like, okay, you have an option of returning nodes, which is probably what we want, which means a bunch of data elements. You could just get page info or the total count, but what we want to do, these would be important for pagination, but I want to go ahead and grab nodes that match the Bayside query. And nodes itself, you can see if we highlight over it, it says, okay, it needs subfields, so we know what to do there. Just add another set of curly braces. And then down here, you can see nodes. It's like we still don't know what it is that you want to return. When you finally get to where you want to go, and you can see here that when we finally get to where we want to go, we need to go ahead and specify just Control space. And this is where you're going to end up getting to finally the data elements that you're looking for. So it's like, okay, so with this query of Bayside, I want to return all the IDs. I want to return the name. And then is there like we'll do a country. Yeah, let's even do recordings. Let's do that. So now you can see with actually, let's not do recordings for right now. Let's just keep it right there. Let's go ahead and press play now. We can press play, and now we're getting results back that match. And in this case, this is the one that I wanted. This is a Bayside. Bayside. This is all garbage right here. And then Anthony Ranieri is the lead singer of the band Bayside up here. So this is actually returning some real good data that we need. And you can see, like, if I don't specify country, GraphQL is only going to return what it is that you want. So it's very efficient. It just returns what you need and not other stuff that you don't need. And then from there, let's go ahead and add that the recordings one. Let's actually do I'll do the recordings. Let's do recordings. So you can see recordings obviously needs some sort of sub argument. So in recordings here, now we're going to do control space, and we're going to say, I want the nodes from the recording. You can see nodes is like, okay, must have subfields. So once again, we do the curly braces anytime you run into that message. And then here you can see if we do control space, now we can start getting the ID of actual recordings. And I'm going to get the titles, and I'm going to get, I'll get the, I don't want anything that has more subs, but you guys get the point, I'm sure, from this example, how GraphQL works. Very similar to JSON. It's not that complicated. I'm not sure why people say it's so complicated, but it is something that you do have to wrap your mind around. But as you can see, this is a Bayside song that I'm looking for. Same with that. So a lot of these are actually Bayside songs. Yeah, this is a good song right here. I like that. So anyway, yeah, this is a lot of this stuff. Yeah, this is awesome. So if you want to practice querying real data, I recommend you probably do that with GraphQL before you start getting too much further into it. To try to building a website around it. Hey guys, what's up? Welcome back. All right, so in this video, I want to look at this static query, and I'm not sure if you guys have noticed this in the application, but on our layout page, we have the static query, and this is actually something new for Gatsby. It just came out in 2.0 series. And what it's doing here is it's just basically saying for one request here, go ahead and get this information that's not really going to change that often. And that's this site metadata. So where does this data come from? Behind the scenes, it's actually coming from the Gatsby config, and up here at the top, you can see this site metadata. So behind the scenes, a lot of this syncing between GraphQL and your Gatsby web server is being done for you. This data, like I said, this is commonly where like your metadata is going to sit. But in another video, we're actually going to see how to make a custom query where we're not going to use this layout the static layout query. Because this isn't something that you normally use for any sort of page level query. But you can see that's where it's getting this data, and then you go ahead and it references that data and the title, and it's also setting it on the header. So if I command line into where my project is located right now, I'm going to go ahead and run Gatsby develop. All right, so now it's running. If we go back over to the server here, and what I want to show you here is this title. So if we go ahead and we dynamically change that information, and let's go to the Gatsby config, and let me go ahead and make this a little bit smaller so you guys can see in real time. So if I go ahead and I change this title, press Control S, and you can see it's saving. So we want to go ahead and give this the music website name that this is. All right, now another thing I want to go ahead and do is, well, we're going to get to that in the future video, but here you can see in this module that the layout the layout file is actually just making this one static query config to the configuration file that we have, and you can see that the site metadata has the title that matches. So the query for GraphQL is matching up to the actual JSON data that it's actually being queried to. So I know that seems kind of confusing, but it's like, where does site metadata in the layout.js here, you can see it says here that this query right here could be arbitrary. It could be whatever you want it to be. In this case, they called it site title query. It could be whatever you want, but this site, it's basically saying go back to the site. That's where it's finding it. And then you could see site metadata, and that's where it actually can find this piece of information here. And then it references the title. And then ultimately, that's where it can be found right here. So I know that seems very confusing, but there is a lot of magic that's going on behind the scenes for you. In the next video, we'll see how to actually set up to query a database system, a local file system database. And you'll see how to make queries to that data system. And eventually this will start to click and make more sense. Hey guys, welcome back. So in this video, what I want to do is, in my source of my project, what I want to do is add a folder, and this is going to be our local database. So without having to connect to like a Postgres or a MySQL database or something like that, it's going to be a lot easier for us to have a local file system database. And we can do so just made up of a bunch of JSON files that we're then querying. And GraphQL and Gatsby has built-in support for that. So let's go ahead and look at how we can set that up. So I'm going to create a data folder for my database. And inside of here, I want to go ahead and create a JSON file, and it's going to be of a few musicians, and it's just like kind of random or whatever. But I'm going to have this file. It's going to be called artist.json. All right, and inside of here, I just need to have several musicians. So there's 3 different musicians in here inside this artist.json. Now, in order for the project to be able to actually read the contents of our data and automatically look for JSON data that matches queries inside of here, then we need to go ahead and install 2 different dependency plugins. All right, so what I need you to do is go ahead and stop your server here, and I want you to go to the command line and run npm npm install hyphen save. And the first one we're going to install is going to be called Gatsby Gatsby source file system. And that's going to allow us to be able to query our local JSON data files. And then in order for us to be able to then take that string data that's in those files and turn it to JSON objects that GraphQL and Gatsby can understand, we need to go ahead and install this project as well, which is called Gatsby Transformer JSON. All right, so hopefully you guys can read all that. Go ahead and press enter, and it should go across the web and install. It might take several minutes because they're relatively large projects, I believe. In my case, I should have. Actually, I do not have neither one of them installed, so it is going to take some time actually. All right, so now that both of those are installed, we want to go ahead and enable those, and we want to go over to our Gatsby config, and at the bottom here, let's go ahead and add a few entries. And the first one, because I don't want to mess this thing up. So I'm going to paste this in here, and if you just pause the video for a second, make sure there is a comma between this line and this one. And this is using the backtick, but it doesn't matter if you use the backtick or just a regular string. They're the same thing because it's ES6. Now, with these new plugins, let's go ahead and restart the server. All right, so maybe you guys have already jumped ahead or not, or maybe you haven't, but there's this notice that, we've been running out of localhost 8000, but there's also this other URL, this GraphQL endpoint, and this is a built-in awesome tool that we can use to actually query our database without having to write the code. And you just do that by typing --GraphQL at the end of your URL. All right, so inside of here, what we can do is we can actually make our queries going right into this, so it's pretty easy. So if we wanted to query our database, all you have to do is press Control space, and this tells you, okay, you need to do a query. Okay, so we're going to do query JSON. Actually, we need to put this inside brackets. So we're going to do one bracket, and then inside of here, we're going to say all data and JSON. Okay, and we're going to say edges. And if you want to know what's available, all you have to do is press Control space. So it would probably be helpful if I actually save the configuration file after making a change to it, and then restart the server. So that'll happen to everybody. So now that I've done that, if I go back over here and I press Control space, you're going to see that you have all these options, and we want to say all data JSON. And every sort of option you have these curly braces that you want to go one step further into it, and you can just press Control space and see, okay, I need to go into edges. And then you go Control space and okay, I need node. And then once we're down here, we can start seeing that, okay, it's reading the actual file system JSON data that we included. So let's go ahead and grab this band. And then we can grab elements from this band, and there's, we have the option of genre, biography, whatever, we have, and then genre. Well, so we'll go ahead and return all these elements, and then just press play, and you can see we're actually getting it from our data. And this is using our actual local file system data. So, depending on how complex your data is, you could have Python scripts that are just updating a file system on your server with new JSON data every so often, you know, for some new information or whatever. And you don't even need like any sort of MySQL database or anything like that. You know, just depending on how, you know, obviously you're not gonna have any sort of Facebook or anything like that, but you could have like an information-based website, even like an affiliate-based deal, where you're probably making money on a static website, like, you know, a lot of them. There's just a lot of options there. I mean, there's just a lot of options. Hey guys, so in this video, what we're going to do is go ahead and make a query from our component. And let's go into the source and into our pages inside the index.js file. So inside here, what we're going to do is we're going to pass in some data. And all we have to do is simply say data and add a query to the bottom of this, and it's going to automatically query our database. And it's really cool. I know there's a lot going on behind the scenes. This can be called whatever you want it to be, but I'm going to call it page query. And you just say GraphQL. You have to make sure you're importing it. So you're going to have to import at the top with link, also GraphQL. All right, and that's built in as part of Gatsby here. So now that we're using that, we're going to go ahead and define our GraphQL query. So use the backtick character. Inside the curly brace, this is where it starts. And this is where all you have to do is go back, copy the query, and then just let's remove this. And then inside the backtick characters, just go ahead and paste this in here. And that's the query that we want. And if we highlight all of it and press tab, it should automatically tab over for us. All right. So now that we've done that, let's go ahead and use the data inside of our component. So inside of this index page that's using the layout, what we're going to do is, I guess where this title is right here, we'll go ahead and make this some dynamic data. So inside curly braces, let's go ahead and reference this data object that we're now passing in automatically. And then here, you're going to just simply say all data JSON dot edges. And if you remember, edges had just one, it's an array, and there's only one value in there, so we'll just grab the first value. Now I know this isn't like null safe or anything like that, but we'll see in later videos how we can do that. But let's go ahead and just reference that origin, and we'll put it in the title here. And if we go back to our server, you can see that we now have the origin for the band Bayside that's now showing up dynamically. So it's pretty awesome, I know. Hey guys, what's up? So in this video, what we're going to look at is a better way to debug. Inside of our layout here, what's common is there's a shorthand with this arrow function that you can just go ahead and return on the same line. But what I want to do is actually reference the data object so I can see it. And I want to console log it. So I'm going to go ahead and put curly braces in here. So that means I need to surround the parentheses with a closing. I need to close that joint with a curly brace. Indent that a little bit. All right, so now I want to go ahead and inside at this top line before even returning anything, I'm going to console log the data. And this is a much easier way, more sane way of being able to figure out what sort of data you're actually passing to your component. So if I go to the website and I right click and inspect and I go to my console, and let's go ahead and just clear this out and we'll refresh. All right, so it looks like we are getting some sort of ES linting error. Oh, and it looks like we do have an error message here. So you can see on the line, this is a good option to talk about error messages. And if you just take a moment, I know this stuff can be daunting or whatever, but just take a moment to read because it actually kind of points right directly to what the problem is. And it'll tell you, inside this pages index.json or .js file, line 9, column or row, column 5, error expected an assignment or function call and instead saw an expression. And it looks like there is linting rules that prevents this thing from building by default that says that there can be no unused expressions. And that's a rather cryptic way. And to you beginners, you're going to be like, what the hell? And the reason for that is because now that we've included this curly brace so that I can access the data object to console log it using the window object, the return statement needs to be in here. So we need to be returning this data here, this function call. So now let's go back over to the browser and refresh, and we now have a clean console. And if we look at this data, this is the best way to take a look and see, okay, this is the data that I'm passing down. So you can see edges again. I'm like, oh, it's an array, one element in that array. So that array has one node, and that node has one element called bayside, and that bayside has a bunch of like key values of different data points. All right, so in this video, let's go ahead and look at what it takes to build a component. And since we have a band object that we're now getting back, let's go ahead and build a component that is based around that. So we're just going to call this band.js. And we're going to look at some of the stuff that we need from the header here. And I'm going to go ahead and just import all that in here because we obviously know that we need React. And we can also go ahead and copy some of this boilerplate as well. And here what I want to do is also do a return statement. Actually, I'm going to put this in curly braces, and then we'll return. But that's in case we want to access some, do some more custom code inside of there. Now this is going to complain because you need to be able to return at least something, so we could satisfy that by just passing in an empty div. We want to change the name here that we're going to call it from header. We'll call it band. Really, this shouldn't even be called band. This should be called artist. Let's go ahead and call this artist. Sorry about that. And I also want to change this to artist. And we're going to go ahead and I want to pass in an entire artist object. So we're going to say, we'll call this an artist. So how do you pass data to your component? Well, if we look at this main query, what we should do is we should take this data, all JSON, to the Bayside object, basically. And we should pass that into our music object. So let's go ahead and import our music component. Really, it's our artist component. So now that we've imported that, we can go ahead and use it. And our artist is going to take in the band object that we'll pass to it. And we want to make sure that we export this as well. So we need to say export default artist. And we also don't need a semicolon. I'm just so used to doing that. So inside of our component here, this is where we're going to reference some information. So we'll say, you know what? Origin equals band.origin. And for right now, we'll just keep it there. We don't have to get it any more complex than that. So basically, we're going to be referencing this band object that gets passed in. So let's go back to our index, and where we're using this, we're going to go ahead and pass this data in. I know this is messy here, but bear with me. What we can do is go ahead and pass in as the property, the band. And inside of the curly braces, we're going to grab everything all the way to the Bayside object here. We're going to copy that. We're going to put that inside the band. And then we're going to close this off. I'm going to remove this because I don't want that anymore. In fact, I don't even care about this music website either. And we will leave the image. So now if we go ahead and restart the server, or not restart, but just go back to your server. And you can see that we have this now dynamic data that we've passed into our component. Hey guys, what's up? Welcome back. So in this video, I just wanted to show you, I added some data to our database. And this is where you guys can branch off on your own and start messing around with whatever sort of data structures that you want that are more interesting to you. Because I think that's a big part of programming, is that you want to be programming and doing something that is actually of interest to you. So I wouldn't necessarily use the data that I'm using. I would actually go ahead and use whatever, books or whatever. The concepts are all the same though. So what I did is I went over to my artist object, and I'm now referencing this image, and I'm referencing this band image, and that's going to be coming back from the data now. So there's this image. Well, that one's missing, but this one does have an image, and that's the one we're going to be pulling back. And this one here. So let's go to our index page, and this is where we're actually making the query. And you can see that we're getting the Bayside object, but we're not getting the image. So you have to be very explicit with GraphQL about what it is that you're looking for. So I'm going to say I want that image now. And by doing so, I now get the image that I'm looking for. So GraphQL is again very explicit about, okay, you want this, so you have to specifically ask for that. Now this is where things get a little bit more interesting. So if we go to the artist, we can now go ahead and let's just start putting in some data. We'll worry about the styling a little bit more later, but let's see. In fact, I'm going to change my data one more time, and I apologize. I would much rather have an array of JSON data objects as opposed to having a bunch of key value pairs. There's really just no need for it. So I want to iterate over this, and that way we can query over the data. We can be like, okay, find me the first name that matches this or that or whatever. So having this in an array is just fine, an array of objects. So by doing something like that, if I do a query like this on my my GraphQL now, I can actually get all the actual values then for my database, and I can send that right down to my view. So I'm going to paste that query right in here. And really there's one extra curly brace there, that would be a problem. Alright, so we'll have that query right there, and now inside of our data we'll be able to pass in the first data element. And really we just have to modify this, and we're just going to pass in the first edges, which is going to be the base sideband. We also need to change this all data to all artist JSON. Alright, so if I check out the artist page now, we're getting base side, which is the first element back, and I'm missing my image here. So if I look at there's my image tag, so that's showing up just fine. So what you want to look for there is making sure that you added it to the request for GraphQL. So I'm going to go down to my query and GraphQL, and sure enough right here you can see that I'm not even asking for the image. So now that I'm asking for the image for these elements, we go back and we now have the data. Alright, so what I want to show you guys now is how to be a little bit more dynamic with our requests. So what we can do is now, I'm going to do this, it could be like slightly hacky, but alright, so we're going to go ahead and use the new URL search support. Let's see if this is actually going to work. I don't know if it's going to work or not. We're going to try. It's always good to see whether or not this actually works before I start filming, but we're going to go ahead and get the query that is going to be called, we'll just call it artist. So you pass in a query of artist, and now that we have the artist, I want to go ahead and say, so we can go ahead and loop through our data. So now we'll do a simple check to make sure that there's some value there. So if there is some value there, we're going to go ahead and create a band object. We'll just declare it. So now we're just simply going to loop over our data. So we'll say for let x equals 0, x is less than the length. So we have to get all this crap. Geez, we have to grab all that. Dot length, and then we're going to say x plus 1. So we're going to say if, then we have to reference this again. So if edges x dot node dot name equals, and this is going to be my param dot to lowercase, because I don't want to have to and we want name to be to lowercase too, so to lowercase. So that way I can do a case comparison here, and not have to worry about case actually. So if that matches, then we're going to go ahead and assign the band object. We're going to say band equals data.all artist JSON.edges x dot node, dot node. And so there's much more efficient ways of doing this, but I'm not going to worry about that right now. So let's go ahead, and with our band object here, we can go ahead and assign it and make use of it down here. So now if we go to the server and it's running and you go to the home page, we get nothing now. But if I put in a query string, I can go ahead and put in the artist query string, and I can put in the name now. And it now queries for the actual artist. So and it can even be, it's case insensitive as well, so that you can get by with that. And now we have the other artists as well. So now you can search by different artists, and what was the other one? The other one was Outcast. So that's how you can have some dynamic data, all file driven, and that's why you guys paid and subscribed to this course. All right, guys, thanks for watching. Hey guys, what up? Welcome back. So in this video, what I want to do is go ahead and use a stateful component in React, because that's where the actual strength of React is. So far, we've been using these functional components, which don't have a whole lot of state management. So if you want like click events to fire off AJAX calls, things like that, you can do all that, but you don't want to do it in this this functional control. So let's go ahead and use the class-based system that React has available to us. We're going to go ahead and say export default class, and we're going to give this the name of artist because that's the name of our class, and we're going to say extends react.create react.component. And this is going to call a super, and we're going to pass in the props. And you can just yeah, no, because this should be, that's not even right. Okay, don't even worry about that. Okay, so now we're just going to have, for right now, we're just going to have the render, and the render is going to return. I should have had it return everything that was there before. But if you guys remember correctly, it was this. To some degree, except you're going to want to change the path because what's going to end up happening is the value of band is actually going to be assigned to the props value of this artist component now that we're using the class system. And then you're going to need to reference. So it's a little bit longer to reference, but you can attach a lot more stuff to it, and you'll see the power of it in just a second. Now this is also complaining because every component needs to be surrounded with a div container. There needs to be at least one parent component that's going to be encapsulating everything inside of it. You can't have sibling components next to each other. So on this, what I want to do is show you guys the power of having this. Now I want to do an on-click event on this this button here, and we're going to say when you are clicked, you're going to say go ahead and fire your on-click method, and we'll just say click me mofo, and we'll close off this button here. And now that we have this function, let's go ahead and add it. So we're going to say on click, and we're just going to alert hello world. Now everything else should work the exact same way. So if we go over to the component now and we click on this button, we're getting the hello world. So that's how you actually get custom behavior inside of your React component. Hey guys, what's up? So in this video, what I want to do is show you guys the Gatsby built-in develop feature, because it's going to be able to save you a lot of time when you're developing. Here's a situation where I'm actually debugging something. And there's really two ways to go about it. But here you can see that, I'm debugging this this iframe issue and iframe reload issue because YouTube changed the way that you start videos at a particular time with the embed feature. But that aside, I'm actually... there's several ways that you can go about actually making changes. So the first is we're just going to put a header in the top here, and this is going to be just simple hello test. All right, so the first way to go about your changes is to run Gatsby build, and then you could go through the build process. Now some people actually like to be very methodical about doing this manually, so they can see if there's a build failure, because you'll see in a moment that we have the ability to have it watch the changes for us, but then sometimes we're not notified of an error, and we're like, why isn't this working? And then you go back to your build, you realize it didn't build, things like that. So that's why a lot of people like to manually do it. And after you build it, you then would serve it, and it's going to serve your latest code. And then you can see it hits localhost 9000. So if you control click on that, it'll actually pull it up in a browser. And then here we go. Let's go ahead and look at the artist page real quick. So here you can see hello test. So that's the first way that you can actually make changes. Now the quicker and much better way is actually to go back to your command prompt And we're going to kill this. Just make sure you're clicking inside there, press Control Y, that should kill it. And then from here, what we're going to do is say Gatsby develop. Now this built-in feature has a watch on it, so that Gatsby will be listening for your changes. You don't have to manually restart the server. Typically, this is what you want. Again, if you want 100% control, you guys figure out what you want to do, but I actually use this feature all the time. It's a lot easier. Now you're going to notice when you're in develop, though, that the URL actually changes to where this thing is starting. It's actually starting on 8,000 and not 9,000, so don't let that slip you up. So then here is the localhost 8000. If we go back to the page, we'll just we'll go back to this page. Oh crap. Yeah, we'll go back here, and then from here, what we're gonna do is you can see this hello test. So as we pull up the code, I'm gonna make this smaller, and then we're gonna go to our component. And then we'll change the title, press Control S, and then you can see that it automatically built and changed right there. So, you know, clearly that is a very beneficial feature that's going to save you a lot of time, and I'm sure that most of you guys will want to do that. Hey guys, what's up? So in this video, I want to show you how to do string concatenation, or really just any sort of expression with React inside of a JSX statement. This is JSX code, and for those familiar, this is not exactly HTML, it's not exactly JavaScript. It really is JavaScript that turns this to HTML, but the format here has to be written in a specific way, so it's JSX. So if we want to do any sort of expression, we need to go ahead and wrap that inside these curly braces. If I could actually type. My goodness. All right, so from here, what we can do is we can use template literal syntax if we wanted to, or we could just simply concatenate. So if I wanted to concatenate some more stuff on the end of the string, obviously that URL would not work, but that's how you could do a simple string concatenation. But we could also use the built-in a new template literal syntax with ES6, which gives us the ability to just inject our arguments right here without having to do a bunch of sloppy string concatenation. And here you could just simply reference your object.id and you wrap it right there. So using this this backtick template literal syntax with ES6, we can save ourselves a lot of ugliness, but this is how you do any sort of expression. So if you had to do math, like add some numbers, things like that, you could do the same thing. You just have to make sure you wrap it in these braces. So in this video, I want to touch on keys in React, and it's very important because a lot of people don't understand, but essentially it can be summed up as this. Anytime you have a list or an array of values, and songs is an array, you're going to want to use the key on the outer component that is being rendered here, because what happens is anytime that there is a list, React has no way of knowing for those elements that are in the list, it say there's 8 of them. If 2 of them got removed, elements 4 and 6, React has no way of knowing without having to re-render everything, and it doesn't actually do that for the list. So in order for it to be able to keep track and to re-render everything, if item 4 or 6 gets removed, they need to have individual unique string IDs on them. And those string IDs can be whatever you want them to be. They just have to be a string. So it could be like a string number or string whatever. But the thing is, it's just easier when you're looping over an array of elements in React to just simply use the key value that is available to you through the loop expression. And you can just assign it here. So you just say key equals key. So this is always going to have a unique value of however many elements are in the list. So, if element 0 gets removed, React's going to be smart enough to re-render the entire array of elements. But without that key, it will not do so.